Vanakkam. Very good evening to all my dear students. Welcome to each and everyone. Very good evening. Welcome to all of you. Suswagatam. Yes, my dear students. First of all, I would like to see that everyone can hear me, can see me. Is Baba audible to each and everyone or not? My dear students, I want to see hearts. Yes, your hearts indicating that yes, you can hear me, you can see me. My dear students, long time, and I know that each and everyone is really doing hard work. Definitely, your hard work is going to get converted into success. So, Suswagatam, Vanakkam, welcome to each and everyone. Wow, really awesome, really awesome, really awesome. Now, kids, before I tell you this chemical bonding, today I'm here with number of slides. Let me show you what type of slides, how much hard work I have done for you. Let me show you, kids. Let me show you this elephant. This elephant will tell you about lattice energy. Now today, how the elephant is going to tell you about lattice energy, that definitely. Now see, kids, what I have drawn, this elephant I have drawn for you, kids. See, this lazy ox, this lazy ox is going to tell you about the solubility. This lazy ox is also I have drawn. This is Titanic, this is Lazy Ox. Number of stories are there. Before I start this chemical bonding, my dear students, first of all, tell me how is the Josh? I want to see some fire in the chat section. Now see, let me show you what I have drawn. See, this is p orbital I have drawn for you, p orbital. If you're really liking, I will show you what is this p orbital. Let me show you. This is d orbital. I will tell you what is the difference in between boundary surface diagram and the orbital. Today I will tell you, kids, but I want to see the fire in the chat section. If you're really liking it, this is d orbital. I will show you how the bonding takes place and whatever the drawbacks, shortcomings given in your NCERT, I will tell you why people are unable to understand chemical bonding, and chemical bonding is the base of chemistry. Today I am going to show you, kids, today each and everything. Now see, kids, just a second. So everyone, before I start, the chemical bonding, this chemical bonding, I would like to say one thing, my dear students. As you know that the periodic table, you have shown huge respect. And I have seen that each and everything has gone directly to your hippocampus. Now, once again, before I should move towards this concept, which is known as the backbone of chemistry, the chemical bonding, hit the like button, show your attendance, show your gratitude towards Baba. I want to see, yes, everyone smash the like button. Then I'm going to tell you each and everything, my dear students, each and every point what you are going to get today on this channel, your Unacademy platform. holds a whole lot of weightage. Each and every point is really very, very important. So the notes, the slides, the tricks you will never get, and the authenticity. I have used JD Lee book, JD Lee original book, wherever the data is not correct in the given books, or whatever the channel you can search. Number of things I'm going to give you today. But my dear students, how is the Josh? I want to see Josh in the chat section. And those who are new, let me tell you, this is your HSP Baba. I have been teaching for the last 24 years. Number of students, they have got rank 1, 3, 4, AIIMS and AIIMS in NEET, J. And let me tell you, my dear student, this chemical bonding chapter is equally important for all students, whether they belong to J or they are doing the preparation for NEET. Each and every students, my dear students, let me tell you, but first of all, kids, I want to see the like button should be hit. Now, my dear students, I have done MTech in 2004, and this is you are going to appear for your NEET in 2024. My dear students, those who are new, you have to subscribe this channel. This is the best channel in the world. India is the best, and this channel is the best. Kids, first of all, let me ask one thing. I know that really, kids, you are really fully dedicated students. I can understand it will require time. Whatever I'm going to give you, my dear students, really I will give you all the things will be definitely 100% accurate without any error, zero error. But I can understand to sit for this much of time, it really requires the high willpower. Where there is a will, there is a way is an old saying, but still true. If you really think you are able, you are almost to be able. So you have to sit with constant perseverance, yes, and the mind directly gaining each and everything. First, do this promise, then only I am going to start, kids. Your consistency, your regularity, your punctuality is very, very important. First of all, I want your promise, kids. Yes, kids. Wow, Wasim sir is there, kids. Our bro is there. Is Wasim sir is there, kids? The bond, you see, this is known as the bond. Bonding is not like somebody has tied with the nut and bolt. Somebody has tied with the rope. That is not the bond. Bond means force of attraction. And this I'm going to tell you, kids, the force of attraction. And this is the only force of attraction for which we are coming to Chennai. Because Chennai students have shown us that earlier they were thinking like inorganic chemistry pedicare radu customer. What nowadays everyone is saying LL, it's Romba Sulvam. What is the meaning? Inorganic chemistry. To understand inorganic chemistry was looking like tough. You must have seen Quota Factory movie. But nowadays, our students, South students, they are saying, no, it's not tough. It's easy. Am I right, kids? So see, kids, Ambika ma'am, your HSP Baba, and the center, Wasim Bhatt sir, then Kailash sir, and Pankri ma'am. Meet India's top educators at the biggest education event in Chennai. So we are coming to Chennai, and at that place we will say Ingeva, all the students. So register now. It's, you can see December 21, 5 p.m. You know your teachers. So kids, how is the Josh? We are coming to Chennai. And there we will say, there we will have coconut water, wana, rana, mune, monu, nale, anche, are, like that. So, wana, rana, monu, nale, anche, 5 people at your place. And now, my dear students, unbox is back. Get 20% off. 20%, you know. If I say SP3, SP4, SP5 hybridization, today I'm going to tell you hybridization. So get 20% off plus up to 6 months extension on NEET UG subscription. NEET UG 2024 offer price 17,683, approximately you can say 18,000, but now it's available just for 14,000 approx. NEET UG 2025 means for class 11 students, offer price 42,000 approx, but it's now available just for 33.5, means in between 33 and 34,000. And NEET UG 2026 offer price was 6299, means 63,000, but it's available just for 50,000 approx. Now you can put code. So Baba's code is HSP10. You can apply this code and you will get gift vouchers and huge discount. Now it's the time to start. Hey, my dear students, now first thing, what is orbital? What is orbital? If I draw, my dear students, like this, see, because chemical bonding will start with the orbital, and if I draw like this, what will you say? Answer in the chat section. What will you call it? If I say 2p, now is it 2p orbital? Because the base of chemical bonding is orbital. Now if I write 2p, is this orbital, my dear students? Say yes or no. Everyone say yes or no. Is this orbital? Is this orbital? Say yes or no. I want to see kids. If your reply is not coming, that doesn't mean then between me and you, the bond will be weak. Weak bond can't do anything. So bond should be strong, and for that, your answers I need right now over there, my dear students. So my dear students, let me tell you, if you are saying this is orbital, then this is not orbital. It's wrong answer. Absolutely wrong answer. The thing which we are starting, the basic thing, the most important thing, the base is wrong. It's not an orbital. Wrong. Wrong, my dear students. Just see, how will you define an orbital? An orbital is the place around the nucleus where probability of finding electron is maximum. Orbital is the space around the nucleus where probability of finding electron is maximum, not 100%. So my dear students, this is not an orbital. So what should be the orbital? Let me tell you. If I draw like this, in the NCERT atomic structure, it is given clearly that this is surface diagram. This is being boundary surface diagram, kids. It's just the boundary surface diagram. It is boundary surface diagram. Now, what is orbital then? My dear students, if I extend it, as you go away from the nucleus, the probability of finding electron will keep on decrease. My dear students, as you go away from the nucleus, just like, have you seen honeybee? As all the honeybees are there at beehive? No. Some honeybees have gone to collect the nectar. As you have seen, studied yesterday only, nectar. If all the bees are there at the same place, that particular point, then who has gone to collect the nectar? So as you go away from that center point, the probability of finding bees will keep on decreasing. As you go away from the nucleus, the probability of finding electron will keep on decreasing. That means this yellow plus red, the yellow plus this pink, they are forming orbital. This is the orbital. And if we don't know orbital, we can't understand chemical bonding and we can't do all the questions with our brain. Let me show you. See how much hard work I have done for you. See this white pipe. Just see the white pipe. That is boundary surface diagram. Are you able to see the white pipe? Only the white pipe. See white pipe. That is boundary surface diagram. And this vehicle, you know, electron is having particle as well as wave nature. So this is orbital. You see this whole together, this white part and this feather, these feathers, they are constructing the orbital. Now let me go away. Just see. Kids, can you see the orbital? Now is it visible, kids? My dear students, can you see the orbital? Can you see the orbital? This is given in class 11th NCERT. Let me show you. If you don't know orbital, you won't be able to understand. Let me show you. It is very clearly given in your NCERT. Just a second, kids. See, kids, this is class 11th NCERT atomic structure, the first chapter. This is 1s boundary surface diagram and this is the orbital. See, as you go away from the nucleus, the probability of finding electron is decreasing because electron is vehicle. How the electron can be located at one place? No, my dear students. How the electron can be particle, how it can have well-defined boundary? No, my dear student, electron can never have well-defined boundary. This is boundary surface diagram. It's given over here. This is B is boundary surface diagram. Just see boundary surface diagram for 1s orbital. This is orbital. This is 2s. This is 2s orbital. This is boundary surface diagram for 2s. This is orbital. Clear to all of you? Is it clear? Yeah, this time I will provide all the slides. My dear students, first of all, tell me, you must be thinking, sir, what are you doing? What is this? Just tell us points quickly. My dear students, if you want to understand, if you want to get the rank, the best rank, you should know from the very, very basic. This is the base. And NCERT has in the class 11th NCERT atomic structure, NCERT has written the difference between boundary surface diagram and orbital. But all the time, when the chemical bonding chapter NCERT is writing, always they are drawing boundary surface diagram, and that's why we can never understand what's the difference between sigma and pi bond and why the pi bond is weaker than sigma bond. Okay. Now, my dear students, let me start from the very beginning. Now I am going to start. Now I am going to start, my dear students. Let's start. Bond. 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 My dear students, if the bonding is strong, that means two atoms must have combined together and they must have formed a strong bond. So, my dear students, remember that if bond energy is equal to or greater than 42 kilojoule per mole, number of types of bonds are there. Very strong bond, weak bond, very, very weak bond. Remember that bond energy should be equal to or, oh, see, this is less than. This is not the sign of greater than. See, this happens. Bond energy is greater than or equal to 42 kilojoule per mole, then the bond will be either ionic, covalent bond. It can be covalent, it can be metallic bond, or it can be coordinate bond. These four bonds are possible. Just to form these four types of bonds, at least this much of energy should be having that bond, or you can say this much of at least energy should be required to break particular bond or bonds. Now, if the bond energy is less than 42 or equal to or greater than 8 kilojoule per mole, means is equal to or greater than this but less than this, we will say it is hydrogen bond. Hydrogen bond. And even if less than this 8 kilojoule per mole, means very, very less, then we will say van der Waals forces. Van der Waals forces of attraction. Weak van der Waals forces of attraction. In this weak van der Waals forces of attraction, dipole interaction will be there. Dipole interaction. Then instantaneous dipole, Keystone forces, London forces, number of things I will tell you later on. But yes, right now our focus is this. And in this, first I will start with the ionic bond and then I will move towards covalent bond. Okay, is it clear? Now see, my dear students, if I talk about ionic bond, let's start with the ionic bonding. Ionic bond. My dear students, how the ionic bond can get formed? First of all, we should know that ionic bond is the force of attraction, electrostatic force of attraction. See how it is going to get formed. Let us suppose there is a metal Na and there is a non-metal chloride. Can you see Na's electronic configuration is 281. We have studied from the periodic table 281, 11 atomic number, and its electronic configuration is 287. Remember that, my dear student. First of all, let me take one analogy that atoms are human beings and electron is being money. Everyone, atoms being human beings and electron is like money. First of all, let me tell you this thing, then you will understand by yourself. Human beings, we know human beings, atoms, it's an electron is like money. Money, human beings like atom, and electron is like what? Electron is like money. Electron is like money. Only two things are required and the whole story will be there, my dear friends. This is the only thing we need. We can see human beings. Human beings are of three types. Metals are also of three types. Some human beings wants to donate their money, some wants to accept money, and some wants, sometimes they are donating, sometimes they are accepting money. Metalloids. Chlorine is the person who is never going to donate money, always accepting. Oxygen is gaining money from everywhere, as Wasim sir has already taught you that redox reaction. Somebody is donating, somebody is gaining. Now, my dear students, so human beings like atom, money is like electron. If you are able to understand, if you want to see this thing, if you can keep this thing in your brain, my dear student, you can understand chemistry automatically. First of all, let me know in the chat section. My dear students, first of all, then you will see how I am going to tell you chemistry. You can see human beings, but you can't see money. In everyone's pocket, there is money, but we cannot see money. We have to apply our brain. We can see sodium atom. We can see sodium atom. If somebody is saying somebody is having sodium atom, we can say, oh, it is atom. How many electrons it is having? For that, we should require brain. Suppose in my neighborhood, somebody bought one BMW car. He purchased BMW car. Everyone will say, oh, what a car. But brainy people will say, oh, he is having too much money. That's why he is able to buy that BMW car. Am I right, kids? Am I right? My dear friends, so sodium, when sodium has seen chloride, sodium is saying, oh, I want to donate one electron to you. Sodium is saying, hey, this is sodium. Sodium is saying, I want to donate one electron to you. Chloride is saying, okay, just give me that electron. I'm in need. I need that electron right now. Now see, my dear students, this is a metal. This is a metal and that is a non-metal. What do you think? What is going to happen? By donating one electron, he is going to be happy. Hey, just take my one electron. Just take my one electron. And that chloride is saying, oh, just give me one electron. Why the sodium is donating one electron? Why the chloride is gaining one electron? Because by donation of one electron, it will be having noble gas configuration. Noble gas configuration. And that will be having noble gas configuration. But my dear students, they have acquired their complete octet. Now, sodium has gained one positive charge, the electrovalency is 1, and chloride has gained 1 electron. So, yes, negative charge is 1. Now, they will live together and they will form solid crystal lattice. Now, from here, the chapter solid state arises, the lattice arises. Now, the solid state got reduced. Now solid state is no more in syllabus, but lattice is there because the lattice is really very useful. Now, my dear students, if you are able to understand by yourself that sodium and chloride, they have from the gaseous, see, this was solid, but for donation of 1 electron, it has to become gaseous. The solid must have got some heat, it must have sublimed heat of atomization, and then only it must have donated electron. 3-step process. Heat converted into gases, then ionization energy. This chloride must be in the form of Cl2. Somebody has given heat, dissociated, then gaseous atoms. Then it has gained 1 electron and it has become Cl negative. Now both together they will form solid crystal lattice and they will emit out lot of energy. That energy is known as lattice energy, my dear friends. See to it. This is lattice enthalpy. Lattice enthalpy, a quality measure of the stability of an ionic compound, is provided by its enthalpy of lattice formation and not simply by achieving octet. My dear students, what I am telling you, if we are saying that if the octet is complete, if we are thinking that is going to be stable, no, my dear students. Octet completion is one thing, but if we are talking about the ionic bond, how closer they have come, means if 2 atoms are coming, means ions, opposite ions, due to the force of attraction, this is known as, yes, electrostatic force of attraction, and due to this 2 ions of opposite charge, one being metal, another being non-metal, they were being gaseous. Now they are coming together, lot of energy they are getting, that lot of energy releasing. We have to keep our ego aside, then only we can form the bond. Means to have friendship, we have to eliminate out energy and we have to gain stability, and this is going to form a strong bond. And this strong bond depends how much energy it has released. Whatever the amount of energy is being released, that much of stability is being gained. Just like you see H2O. H2O is gaseous. H2O molecules are far away like clouds. When they are coming close together, they are forming water. And water is coming close together, it is forming ice. And ice is coming close, water molecules coming close together, they are forming iceberg. See how stable iceberg is. It has broken the Titanic, huge Titanic, which was harder than the steel, has got broken up by that H2O. That is the power of bonding, my dear friends. Everyone, exothermic reaction. So see, now if I say that Na plus gaseous ion, chloride negative gaseous ion, that means they are far away. They don't know each other. They are far away at infinity. At infinity. Infinity means what? What do you mean by infinity? For a beggar, just to purchase a car is infinity. If a rich people is having 1 lakh rupee, it's nothing. But for beggar, 1 lakh rupee, 1 crore rupee can be infinity. That means infinity means too far. Infinity doesn't mean infinity. Infinity means they are too far. They are too far. Now, due to force of attraction, electrostatic force of attraction, due to electrostatic force of attraction, they are coming together, and now they have formed the bond NaCl solid crystal lattice. What do you think? When they are coming together, they will release energy, and this energy, lot of amount of energy released. This released energy is known as lattice energy. Now, my dear students, some students must be thinking, sir, lattice energy is the required energy or the released energy? See, my dear students, let me show you. Let me show you. See to it. If I write NaCl, Na positive gaseous, Cl negative gaseous, it has formed NaCl plus lattice energy. Can I write this equation like this? Na positive gaseous, Cl negative gaseous formed NaCl and lattice energy, that is energy released. Or I can write delta H negative exothermic reaction. Or can I write like this? NaCl, the energy required, that is lattice energy, to separate Na into gaseous, Cl negative into gaseous. 1, 2, 3. 1, 2, 3. All three are correct. 1 is correct, 2 is correct. Just to let me know what you're saying. Kids, you have to answer it. If you want to get the best rank, you have to answer it. All three are correct or not? Are these three reactions correct or not? Just to let me know all three are correct or not. Yes or no? Just do let me know yes or no. I want to see your answer, my dear students. Yes or no? Just do let me know yes or no. I want to see your answer. For writing yes, you have to show thumbs up or the hearts. Thumbs up or hearts so that I can see from the distance. All are correct. Very good. Very good. Very good. Now see, a qualitative measure of the stability, of an ionic compound, is provided by its enthalpy of lattice formation. This is the statement of NCERT kits. Exactly the same statement is written in your NCERT. Is provided by its enthalpy of lattice formation, just reverse of lattice destroy, and not simply by achieving octet, and not point to be noted, my lord, not simply by achieving octet of electrons around the ionic species and gases. Is this point clear to all of you? I hope this point is clear to each and everyone. Now see, the lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous ions. Because they can give you statement and they can ask you this statement is true or false. Because of the reduced syllabus, they can make question from the NCERT lines. They can make question from the NCERT lines. Is it clear? Once it is clear, kids, show me the thumbs up. Fast, fast, fast. So that keep on showing fastly. If it is clear, show. Kids, you are too far away from me. I'm too far. But we can decrease this distance with the help of this chat. If you very fast, if you show me thumbs up, I will see, yeah, you are getting it. You are getting it. Speed is good, but I cannot leave you without taking you along with me. The speed doesn't mean anything, kids. Now, how will you find out lattice energy, kids? This is the toughest question. You just do let me know one thing. If there is Ramu, there is Sita, or there is Shamu, I can say there is Shamu, Ramu, Shamu. What do you think? Ramu and Shamu can have friendship, or Ramu can also have friendship with this huge animal of too much size, huge animal. You know, this is my drawing. I have drawn it. Baba HSP has drawn it. The Baba HSP has drawn this figure, elephant. Now, its size is less, small in size, Ramu, small size, Shamu, small size, but its big size is too much. It's very, very big, very, very big. My dear students, just to let me know who can form a bond, Ramu with Shamu, Ramu with elephant, or Shamu with elephant. Just to let me know, my dear students. Kids, size is secondary. First thing is force of attraction. Remember that. Size matters a lot. If equal size is there, better bond formation will be there. But before the size, first thing is force of attraction. Ramu, Shamu. Everyone is writing Ramu, Shamu, Ramu, Shamu. My dear students, remember that size comes on the second point. First point is what? Force of attraction. Everyone is asking about. I will give you at the last my Telegram link. First thing is force of attraction, kids. Force of attraction is very, very important. This force must be the first point and size must be the second point. You must have seen, kids, number of people, they are having friendship with an elephant. Force on the first point, size on the second point. Always keep it in your brain. Now see, kids, friendship. Elephant is a very huge animal. This is Ramu, this is Alia. Now see, lattice energy is equal to force of attraction and inversely proportional to size. Lattice energy is equal to charge, that is force of attraction, and inversely proportional to size. R is equal to R cation plus R anion. Then how friendship with elephant is possible? If size matters a lot, only if the size is the criteria, then how friendship with elephant is possible? Now see, because force, that is charge, is first prime and second is the size. That's why lattice energy is equal to Q1 into Q2 upon R. Means charge is very, very important. Is this point clear to all of you? Now, my dear students, how many of you need, how many of you want the trick so that you can do any question of this world? How many of you want trick? Show me thumbs up. How many of you need trick to do any question of lattice energy? How many of you need? Okay. So kids, First of all, do let me know, bond of equality is good or bad? Bond of equality is good or bad? Just do let me know one thing. Bond of equality. See, bonding of equality is good. If charge is remaining same, if we keep aside the charge, hey kids, if we keep aside the charge, then the bonding of equality is good. Bonding of equality is good. Now see, big cation, big anion, stable. Small cation, small anion, stable. Lattice energy is greater than hydration energy and less soluble in water. My dear students, not only lattice energy, along with lattice energy, you are going to understand solubility also. Every question based on solubility, thermal stability, lattice energy, you can do within fraction of second. Are you ready? Now see. Big stable, small stable. Now see kids. Big stable, small stable. Now see. Big small, too much difference in size of cation and anion is unstable. Then hydration energy will be greater than lattice energy, and that will be more soluble in water. Okay, is this point clear to all of you? Big is stable with big cation, big anion stable. Small cation is small anion is stable. Small cation, large anion, small cation unstable. This point is clear. Now see, as we know that lithium, sodium, potassium, rubidium, cesium, francium size is increasing. This is radioactive. Leave these elements. These are being radioactive. Francium and radium, they are being radioactive. Leave them. Beryllium, magnesium, calcium, strontium, barium. Size is increasing. The size of cations is being increasing. +1, +1, +1, +1, +1, +2, +2, +2, +2, +2. But in case of anions, how to understand who is being smaller and who is being larger? Remember that monoatomic anion like chloride, O2 negative, O2 negative, charges 2, OH negative. These are smaller anions. Chloride, hydroxide, O2 negative. And bigger anions. Any anion, if you see, if it is multiatomic, all multiatomic anions are larger, as well as this bromide and iodide. They are monoatomic, but they are also larger. Okay? These are larger: carbonate, sulfate, phosphate, chlorate, borate, phosphate, oxalate, anything. Is this clear? Is this clear, my dear students? Then we can do question C. Compare lattice energy. If whatever I taught you is that clear to all of you, then we can do question. Okay. Okay. One kid is asking, sir, OH is also having 2. Hydrogen is very small. We can ignore it. Hydrogen is very small. We can ignore it. Okay. Even if I can write nitrite, N3 negative. Hydrogen is very small, so we can ignore it. It will be considered as small only, right? Now see, are you ready for the question? Are you ready for the question? See, if I'm writing lithium, my dear student, lithium, smaller cation, chloride, smaller anion, agreed, smaller cation, smaller anion, stable. Small with small is stable. Cesium is large cation, fluoride is small anion, unstable. Unstable. So who will have maximum lattice energy? Write down If you are able to understand, write down in the chat section, out of these, who will be having maximum LIF? Very good, very good, fantastic. So the answer is LIF, NAF, KI, RBF, CF. Agreed? Agreed, my dear friends? Do let me know. Everyone agreed? This is the order for lattice energy. Now see here, the second point, barium limb sulfate, small cation, large anion. Oh, large cation, large anion. Okay. So who is stable now this time? Who is stable this time, kids? If you are able to understand, if you are really able to understand, then do let me know in the chat section who is more stable this time. So according to me, this is the stability order. This is the stability order. Agreed? Agreed? Very good, very good. Now this sodium is having one charge, one positive charge, chloride -1, 2 positive charge -1, 3 positive charge. Now they are belonging to the same period. If cation belongs to the same period in the long form of periodic table, then size is approximately same. Once the size is same, who is going to decide? Charge is going to decide, and more the charge, more is thermal stability. Sorry, lattice energy. Right now we are talking about lattice energy. Is everyone able to understand? Is everyone? If yes, it's by yourself. You have to show me the thumbs up. It's, if your reply is coming, then I can increase my speed. Otherwise, I am unable to understand whether you kids are able to understand. Automatically, you have to show me the thumbs up. And kids, smash the like button. Kids, if you're liking the tricks, if you're really liking tricks, smash the like button. If you're really enjoying, now see, thermal stability. See kids, thermal stability. That is stability against heat or temperature. In case of covalent compound, I will teach you, is directly proportional to bond energy, but in case of ionic compounds, bond of equality is good. Bond of equality is good. Once again, the same funda we have to apply, the funda which we have applied in case of lattice energy, the same funda we have to apply for thermal stability also. See, the last question, some kids are asking about last question. See, sodium, magnesium, aluminium. Sodium, magnesium, aluminium, 3 atoms belong to the same period in the long form of periodic table. That is your third period. So see, here the charge is +1. Sodium is having charge +1, +2, +3. So charge is the key factor. I hope the kid who has written is able to understand. Now see kids, bonding of equality is good. Right now I've told you that small cation, small anion is stable, large cation, large anion is stable, right? Okay. Now see, magnesium carbonate, calcium carbonate, strontium carbonate, barium carbonate. Now some kids must be thinking, sir, what is this? The same result when I am going to teach you Fajan's rule. With the Fajan's rule also you are going to get the same answer. Either you solve the question with this funda or you solve the question with this funda. Both are going to give you the same result. Right now I haven't taught you the Fajan's rule, the polarization. Once I'm going to teach you the polarization, the Fajan's rule, you will be able to understand. But right now we have to focus on bond of equality is good. All these things, just see, thermal stability is directly proportional to lattice energy generally. I'm not saying always, generally. I will tell you the exception also. So that is charge upon size. Now here is the question. Now see to it. Magnesium, small cation, this is multi-atomic, large anion, small cation, large anion, unstable. Large cation, large anion, highly stable or more stable. So kids, do let me know who is going to be the most stable if you are able to understand. Hey, if you are able to understand, do let me know who is being the most stable. Thank you. Shashadri, thank you, thank you. Oh my God. Wow. Thank you, thank you. Barium carbonate. So the thermal stability order is in this order. So the thermal stability order will be like this. And that's why, my dear students, you know very well the calcium carbonate. Taj Mahal is made up of this calcium carbonate. Do you know Taj Mahal? Shahjahan, Taj Mahal. Taj Mahal means calcium carbonate. Marble is not going to show thermal decomposition less than 1000 degrees Celsius. Means at least 1000 degrees Celsius temperature is required to break this marble. This much thermally stable, kids. Now for the second line, just see second line. This is being small cation, large anion. Here large cation, large anion. Who is going to be more stable? Fast, fast. Who is going to be more stable? Who is going to be more stable? This is going to be more stable. Wow, very good. I can see, kids. Really, really, I'm liking your answers. Really, kids. Really. That's really fantastic. Really fantastic. Now, this is being small cation, large anion, large cation, large anion. So definitely who is going to be more stable? Rubidium carbonate is going to be more stable. Now here, just see in the last one, +2, +2, +2, and oxygen is just small. That means this is being small cation, small anion. This is being large cation, small anion. So this time the stability order will get changed and it will be like this. Am I right? Am I right, kids? Do let me know, am I right or not? Everyone is able to understand or not? Do let me know, my dear students. Everyone. Hey. Till now, is it clear? Till now, my dear students, if you're liking it, show me some hearts, show me some fire. This is the trick. Baba always says, your HSP Baba always says that study smartly. Everyone is doing hard work. All the time they are learning, they're forgetting. They are learning, they're forgetting. They are revising 4 to 5 times. No need to revise 4 to 5 times. Just study with your HSP Baba and get the tricks, each and everything. Wow, I can see your love. Now, my dear students, here, these are the questions. You can see very clearly, this is a small anion, this is being a small anion, and small anion, small cation, small anion, small cation. So definitely the stability is like this. The stability is like this. But in these two, you see 4 bonds. 4 bonds, maximum stable, 1 bond. Just see, this is a small anion, small cation, small anion, small cation, small anion, small anion, small cation, small anion, but see only one bond. Here, four bonds. So definitely this is going to be more stable, kids. This is going to be more stable. In diamond, diamond is sp3 hybridized. Four bonds. One carbon is bonded with four more bonds. Sigma bond 1, 2, 3, 4. This is more stable. This is sp2 hybridized. Carbon is just bonded with 3 sigma bonds. 1 sigma, 2 sigma, 3. So only 3 bonds. So this is going to be more stable. So the stability order will be like this. I hope this is bonding of equality. Here bonding of equality, and here more number of bonds, deciding factor, and here the hybridization is deciding factor. Kids, is everyone able to understand? Everyone, kids? Graphite doesn't have resonance. In graphite, one electron is loosely bonded, that is pi electron, and that is good conductor of electricity. In graphite, there is no resonance. The electron is moving in its own orbital, right? Kids, here the bond of equality funda. Here you see carbon is forming 4 bonds, ammonia is forming 3 bonds, H2O is forming 2 bonds, and this is just forming 1 bond. If you say 1 bond, definitely if you treat one single bond of HF, then one single bond of HF will be more stronger than carbon and CH, carbon H. But you see carbon is forming 4 bonds, chlorine is just forming 1 bond. So definitely more the number of bonds formed, more exothermic reaction will be, more heat energy will get released, more will be the stability. Got it? Got it? Now, solvation and solubility. Kids, this is the thing for which everyone is dying. Everyone is searching for such type of tricks, the solubility of salts. But for this, I want to see the likes should get increased more than 400. Today I'm going to give you a trick to do any solubility, to find out the trends, increasing, decreasing order, as well as to find out whether that salt is soluble or insoluble in water. Wow, thank you, Shishadri, thank you. Okay, so everyone, yeah, now see kids. This is ox, this, and this is water. This ox is on land. This ox is on land, and this is water. And this is the boundary in between. See kids, how is the ox? Baba has drawn it. Drawing by Baba. Drawn by Baba. Drawn by Baba HSP. No one can give copyright. No one can give copyright. How's the pick? How's the pick? Kids, you can take some rest. How's the pick? Tell me, kids. Baba want to see your reply. How's the pick? How's the pick, kids? No one can give copyright to Baba because this pick This picture is drawn by Baba himself. Now see, the story moves now. Okay, if you're talking about diamond and graphite, let me tell you, my dear students, graphite is thermodynamically more stable. If you give pressure and temperature to diamond, it will require too much time, and definitely the graphite diamond will convert into graphite. The most stable form thermodynamically most stable form is graphite. Let me tell you, some students are thinking what happened, sir, graphite and diamond. If I say thermodynamically graphite is more stable, that means it will require time. It is going to take time. Thermodynamically graphite is more stable. Let me tell you, kids. Let me tell you once again. Thank you, sweetie, thank you. Let me tell you, kids, thermodynamically, graphite is more stable. The meaning of this, that diamond will one day, you know that everyone is saying हीरा सदा के लिए, in Hindi हीरा सदा के लिए, diamond is forever. In English, diamond is forever. My dear students, one day diamond will definitely convert into graphite, but it will take too much time. Not soon. Is it clear? Is it clear? Diamond is not forever. Diamond, one day, diamond will convert into graphite, but it will take many years, many years. So thermodynamically graphite is more stable, right? I hope that this is clear. Now see, kids, this is land and there is lazy ox. This is land, solid. This is state border, and that is sea, liquid. Can you see the pic? This pic, again and again I'm telling you, I don't want to make a show off that Baba has drawn. I want to feed this pic in your hippocampus. Just keep this pic in your hippocampus. There is lazy ox, and this lazy ox wants to cross this straight border and want to go to the sea. This is a lazy ox. Lazy ox wants to cross this state border and want to take a, yes, lazy ox want to go to the Titanic. He wants to have fun in Titanic. Okay. Now see, kids, everyone, but he is a lazy person. This ox is being lazy, and the one who is being lazy can't get sure success. Everyone say, can't sure success. This lazy ox, because this is being lazy, lazy ox can't get sure success. Lazy ox can't get sure success. Can't sure success. Everyone say, can't sure success. Say. Kids, fast, write down in the chat section, can't sure success. Can't sure success. Everyone say, because this is going to be the base of salt hydrolysis also. Whenever you are going to study salt hydrolysis, the new chapter which was just in for the AIIMS, and now there is no separate exam for AIIMS. At that time it was, yeah, number of questions were coming in AIIMS from the salt analysis, that is qualitative analysis, salt hydrolysis, salt analysis, salt mixture, practical chemistry, inorganic practical chemistry. Can't sure success, and you have to keep it in your brain, can't sure success. Now see the meaning of can't sure success. Can't sure success, that means he won't be able to go to that ship Titanic. CBI has done nitrate and Ox got late. CBI was thinking, hey Ox, how can you go to Titanic ship by crossing the Strait Barrier? CBI has done nitrate and Ox got late. Can't sure success. CBI has done nitrate, Ox got late. CBI has done nitrate, Ox got late. Now see, border security force, police is also there. Now these three things you have to remember. One, can't sure success. B, CBI nitrate, Ox got late. C, BSF, police. It's this, I'm not only teaching chemical bonding, I'm forming the base of salt analysis also. There are three anionic radicals, three groups. First group having 6 radicals. B group 5 radicals. C group 4 radicals. Now, if these radicals are clear in your brain, then I'm going to tell you the solubility. Everyone, first of all, I will tell you what is the meaning of can't sure success. Right now, no, I'm not going to tell you. Kids, everyone can say can't sure success. CBI nitrate, Ox got late, BSF police. BSF police. Can't sure success. CBI nitrate, Ox got late, BSF police. Kids, I'm not only teaching here. Along with teaching, I'm trying to keep everything in your hippocampus so that no need of revision. No need of revision should be there. Can't sure success. CBI nitrate, Ox got late, BSF police. Now see. C for carbonate, A for acetate, N for nitrite. Remember that it's not 8, it's 8, it's 8, it's 8. But this is nitrite. T for thiosulfate, S for sulfide, S for sulfite. Can't sure success meaning is carbonate, acetate, nitrite, thiosulfate, sulfide, sulfite, CBI nitrate, oxalate, chloride, bromide, iodide, nitrate, oxalate. Let me show you. C for meaning of C is chloride, bromide, iodide, nitrate, oxalate, borate, sulfate, fluoride, phosphate. Now, you understood? Did you understand, my dear students? Did you understand? Everyone, do let me know. CBI nitrate, oxalate, BSF police. Likhita, very good. Very good. Everyone, can't sure success. You have to keep this sequence in your brain, then only you can understand, kids. Everyone, can't sure success. CBI nitrate, Ox got late, BSF police. Can't sure success. CBI nitrate, Ox got late, BSF police. Is it clear? Now, see, only 2 got permission, means these 2 green, all, I will let you know what is the meaning of green, all red, all green, Ox got late, cross, and police, cross. Rest are green. The wherever I have added green signal, green signal, that means their salts are soluble in water. And wherever I have placed red, their salts are insoluble. First of all, do let me know you are able to understand this much. Wherever I have added green, their salts will be soluble in water, and the exceptions I will let you know. And wherever I have placed red, their salts are insoluble in water, and the exceptions I will let you know. Now see kids, if this much is clear in your brain, show me some hearts, show me some thumbs up so that I can move ahead kids. Hey everyone, show me some hearts, show me some thumbs up so that I can proceed. If this much is clear to all of you. Yes, fast, quick, kids, quick. Now see kids, see, can't sure success, CANT sure success, can't sure success, carbonate acetate nitrite, thiosulfate. Those who don't know how to write thiosulfate, if you don't know how to write thiosulfate, let me tell you kids, thiosulfate. Just write down sulfate, SO4 negative. Can you write sulfate? Once you know how to write sulfate, that everyone knows how to write sulfate. Now, just in place of one oxygen, you say this one oxygen, how many oxygens are there? 4 oxygens. So take like this, one in place of one oxygen, write down sulfur. And now how many oxygens are left? Only 3 oxygens are left, 2 negative. So combine these two sulfur, what do you get? S2O3, 2 negative. This is being thiosulfate. Is it clear? To the sulfate, just take out one oxygen, in place of one oxygen, add sulfur, and this will become thiosulfate. I hope that everyone is able to understand. So all carbonates, solubility, salts of all carbonates insoluble, salts of all acetate soluble, salts of all nitrite soluble, thiosulfate insoluble, sulfite insoluble. Now these are the exceptions. Exceptions means if they are insoluble, these are soluble. If these are soluble, they are insoluble. If these are soluble, its salt is insoluble. If it's all salts being insoluble, cross means insoluble, then these are soluble. Insoluble, then these are soluble. Insoluble, then these are soluble. Now the problem is how to remember these exceptions. How to remember these exceptions. My dear students, now are you ready to remember to keep these exceptions in your brain? Is everyone ready? Is everyone ready, kids? Kids, I want to see your reply fast. Fast reply, I want to see, kids. If you're ready. Hey, everyone, now see. See, kids. First one, hydrated aminos rubicis is disordered, no, dissolved. It's not disorder, dissolved. Oh. Dissolved in what? Dissolved. See, error-free teaching. Error-free teaching. Hydrated aminos rubicis is dissolved in water. Hydrated aminos rubicis. Where you have to focus? Aminos rubicis. What is the meaning of that? Ammonium. Amina. Amina nos rubicis. Amina nos rubicis. Just see, the trick is amina nos rubicis dissolved in water. Amina nos rubicis dissolved in water. Amina nos rubicis dissolved in water. Ag, mercury, Ag, you know. Now, Punjabi cute baby is having silver hugs. Thiosulfate. For thiosulfate, all thiosulfates are insoluble in water, but Punjabi cute baby is having silver hugs. Just see, Punjabi cute baby. See, thiosulfate, all thiosulfates are insoluble in water except Punjabi cute baby is having silver hugs. Kids, everyone, are you getting it or not? First of all, do let me know, are you getting it or not? Punjabi cute baby is having silver hugs. See, Punjabi cute baby is having silver hugs. Now, once again, Amina nos rubicis. Amina nos rubicis. Amina nos rubicis. Amina nos rubicis. Amina, just see. Amina knows, Amina, ammonium, Amina knows rubicis. Punjabi cute baby is having silver hugs. Amina knows rubicis. This I will let you know. Amina knows rubicis, Amina knows rubicis. And this I am going to tell you. This I am going to tell you. Kids, till now, is it clear? If it is clear, then tell me, kids. BSF, I will let you know. I will let you know. Sharvesh, I will let you know. But first of all, do let me know. Are you getting it? The trick is hydrated amina knows rubicis is dissolved in water. Silver hug silver. Silver hug silver. Punjabi cute baby is having silver hugs. Amina knows rubicis. Amina knows rubicis. You can make a song for it. See how the song will work. Amina knows rubicis, silver hug, silver. Punjabi cute baby is having silver hugs. Amina knows rubicis, Amina knows rubicis. Yeah, very good. Likita, very good. Everyone say Amina knows rubicis. Amina knows rubicis. Or Amina knows Rubik's. You can say Amina knows Rubik's or Rubik's, whatever you want to say. First of all, kids, do let me know the creativity. First time in this whole world, Baba HSP has not slept number of days and nights. I have given to you for this trick. I made my students of Avengers also helped me a lot. Wow. Wow, thank you, thank you. Now it's looking very good. Now I'm happy. Now I'm happy. Everyone, you can sing this song. Why to sing other songs? Just sing your song. Hydrated Amina knows rubicis, silver hugs silver. Punjabi cute baby is having silver hugs. Amina knows rubicis, Amina knows rubicis. Now sits. Here, barium, strontium, calcium is there. Now see, for this I am going to give you a trick. For this I am going to give you a trick. CA sir is doing BA. What is the trick? CA, you know, chartered accountant. CA sir is doing BA. I don't know why he is doing BA, because all the Punjabis, they were doing BA, and that's why CA sir is doing BA. Wow, thank you. CA sir is doing BA. CA sir is doing BA. CA sir is doing BA. Got it? CA sir is doing BA. Now, CBI nitrate aux got late. Everyone say CBI nitrate aux got late. Now see, all chloride, all bromide, all iodide, all nitrate are soluble in water except this oxalate. The ox was not able to cross that border. That means ox was not able to dissolve in water. That's why that is the story. All CBI nitrate oxalate are soluble except this ox. And I've told you this ox was lazy, and lazy ox was not able to cross the state border. State means solid to liquid. Oxalate is not able. Now see, PbCu, PbCuAg, PbCu. Now I'm going to give you a trick for this. Are you ready for the trick, everyone? Now see the trick. Punjabi cute bio auntie is having silver hugs. Punjabi cute bio auntie, auntie means antimony, is having silver hugs. How is this trick? All chlorides are soluble in water except Punjabi cute. Their exception was Punjabi cute baby. Here is Punjabi cute bio auntie is having silver hugs. Yeah, this is valid for JEE as well as NEET. Equally good for JEE as well as NEET. Punjabi cute bio auntie is having silver hugs. That means these chlorides are insoluble in water. If I say BiOCl, BiOCl insoluble. If I say SbOCl insoluble in water. Everyone is able to understand? Is everyone able to understand, kids? Punjabi cute bio auntie is having silver hugs. Punjabi cute silver hugs. Punjabi cute bio silver hugs. Bio plus. Bio plus. See, nitrate. In nitrate, who is an exceptional case? All nitrates are soluble except bio plus. Bio nitrate is insoluble in water. And Amina knows rubicis. Amina knows rubicis. Amina knows rubicis. Now, if this much is clear, now see, borate is not in syllabus, not required, not required. And see, sulfates, all sulfates are soluble except this, and this you know very well, and all fluorides are soluble except this, and phosphates are insoluble except amino rubicis. Again, it's getting repeated, amino rubicis. Now see the trick. This is not required, not required. Now see, sulfates, Punjabi CSR is doing BA and Punjabis are having silver hugs. All sulfates are soluble in water except CSR is doing BA, CSR is doing BA and Punjabis are having silver hugs. Fluorides are soluble in water except CSR is doing BA in Punjab. CSR is doing BA in Punjab. And amina rubicis. Amina rubicis. That means all they are soluble in water. I hope this much is clear to all of you kids. Let me have a glass of water. Kids, I think this much is clear to each and everyone. So let me take a glass of water. Okay, kids, just a second. Just a Kids, I hope this much is clear to all of you. This much is very much clear to all of you, my dear students. Now, this much I've told you which are soluble, which are insoluble. Now I'm going to tell you the trend, increasing order, decreasing order. Is everyone ready? Is everyone ready? Now see, trick, bonding of equality is good. Big cation, I've told you, small cation, lattice energy will be greater than hydration energy. And if lattice energy is greater, then the salt is less soluble in water, as already I have told you. Now see, big, stable, lattice energy is greater than hydration energy, less soluble. Small, stable, lattice energy will be greater than hydration energy. But you see, big is small, too much difference in size of cation and anion. Hydration energy is greater than lattice energy, and more will be the solubility. And these questions, frequently asked questions, number of times examiner is going to ask such type of questions. Now just see to it, kids. This already I've told you, and this is going to make fantastic use. Now it's your time. See, this is small cation, large anion, large cation, large anion. Its lattice energy is maximum. Lattice energy is maximum, and its lattice energy is minimum, right? Lattice energy is minimum. So what do you think? Which is going to be most soluble in water? Which will be maximum soluble in water, kids? If you are able to understand, very good. I can see barium carbonate. Once again, see, kids. Everyone is writing barium. Some are writing sulfate. The first one, carbonate one. Some are writing barium. Some are writing no. See, kids. This is bigger in size. This is smaller in size. Smaller, bigger, and just see, bigger and bigger, stable. Their lattice energy is more than hydration energy. If lattice energy is more, hydration energy we don't know. We cannot find out the hydration energy amount, quantity we cannot find out. We can just find out lattice energy. If lattice energy is more, then hydration energy will be less and less soluble in water. Small is small, less soluble in water. Large, less soluble in water. So large, small, hydration energy will be more because lattice energy is less. So hydration energy will be more soluble in water. Now tell me, kids, and see, carbonate, sulfate, chlorate, nitrate, all they are multi-atomic anions. Multi-atomic anion means they are bigger in size, they are smaller. Now see, kids, large cation, large anion will be stable or unstable? Stable. Small cation, large anion, unstable. This is unstable. That is stable. Who is going to be maximum soluble in water? Kids, do let me know now. Who is going to be maximum soluble in water? Very good. Now it's clear. This is the solubility order. Is everyone able to understand, my dear students? Do let me know. Is everyone able to understand? Every single child is able to understand. Do let me know, my dear students. This is the solubility order. is everyone. These are the questions. Most frequently asked questions. Number of times examiner, they have asked these questions, kids. Now clear, very good. Now see, in this one, small cation, beryllium, multi-atomic anion, multi-atomic anion, multi-atomic anion. So it is large anion, small and large, stable or unstable, small, large, unstable, unstable. Now see, large cation, large anion, stable. Stable means what? Lattice energy is greater than hydration energy. Here it is unstable. That means what? Hydration energy will be greater than lattice energy. Who is going to be maximum soluble in water, kids? Maximum soluble in water. Beryllium sulfate. Very good. Now you're getting. Now you are HSPN. Very good. That's why, kids, once I have told you all sulfates are soluble in water except barium, strontium, calcium. See, when I have given you the trick, at that time we have done the cramming, the sulfates. These sulfates were insoluble in water, but beryllium sulfate, magnesium sulfates are soluble in water because this is the solubility order. This is being the solubility order. Now, this is the trend that barium sulfate will be the least soluble or insoluble in water. Kids, first of all, do let me know everyone is able to understand. Now see, small cation, large anion, small cation, large anion, unstable, unstable. Unstable means hydration energy will be greater than lattice energy. And this is large cation, large anion, stable. And stable means what? Hydration energy will be less or lattice energy will be more than hydration energy. Kids, who is maximum soluble in water? Who is being maximum soluble in water? Do let me know. Very good, very good, very good. You got it. Kids, now do let me know how many of you are really getting it and how many of you are happy. Yes, show me the hearts and anything new you got. Then only I'm going to give you such type of tricks. Baba is continuously. See, it's not taking too much time to tell you, but how much time it would have taken to make such type of tricks. Only one thing is working at three places. Bond of equality is good. You can do any question of thermal stability, lattice energy and solubility with one trick. Bond of equality is good. Thank you, NEET aspirant. Thank you, kids. Your comments really, they are going to play very, very important role in my teaching. So don't forget to write. Don't forget to show your feelings. We can just find out lattice energy. If lattice energy is more, hydration energy is less. If hydration energy is low, we cannot find out hydration energy. So just focus on lattice energy. If lattice energy is high, hydration energy is generally low. If lattice energy is low, hydration energy is generally high. That's it. Yes, yeah. Thank you, kids. Thank you. Now see, just see, this is the diagram I have drawn. See, kids, small cation, large anion. Can you see? I tried to make a pic of it so that you can easily understand it. See kids, small cation, large anion I've drawn. See, big cation, big anion. Can you see kids? This is the picture. This is maximum stable, most stable, most stable. Can you see kids? Small cation, large anion, big, both are being big. Just try to see to it, kids. This is being big. This is also being big. This is being small. That is being big. I hope that everyone can see to it. Everyone can understand. Now, beryllium hydroxide. Hydroxide was what? This hydroxyl ion was, yes, hydroxyl ion was, yes kids, do let me know. Small anion or large anion? This was small anion, small anion. This is a small cation, small cation, small anion. And here, this is large cation and small anion. So it's, this is going to be maximum soluble in water. Solubility will be like this. Solubility is increasing, kids. Can you see? Can you see, kids? This is unstable. Now here, fluoride is small anion, small anion. Now, small anion means this is a small cation, small anion. This is a large cation, small anion. So definitely the solubility will get increased. Can you see, kids? Can you see, kids? Very good, very good, very good. Now see, these are the questions. These are the questions, and I am going to solve all the questions. But before that, everyone, if you are able to understand along with me, you have to solve these questions. Let's see, kids. Lithium nitrate, if you are able to understand, just think of it. Lithium, small cation, large anion. And this cesium nitrate, large cation, large anion. So solubility order will be like this according to me. Say yes or no. If yes, keep on showing thumbs up. If you are agreed, if everyone agreed, very good, I can see. Now chlorate, large anion, small cation, large anion. Once again, the solubility order will be like this according to me. If you are agreed, this is large, small, large, large. So once again, according to me, the solubility order will be like this. Now, small, large, large, large. Once again, the stability means solubility order will be like this. I haven't written lithium iodide here. Number of channels. You see number of YouTube channels, they have written NAF, sorry, lithium iodide, but I have left this space. Why? Because this is an exceptional case. If you see the literature in many books, many YouTube channels, they have written over here LII, but I haven't written. I will show you JD Lee book. The data I will show you over there because that is exceptional case. No, no, no. LI I will not write exceptional. This is exception. That's why I have left space exception. Now, small is small, small is small, and this space I have left because this is exception. I will show you JD Lee book. Now just see to it. If I write small cation, small anion, large cation, small anion, so the solubility order will be like this. Am I right, kids? Am I making sense? Oxide is also small, small. So once again, I am going like this. And small is small. Once again, small is small is stable. I am going like this. Agreed? Kids, everyone agreed? Do let me know. Everyone, if yes, this slide is clear to all of you. I will tell you, no, it's not insoluble. I will tell you where it will lie. I will tell you. See, before telling you these exceptions, before showing you these exceptions, do let me know everything is clear till now, kids. Very good. Last one. See, hydroxyl ion is small. So see, small cation, small anion, hydroxyl is small, OH negative is small. I've told you this is being small. So stable. This is large cation, small anion. So solubility. Bond of equality is good. Now see, kids. This book, JD Lee book. Have you heard the name? Baba has told you that in organic chemistry you must have seen the movie Quota Factory. Everyone is crying that in organic chemistry we are unable to understand. Number of times teachers starts fighting. Now see, kids, Baba is not going to talk anything in the air. Baba is meant for telling you the 100% which is true thing. JD Lee book, two types of JD Lee books are there in India. One is original and one is in the name of Indian writer. I'm not talking about the bogus type of JD Lee. I'm talking about original JD Lee. First of all, do let me know, have you heard the name of JD Lee book? And this pic I have taken from JD Lee book. See, in case of bromide, only in case of fluoride, just see lithium fluoride 0.1, 1, 15, 12.5, 24.2. In case of fluoride, there is, you can see 15, 24, 12.5. Rubidium fluoride is abnormal. Increasing, decrease, then increasing. So generally increasing. Fluoride solubility generally increases. This term can be used. Fluoride solubility of alkali metals generally increases because of rubidium fluoride exceptional. Now see, 19.6, 6.2, decreased, increased, decreased, increased, random. Chloride solubility, that's why alkali metal chloride I have never taken. See, in this chart, I have not taken chloride. They cannot ask about chloride. Now see, in case of chloride, there is too much chaos. Now see, bromide is okay. 20, 8.8, 7.6, 6.75 point. Regular behavior, this is okay. And see, that's why in my notes, I have taken bromide, lithium bromide, sodium bromide, potassium bromide, rubidium bromide, cesium bromide. See how much authentic notes are these. See kids, how much authenticity is there. In case of iodide, I left lithium. In case of fluoride, I left this one. See, rubidium. Two places I left because, see, this is the data. And in case of iodide, lithium which I have left, sodium I have left, 8.8, 8.7, 7.2, 3 point. It's generally decreasing, but this is 11.9. Sodium iodide is having exceptional behavior. So generally solubility decreases for chloride, bromide, iodide. Generally, the word is generally. They can ask with generally, they can ask with generally. Only the fluoride solubility is increasing on down the group, and all three halide solubility decreases on moving down the group. CBI solubility decreases down the group. It's now see, is this point clear to all of you? So how the examiner will ask the question? He will put generally. Generally, chloride, bromide, iodide, halide solubility decreases down the group, but fluoride of alkali metals, fluoride solubility increases down the group. Are you getting it? What I am telling you? That's why the word generally is used. If they are using generally, no problem. Got it? Everyone got it, kids? Do let me know. Everyone got it? Now let's move ahead. Exceptions. Kids, some exceptions you have to remember. Now see kids, why these are exceptions. Silver fluoride, small, then also maximum soluble in water. Beryllium is small, then also maximum soluble in water. These are the exceptions. So you have to remember small cation, small anion, but then also maximum soluble. This also, silver is common, silver is small and small, then also maximum soluble in water. So these things you have to remember. And lithium carbonate, you see this is also exception. Small cation, large anion, and here this is large cation, large anion, then also maximum soluble in water. These are the three exceptional cases you have to remember. These three cases are exceptions. Thank you, Harsh, OP, thank you. These are the only three exceptional cases. One is more there, but not in syllabus. That's why I have not written. Only these three exceptional cases you have to remember. Is it okay, kids? Is it okay? These are the only three cases. You have to keep it in your brain. Yeah, I can see. I can show you. See, this one, you are asking for this. Are you asking for this? Hey, are you asking for this? Now, my dear students, 2 hours gone. I haven't had a talk with you. So kids, till now, just do let me know. These things, these notes, you will not get anywhere. And see, already I have written those questions just to save your time. because this is a very lengthy chapter and I want to cover even a single point. I'm not going to leave even a single point, and I'm not going to give you anything wrong, 100% accurate. See, I could have given only this much. I could have given only these slides and you are comfortable with this. Everyone is comfortable that the solubility you have done the solubility and everyone is comfortable with this, isn't it? I must have written for your comfortable zone. I could have written the lithium iodide and the rubidium fluoride. I could have written, but I have not written, kids, because that would be wrong. And you see all the YT channels, they have given that only. Thank you, Jasmine. Everyone, you see anywhere, they have given here lithium iodide, they have given their rubidium, they have given, but Baba can't do that because Baba means the accuracy. This channel of Unacademy means the accuracy, 100% accuracy. And see, kids, I could have given, but I haven't given. And for this, these two things, how much hard work I have done, no one can understand. See, kids, that's why this data I'm showing you, this is very, very important. Number of times they have asked questions on this. Because of reduced syllabus, they can ask question on this. Lithium iodide. Lithium iodide. No, sodium is exception. Otherwise, this is decreasing. See, decreasing. Otherwise, decreasing. From lithium, it's lithium iodide, it's decreasing. See, where is lithium? Haven't written. Otherwise, see, lithium I have not written. Otherwise, NaI, then cesium iodide. Let me see. NaI, then cesium iodide. NaI is most soluble. NaI. See, NaI is maximum soluble and then the solubility is decreasing. Only lithium I have left. This is accurate, otherwise decreasing. See, up to here it's decreasing. Just see. Okay. Now see, these are the exceptions. Now, Ionic Radii. This is really awesome. Once again, I will show you something that 99 people, they are telling you wrong. Here, the thing I am going to tell you, 99% people, they are not giving the full or complete knowledge. Now, see, kids. See, kids. Can you see? These are in gaseous state or molten state. Can you see the size? This is the English channel, knowledge point. I know Hindi very well, but this is English channel, so I can't speak in Hindi. Hindi मुझको आती है बहुत अच्छे से, but kids, number of kids, they can't understand Hindi, so this is the English channel. Okay, now see, kids. Lithium, sodium, potassium, rubidium, cesium. This is the size in gaseous or molten state. Now the cesium is having ego of size. The cesium is saying to everyone, hey, have you seen my size? I'm the biggest, I am the biggest, I am the biggest. Now, lithium is saying, oh, cesium, I'm not that big as you, but I'm being small. I run very fast. So, lithium is having the ego of speed. He is having ego of size. He is having ego of speed. But ego is not a good thing. Ego is not a good thing because, my dear students, If you have seen crocodile, inside the water, crocodile is very killing, but outside, the lion is going to kill the crocodile. Inside the water, ox is very killing, but outside the water on land, lion is going to kill that. Inside the water, shark is very killing, but outside the water, shark is helpless. Am I right? So, the importance is of medium, the place, not who you are. Who am I is not that important. As important is where am I? Am I right or wrong? First of all, do let me know. Everyone, do let me know. Hey kids, Baba is doing that much of hard work and you are fighting for other platforms. Don't fight, kids. All teachers are very good. It is just the place from where you can get accurate knowledge and easily you can keep it in your brain. So don't fight, my dear friends. So always remember, same what I'm saying, that who am I is not that important. Where am I is much more important. That is valid for these ions also. This is saying I have got ego speed, I'm smaller in size. Cesium is saying I'm largest in size. But once they have gone, right now they are in gaseous or molten state. Now once they have ions gone for take a bath, ions have gone to take a bath. Now once they have gone inside the water, hey, what has happened? Ego, the smallest converted to largest and the largest converted to smallest. Oh my God. The one who was in gaseous state, smallest, the water converted into biggest, and the one who was biggest in size, water converted into smallest. This is the magic of Pepsi water. Pepsi water means polar protic solvent water. Pepsi water. Can you see, kids? Now see, who is responsible for all these things? Just try to understand. This is the biggest size of water, but if you compare, see, the question will come from here only. Lithium is bonded directly with 4 water molecules only, tetrahedrally, whereas cesium is bonded with 6 water molecules octahedrally. In the first layer, who is more bigger in size? In the first layer, if I talk about direct contact of water, see, the size of lithium is only this much. The size of cesium is more because cesium is bonded with more water. And why this? Let me show you. Let me show you. Let me show you. Lithium is like this. Lithium's atomic number is 3. 1s2, 2s1 and 2p0. Just see how many vacant orbitals are there. 1 and 2p0. D is not there. How many? 1s2, 2s1. So 1s2, 2s1. So 4 are vacant, and that's why 4 water molecules can form a bond. 4 water molecules, 4 H2O can form bond, and that bond is known as bond of hydration. Now if I talk about lithium, sodium, potassium, rubidium. Now if I talk about, suppose, potassium only, Potassium lies in fourth. So I will write 4s2 and 4p 0 and 3d like this. 3d is filled or not? 3d is filled of potassiums. 3d is filled or not? Do let me know. 4p is 0, 3d is also 0. So it will form, yes, S is there, P is there, D is there. So what type of bond it can form? Kids, do let me know. Do let me know. 4p is vacant, 3d is vacant, 4p, 4, 3d, number of orbitals, subshells are vacant. So it can form more bonds. It can form more bonds. And more bonds means what, kids? Now, if I write K plus, this is lithium. First of all, let me make it into ion, lithium plus. So it will be like 1s2, 2s0 and 2p also 0. How many orbitals are vacant, kids? How many orbitals? 4 low energy vacant orbitals are there. Vacant orbitals are there, kids. So 4 direct water molecules can form bond with that. Here potassium is like this. Now if I write potassium plus, then what should I write, kids? It was not 2, sorry kids. It was not 2, it is 1. Potassium is having 1, was having 1 only. 0, 0. Now 4s 0 and 4p will be 0 and 3d will be 0. So it will form octahedral bond, and that is sp3 d2. So 6 water molecules directly can form bond with this, and that's why just see to it, kids. Lithium is forming 4 bonds with direct water. In the first layer there are 4 water molecules, whereas cesium is in the first layer is having 6 water molecules. But if I talk about second layer, this is bonded with 4 more water molecules, 4 more, 4 more, 4 more. That means 4, 8, 12, 16 and 4, 20 and 5 in the outer mode, 25 water molecules. 25 water molecules, and this is having bigger size in the gaseous state, and water loves, that is hydration. Love means hydration. Water loves more the smaller one. That means this hydration will be maximum for the lithium. One lithium is bonded with approximately 25 water molecules. No need to remember, but yes, we should know. Whereas cesium is bonded 6, 1, 2, 3, 4. 6 plus 4, 10 water molecules. So overall, if you compare, this is having biggest size because of the second layer bonding, not because of the first layer bonding. In the first layer, it is just having 4 water molecules and it is having 6 water molecules. But this is bigger in size because of the second layer water molecules, kids. Are you able to understand? Everyone, could you please let me know? Could you please let me know, kids? Everyone is able to understand. Lithium, hydrated lithium is maximum in size because of more water molecules in the second layer, not in the first layer. In the first layer, lithium is directly bonded only with 4 water molecules, whereas cesium, potassium, rubidium, they all are bonded with, in the first layer, they are bonded with 6 water molecules. Not much. Okay, see, kids, those who are unable to understand, lithium is smaller in size. Just see, lithium is not having D, no D, no 2D orbital. If there is no 2D orbital, lithium is only having this vacant, this vacant, this vacant, this vacant. How many orbitals are vacant? 4. One water is going to donate one lone pair. An orbital can accommodate maximum of 2 electrons. So this lithium can form how many water molecules? Bonding, 4 water molecules bonding. That's why lithium is bonded in the first layer directly with only with 4 water molecules only. But rest of other elements, if I talk about potassium, because d orbital starts from fourth period only. In the fourth period it's 3d, in the fifth period it is 4d, in the sixth period it is 5d. So all they are having, all the potassium, rubidium, cesium, they all are having vacant d orbitals. So they are forming octahedral. That one cesium is directly bonded with 6 water molecules in the first layer. This white one is the first layer. It's this white round circle is the first layer. This white circle is the first layer. If I just talk about the first layer, then in the first layer, cesium is having more water molecules, but in the second layer, because this is having maximum charge, smallest size, it is more attracting water. So number of water molecules are there. So total 25 water molecules, they are making it biggest, and this is smaller. So anyone can ask that lithium is maximum in size in the water or polar protic solvent, that is PPS, because of second layer water molecules. Clear? Now clear, kids? Do let me know now. Is it clear? Now see, there are two things, kids. There are two things. Just see. One is ionic radii in gaseous state or molten state. Number of kids must be confused, sir. What are you saying? See, in gaseous state, this is largest in size. Gaseous state, cesium is largest in size, but in aqueous state, lithium is largest in size. Just see, this is hydrated radii, means in water. This is in water. That is in air. Can you see, kids? I don't think you are able to understand. One is the size in air. In air, the size is increasing like lithium, sodium, potassium, rubidium, cesium. Cesium is maximum size. And in water, due to hydration, maximum hydration, lithium is maximum in size. Kids, can you see? Can you understand? Oh my God. My dear students, just do let me know. Is everyone able to understand? Show me thumbs up, show me hearts if this is clear to each and everyone, kids. How are the slides? How are the slides, kids? Are you liking slides? Now see, kids. Now see, kids. Ionic mobility. First of all, let me tell you, some points. The ion, which is maximum in size, that is gaseous or molten, in water, or any other PPS means polar protect solvent, will become least in size. Now, why is this? Why it is like that, kids? Let me tell you, let me explain. This is all because hydration or solvation is inversely proportional to ionic radii. Which ionic radii I am talking about? The ionic radii which is in molten state or gaseous state. This is the third point. Or this, I can also say that water is going to do maximum bonding with smaller cations, or I can say water loves smaller cations more. Water or PPS loves smaller cations more. If I say water is the public, for example, if I say, water is the public, lithium is, tell me the name of any actress. Lithium is that actress, famous actress. Just do let me know any name of famous actress starting with L. Any famous actress, kids? Yeah, you must have seen in GOC. Any famous actress? Anushka. Yeah, but L, starting with L. Starting with Lionel Messi. Oh my God. Very tough name. Leo. Okay, let's say Leo. Now this Leo is smaller in size, like this. This is the size. Now cesium, bigger in size. Tell me any name of like this only. Chinky. Let's say Chinky. Chinky. Chinky is larger in size, but not famous. This is very famous. This is famous star. That is not famous. Now kids, right now this is bigger in size, this is smaller in size, but who is going to be more surrounded by public? Out of Leo and Chinky, who is going to be more surrounded by public? Just do let me know. Who is going to be more surrounded by public? Say, if I say this is the public, who is going to be more surrounded by public? Water is blue in color, so let me indicate public by blue. Do let me know. Leo is going to be more surrounded by public. So public will surround Leo like this. Public will surround Leo like this. Now, if anyone wants to attack on Leo, then Leo is surrounded by this much of public. Leo is surrounded by this much of public, kids. Leo is surrounded by this much of public. So no one can attack on Leo because Leo's size is like this now because of the public. Now Leo size is this much, kids. This is the size of Leo. Leo is having this much of size. And too much public is not going to surround this Chinky. Now Chinky's size is only this much. This much. Who is bigger in size? Do let me know, my dear friends. Who is bigger in size? Now do let me know, my dear friends. Kids, now you got it. Now you are able to understand that the smaller cation, because of the love of water, the smaller cation, the smaller person, because of the love of public, becomes bigger. Like Sachin Tendulkar, Rajnikant was a bus conductor, but now due to public's liking, they have become larger or bigger. Kids, everyone is able to understand now. Now everyone able to understand. So in water, this is larger in size. I hope that everyone can understand. Kids, you are asking for a break. I'm teaching you. I'm telling you, just try to understand. Everyone got it? Those who are able to understand, show me the heart so that I can move further ahead, kids. I'm unable to understand how many of you got it, how many of you are not. Those who are able to understand, show me the thumbs up and the hearts or thumbs up, anything. So that at least I should know you are able to understand or not. Wow, that's great. That's great. Wow, now you got it, got it, got it. So kids, now you are able to understand this. I was telling you that this was the smallest in air or gaseous state, and this was the largest in gaseous state. But in water or polar protic solvent, this has become biggest. Okay, due to the maximum solvation, maximum hydration, this has become largest in size because of maximum hydration, maximum solvation, maximum radii. Now this is least solvation, least radii, least solvation. In case of water, we will say hydration. If water is the solvent, we will use the word hydration. If any solvent else, we will say solvation. This is hydration or solvation. I hope that everyone. Now kids, let me tell you who will run fast. Do let me know who is going to run fast. The smaller one or the larger one? Who will be having maximum speed? Who will be having maximum speed? Ionic mobility. Ionic mobility is inversely proportional to hydrated radii. Hydrated radii, or if any other solvent is there, kids. In case of any other solvent, then I will say ionic mobility is inversely proportional to solvated radii, solvated size or radii, whatever you want to say, you can say, kids. Everyone is able to understand this thing. Just to let me know, is everyone able to understand? Everyone got it? Everyone got it? Now, just see ionic mobility at infinite dilution. Lithium aquated. Who is biggest in size? Aquated one. Lithium aquated is maximum size. This is maximum size. And this is having least size. Now, who will run fast? This will run fast. ionic mobility, this is 33.5. No need to learn the values, no need to learn, but the order you should know. This is maximum ionic mobility, and this is, oh, this is maximum size, sorry, this is maximum size. So least ionic mobility, and this is least size. Which size? Hydrated or solvated size. Hydrated, after hydration, this is the least in size. So maximum ionic mobility, is it clear? This is going to help you in your electrochemistry also. See kids, yeah, cesium will have maximum ionic mobility. Now approximate hydration number 25, 16, and see they are having almost constant. Everyone, this data I have taken from JD Lee book. My dear students, if you see in your electrochemistry, if the ion is moving fast while keeping rest of the things constant, let me talk about molar conduction, molar conductivity, then the ion who runs fast, the one who is having more ionic mobility, will be giving more conductance. So same will be the order for conductance also. This will be the order for conductance also. See, same will be the order for conductance also. This will be the order for conductance, conductivity also. See kids, conductance order also, because this is running fast, so maximum conductance also. Is it clear to all of you kids? No need to remember the values, no need. I have given you the data so that you can understand. See kids, now I am going towards Fajan's rule. I hope till now this is clear to each and everyone. Till now it is clear to each and everyone. Yeah, lithium and sodium. See, if you want to see, lithium and sodium are not constant, but here they are almost constant. 11, 10, 10, almost constant. See, 64, 67, 68, but there is huge difference in between lithium and sodium. See, 33.5, 43.5, 64, 67, 68. Kids, if you are taking break, then it will go very lengthy. Let's deal with Fajan's rule, kids. Let's deal. This is clear. So let's move towards Fajan's rule, kids. Fajan's rule. Fajan's rule says, you know, first of all, let me tell you, is there any bond which is 100% ionic? There is no bond. There is no bond, no ionic bond which is 100% ionic. What is the meaning of this? My dear students, what's the meaning of this? This is like that. If I say, have you seen any human being who is not telling a lie, who is always speaking the truth, the true words? Have you seen? The genius human being must have said one or two times the thing which is not accurate, not true. So kids, ionic compounds have some, yes. So ionic compounds shows some covalent character. And this is the point on which he was talking about who was doing research. Who? Fajan. So Fajan has given an idea about that how much covalent character or the polarization is there in a compound or the entity which is having electrostatic force of attraction. So he was just searching for the percentage of covalent character in an ionic compound. More is the polarization. Now, what is polarization? Let's see. So, Fajan was just searching, or Fajan has given an idea about covalent character in an ionic compound. Now, kids, first of all, I will tell you this point according to me, and then I will give importance to Fajan. According to me, I don't require any scientist. We ourselves are the scientist. Just apply your brain. I'm not saying that only I can think like that. Even you people can also think like that. Without giving importance to Fajan, would you like to find out which is being more covalent or which is being less covalent by yourself, by applying your brain? Just see, kids. Have faith on you. And you can do anything, kids. You can do anything. See, what I have told you, best ionic compound. Who could be the best ionic compound? The ionic compound was formed between metal and a non-metal. Just to let me know, if I go down the group like lithium, sodium, potassium, rubidium, cesium, francium, leave francium because it is being radioactive. On moving down the group, the metallic character increases or decreases? Definitely the metallic character increases. Definitely the metallic character increases. Metallic character increases. Am I right? Yes, definitely the metallic character increases. Or I can simply say, on moving down the group, the ionization energy decreases. So this metal was electron donor. This metal was electron donor. Now, kids, do let me know who can donate its electron easily. The one whose ionization energy is least. As on moving down the group, in alkali metals, the number of shells increases and the outermost electron goes far away. So it's very easy to eliminate out electron from this cesium. Leave this is being radioactive, so I'm not going to consider it, right? So least ionization energy or ionization potential. So best metal, maximum metallic. So I have taken it. So my friend is cesium. Cesium positive. I have selected cesium. That you are good, you are fit for ionic bond. Now non-metal, what do you think? The non-metal, what type of non-metal do you think is going to form very good ionic bond? The one who can easily snatch electron, whose maximum electronegative, can easily snatch electron. This is not Fajan's rule. This is not. This is HSP rule. Kids, let me write down over here. This right now what I'm telling you, it's not Fajan's rule. This is HSP's rule. Right now, whatever I'm teaching you, this is not Fajan's rule. Fajan has nothing to do with this. This is not Fajan's rule, kids. This is what? This is just HSP rule. HSP rule. Right now, this is only HSP Baba rule or Kit's rule. Simple rule. I'm not giving importance to any scientist. Kids, you can see. Now, if I say there is chloride, bromide, iodide, out of these three anions, even I can take fluoride, no problem. Who can? Already they are having negative charge. I have added. Let me write down chloride, bromide, iodide, chlorine, bromine, iodine atom. Who is maximum electronegative? Who can easily snatch electron out of these three? Just to let me know. Even I could have taken fluoride, but right now I'm not taking. Out of these three, do let me know who can easily. Chloride. So this is the best choice. Chloride. So cesium chloride, according to me, cesium chloride is maximum ionic. Maximum ionic. And according to me, lithium iodide, kids, see, lithium iodide will be maximum ionic or least ionic. Do let me know. According to you, kids, do let me know. Lithium iodide will be maximum ionic or least ionic. What do you say? What do you say, kids? Kids, do let me know. Lithium iodide will be maximum ionic or least ionic? Least ionic. Now, the one who is least ionic will have maximum covalent character. You said cesium chloride is maximum ionic. So, it will have least covalent character. Least covalent character, right? And you said this is least ionic, so maximum covalent character. It's okay. Is this point clear to all of you, kids? First of all, do let me know. Is this point clear to all of you? If you are able to understand this thing, there is no need of Fajan's rule. But I will let you know what Fajan's rule says. Then only you can understand that yes, without any application of any scientist, we can just do the things with our brain. First of all, do let me know, kids. Just show some symbol, fire or hearts, so that I can understand. And I will show you we are going to get the same result with Fajan's rules also. We will get same result with Fajan's rule also, kids. See now what Fajan said. What Fajan said, see kids. Fajan said about cation. This is, suppose I am taking cation C plus, and this is being anion. Let me show you what is polarization. First of all, let me show you polarization. Now, this is anion. This is being anion. Largest anion with maximum charge and smallest cation with the maximum charge. Just understand what I'm saying, everyone. Smallest cation with maximum charge and largest anion with maximum charge will do maximum polarization, will do or can have maximum polarization. Maximum polarization means maximum covalent character. Maximum covalent character means least ionic character. Now the question arises, what is this polarization? What is the meaning of polarization? That's the question, $1,000,000 question. What is the meaning of polarization? Let's understand what is the meaning of polarization. Polarization means to destroy or to diminish or to change the size of an ion. To change the size of an ion, this means this cation is attracting this anion's electron. In ionic bond, cation, how the cation was formed? That has donated electron and it was living happily, and anion was having electron and living happily far away or in the solid state crystal form. But in polarization, this cation is trying to withdraw its electron. See how? See how? It is de-shaping it. It is saying, hey, your electrons, I want to gain your electrons. It is de-shaping this. It is de-shaping this. Now see over here, the electrons are coming like this. The electrons are coming like this. The electrons are coming like that. Now this shape was like uniform circle, but now D-shaped. The polarization also means D-shaping, D-shaping, D-shaping of an ion. Or you can say polarization also means attraction of anionic electrons towards its self side. Now this is somewhat looking like sharing of electrons, looking like that this anion is sharing its electron to this cation, and this is the character found in covalent compounds. Now D-shaping or sharing, D-shaping, the shape is getting tilted toward this side. Now see, smallest cation and largest anion, maximum covalent character. Now see kids, let me show you. If I say keeping anion constant, keeping anion constant. Now lithium iodide, sodium iodide, potassium iodide, rubidium iodide, cesium iodide. So according to Fajan, who is having maximum covalent character? According to Fajan, who is having maximum covalent character? Do let me know, my dear student. Who is having maximum covalent character? Who is having maximum polarization? Maximum polarization. Do let me know, kids. Who is having? See, this is common. This is common to all. This is common. Now, smallest cation. Who is being smallest cation? This is being a smallest cation, right? Smallest cation, and this is common. So this is having maximum polarization. Am I right? Maximum polarization. Maximum polarization means what? Maximum covalent character. Maximum covalent character means what? Least ionic character. Least ionic character. Now, cesium iodide. Cesium iodide. This is Large cation, this is common. Large cation means least polarization, least polarization. Least polarization means least covalent character. Least covalent character means maximum ionic. Maximum ionic. Is that clear to all of you kids? Is this point clear to all of you? Now, what if I do, if I take cation common? Suppose if I take constant cation, if I take constant cation and if I change anion, that is suppose Na positive, sodium fluoride, sodium chloride, sodium bromide, sodium iodide. Now this is common. This is getting changed. Who is largest anion? This is being largest anion. This is being largest anion. So it is having maximum polarization, maximum covalent character. So least ionic. Are you getting my point, kids? Are you getting my point? Now if I change both, changing both cation and anion, let's change both cation and anion. Just try to understand. If I write lithium iodide and if I write cesium chloride, this is A, this is being B. Just do let me know who is having maximum covalent character. Maximum covalent character. Just find out maximum covalent character. Find out, kids. This is your question. Who is having maximum covalent character? I'm waiting, kids. I'm waiting for your answer. Everyone, do let me know. Maximum covalent character. I want to see your answer. Some are writing A, some are writing B. Maximum people, majority of the students are writing A. A. See, this is the smallest cation, largest anion. Smallest cation, largest anion. This is the favorite thing of Fajan's. So maximum polarization, maximum covalent character, and least ionic. And cesium is largest cation, smallest anion, least polarization. Am I right? Least polarization, least covalent, maximum ionic. Agreed, kids? Everyone agreed? Is everyone agreed, kids? Now, if everyone, because you have given the answer, according to you, the cesium chloride is maximum ionic, right? Now see, this answer we have got according to Fajan's rule, and see in the starting, without applying Fajan's rule, HSP Baba's rule, cesium chloride is maximum ionic. Without applying any rule, I've shown you or not? See, kids, this is maximum ionic and this is least ionic, means maximum covalent. Do let me know in the chat section. If agreed, show me the hearts. Without applying Fajan's rule, HSP Baba rule or public rule, approved in the starting only or not, kids, with the fundamental logics. Kids, do let me know. I want to see. I want to see what you say, kids. Smash the like button, kids, if you're liking it. This is Baba's logic. No need to follow many scientists. Just you try to become scientist. Break I will give at 9. At 9 I will give break. Kids, I will give break at 9. First break at 9 I will give you, kids, because there is too much to study, kids. Please, first of all, do let me know, kids. Please, you have to support me, kids. Too much to tell you. Too much. The valence bond theory, the hybridization, the formal charge, the banana bond, the no bond resonance, the bond order, the molecular orbital theory. Long way to go, kids. If I'm going to give you right now the break, how will I cover these things? You know where you are going to get such type of tips and tricks. Nowhere, kids. Are you with me? At 9, I will give you the first break. Hey kids, do let me know, are you with me? At 9, I'll be able to complete valence bond theory. At that time, I will give you the first break. If you are agreed, show me the hearts. Yeah, half hour break. I will try to give at 9. Yes. If you are agreed, if you are ready, show me the hearts or the thumbs up or the fire in the chat section, kids. I want to see. I'm coming to NaCl, MgCl2. I'm coming to that. Now, this thing we have cleared, we know. Now see, kids, if I say I'm having compound like this, NaCl, MgCl2, AlCl3. Now, to solve such type of questions, at least you know one thing, that in the periodic table where these elements lies, if I talk about third period, there is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Sodium, mangal, sip, chilled, argon. What is the trick for this? Sodium, mangal, sips, chilled argon. Now see, they are lying in the same period. Sodium, magnesium, aluminium, they are placed in the same period, and the element which is placed in the same period, they have approximately same size. So they have approximately same size, approx. Now kids, when the size is same, what I have told you, see, in the starting only what I have told you, smallest cation with maximum charge, I have told you, more is the charge, more will be the polarization. Now see, more is the charge, more will be polarization. So see, here is 1 plus, here is 2 plus, here is 3 plus. So which is maximum covalent in nature, kids? Do let me know which is going to be maximum covalent. The polarization or the covalent character is in this order. Agreed? Everyone agreed? Is everyone agreed, kids? The polarization. So here the charge is going to decide. Charge is a deciding factor. Now kids, this is right or wrong? Is it right or wrong? All they are having inert gas configuration. All they are having inert gas configuration. Charge is the deciding factor. Now see kids, one more point, let me tell you, the pseudo inert configuration. Have you heard this name? Pseudo inert configuration this pseudo inert configuration. Who is going to give pseudo inert configuration? That means noble gas configuration, noble gas configuration plus D10, D10. This is pseudo inert configuration. Are you able to understand kids what I'm talking about, what I'm telling you? So pseudo inert configuration, first let's find out the pseudo inert configuration, what it is. Then I will tell you that pseudo inert configuration cation will have more polarization. The cations which are having this pseudo inert configuration, cations, or better to say these cations will have more polarization, will have more polarization power. Now let's see any cation having such type of configuration. If you think about kids, if you think about copper, copper atomic number is 29, that is 3d10 4s1. This we have studied in the periodic table. Now if I write Cu plus, if I write Cu plus, what do you think its Cu plus configuration will be? Yes, 3d10 4s0, and before that you know that the pseudo inert configuration, and before that inert gas configuration or noble gas configuration is there. So this copper plus is belonging to this category. So I can write copper plus, silver plus, gold plus, and zinc. If I say zinc is having atomic number, how much? Let me write down over here. Zinc's atomic number is 30. So its configuration is 3d10 4s2. So how many electrons should I remove to make it pseudo inert? So see to it, I have to remove 2 electrons. So if I write Zn2 plus, I will be having 3d10 4s0. So this also belongs to pseudo inert configuration. So I can write zinc, cadmium, mercury, copper, silver, gold, zinc, cadmium, mercury, copper, silver, gold, zinc, cadmium, mercury. These are having pseudo inert configuration. Is it clear to all of you kids? 3d10, what I have written? 3d10 I have written, 3d10. Oh, it's slip of marker. Thank you. 10. Thank you, thank you, thank you. Priya Darshini, thank you. It was slight slip of marker. It is 10 only. It is 10 only. So I hope that everyone is able to understand that cuprous is having pseudo inert configuration and Zn2 plus, cadmium 2 plus, they are having pseudo inert configuration. Now, how to apply it? How to apply it? Now, see kids, if anyone is going to ask, if somebody is asking that we are having NaCl, we are having cuprous chloride. This can be written like this, or you can get it like this: Cu2, Cl2. must have seen it somewhere. Sandmeyer reaction, cuprous chloride, benzene diazoxide chloride was reacting with cuprous chloride to form chlorobenzene. So who is going to have more covalent character? More covalent characters. So definitely your answer will be that cuprous chloride is having more covalent character. Why? The reason is having inert gas configuration. Na plus is having inert gas, that is having pseudo inert configuration. Am I right, kids? Am I making sense? This is having inert configuration, that is having pseudo inert configuration. Kids, you got it? Do let me know, kids. Hey everyone, the Fajan's rule is done and dusted, so that I can start the new topic. If it is clear to all of you, have you got it? Then do let me know, my dear students. Is Fajan's rule very much clear to all of you, my dear students? Done and dusted. That's really fantastic. Now see, kids. Now the Baba is going to start with this awesome thing, kids, awesome thing. Let's see. I'm here with orbital valence bond theory, and this is the base. If you're able to understand it, really, I mean it. Mark my words, kids. Categorically, I'm telling you this fantastic, awesome thing, that you are going to win the race. Is everyone ready? Now see. Orbital. This valence bond theory was first light was thrown by Hitler and London attractive forces. Now see, kids, I'm asking to you only that if I say I'm having one atom, I'm having one atom and another atom, what can you think whether they are going to attract or repel? Do let me know. Is there any force of attraction, or will be there force of repulsion, or will be both? In between two atoms, this is one atom, atom number one, and that is being atom number two, or I can say this is atom A, and that is being B. This is atom A, and that is being atom B. What do you think? In between two atoms, there will be force of attraction, or there will be force of repulsion. So what can you think? Just say. So let me see what I can say. One atom definitely attracting its own electron. So atom A is attracting its own electron and atom B is attracting its own electron. First type of attractive force. Now the atom A can have attraction on atom B's electron, and atom B must be attracting atom A's electron. That means two types of forces of attraction I can see. The one atom is attracting its own electron, just like king and queen. In the movies you must have seen, in the olden days, one king was having many queens. Nowadays only one, right? Queen means Rani. In all languages, queen means Rani. In every language, queen means Rani and king means Raja. One king can have many Ranis. The king is attracting its own Rani. That king is attracting its own Rani. This king can attract another king's Rani, and this king can attract this king's Rani. Two types of attractive forces. Now you can understand. Now are you able to get it? Now this Rani and Rani, there will be repulsion, and this king and king, there will be repulsion. Two attractive forces and two repulsive forces. Are you getting my point, kids? If I say, just see to it. If I keep it like this, just to make it very simple, and that it should remain for a longer period of time, let me make two atoms, two types of atoms like this. Just see to it. One atom and another atom. In the center, this is the nucleus. This is the nucleus. And this is atom B's nucleus. This is atom A, this is atom B. And the proton is having positive charge. And this is like king number A. And this is king number B. And you know that in the orbits, who is moving in the orbits? Kids, do let me know who is moving in the orbits. So electrons are moving in the orbits. Electrons, 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 and the electrons, electrons. So this king is having love towards its own electrons, and this king can attract this king's Rani. Electron is like Rani. Electron is like Rani. Rani's Rani, also Rani, Rani B, Rani A. This king is attracting Rani A. This king is attracting Rani B also. And that king also, this king also attracting its own Rani, and it is attracting this Rani. So there are two types of attractive forces, as well as this king is having force of repulsion with this king, positive, positive. This is positive, this is positive. So force of repulsion is there. Now this Rani is repelling this Rani. There is also force of repulsion is there. Now I hope that everyone can understand it. It's now do let me know in the chat section. First of all, is everyone able to understand? Is there anything new, or this is very much clear to each and everyone? Do let me know, my dear friends. And Hitler and London, everyone is saying this concept was given by Hitler and London. Everyone is saying this concept given by Hitler and London. This is very normal, very natural, but obvious case. Of course, we know this. Now, let me show you the same thing introduced by Hitler and London. Attractive forces. It is given in NCERT. As I'm talking about NCERT, let me write down. According to NCERT. According to NCERT. These are the lines written in NCERT. According to NCERT, Hitler and London in 1927. 1927, they have given rule that attractive forces arises. It is loving its electron, it is loving its electron, Na is loving its electron, Nb is loving its electron. Hitler and London has given like this. Now, yeah, screening will be there. That I have told you in periodic table. One kid is writing, sir, screening will not be there. Priya, oh, Priya is there. Priya, this already I have explained in periodic table. Screening will be there. Now, see, this is attracting its electron. This is attractive forces. This is given in NCERT. Na, it's loving electron of B, and B is at loving. This is yellow is B, right? Just see to it. Hitler and London has given. Now, repulsive forces, plus force of repulsion, electron force of repulsion. Everyone is saying Hitler and London has given this. Now, kids, is there any need of any scientist for this? Just try to remove most of the scientists from the logical mind. Each and everything you will be able to understand. It's spammers are spamming. They're just talking about anything in the air. My dear students, if you are able to understand, keep on showing thumbs up so that I can understand. Thumbs up should not get stopped, kids. Keep on showing thumbs up. Now, I've told you all these things. Now, let's see. It's this thing. This thing is for hydrogen. Now, if I say hydrogen atom, before this, let me show you something. Let me tell you one story before this. Let me tell you one story, kids. There is one college. Just tell me. First of all, do let me know. There is one college. There is person A, name as Ramu. So let me change the name. Let me keep the name Pandu. This is Pandu. Pandu. And there is another Chinku or Chinky. This is A, that is B. A and B. Let's suppose this is A and this is B. Okay. Now do let me know what happens in college. I'm not saying in real life, may be possible. There is nothing to do with any person. All the characters taken in this right now short movie of 2 or 3 minutes are fictitious. There is no resemblance with any person who is dead or alive. So now, my dear friends, they will come, they are far away. Let's say they are far away. They are far away, far away, far away in the starting, far away. But one day they have seen each other. Now, what can happen? What can happen? Either they will not talk to each other, or they will talk to each other, or they will fight. Three possibilities are there. First thing, they will move their way, they will not talk. Second, yes, they will come and talk to each other. Third, they will fight. These are the three possibilities are there. But most probably, there's force of attraction. Force of attraction, and due to force of attraction, they will come close to each other. They will come close to each other. Now, they are close to each other. Now they are friends. They are being friends. They are being friends. They are being friends. Now, another thing, what is possible, either they are going to get married or they will remain friends. Now, once they have come together closest to each other, once they have come closest, then what do you think? Is there any other chance to come close or one day there will be fight. What do you think? This is minimum point of distance. This is the closest, and this is, you can say, most stable moment of their life. Am I right? Least energy, maximum stability. Least energy, maximum stability. Least energy means potential energy. Least potential energy, maximum stability. And then after few days, what will happen? Then after few days, what will happen? They will have strong fight. And once again, they will go far away. After fighting, now they will have fight and they will go far away. This is the life. They will go far away. This is the life. Am I right? Now they will have maximum potential energy. In this case, they will have maximum potential energy and least stability. Am I right, kids? This is the truth of life, and this is the cycle. Am I right or not? First of all, do let me know. If I'm right, just show me thumbs up. Everyone, every Tamil movie's ending. Oh my God, obviously, kids. If I'm right, if I'm 100% right, then show me the thumbs up. I want to see your thumbs up, kids. I don't want to follow any scientist. We just want to see our rule, the best rules. And smash the like button also. Smash the like button, kids. Now see, this is the diagram for hydrogen. This is hydrogen's diagram. This is hydrogen's diagram, kids. For hydrogen atom. Now see, let's start from here, but let me show you. This is diagram given at NCERT. This is indicating, the y-axis is indicating energy in kilojoule joule per mole, potential energy. This is being potential energy. And this is indicating internuclear distance. Internuclear distance. We are not going to start from there. We are going to start from here. Now see, this is zero line. If you see in NCERT, this is taken as reference, 0. Below this, negative energy, upper this, higher energy. Okay, fine, fine. If you are having NCERT, you can take the help from NCERT. Thank you, Mirthilal. Thank you. Let me tell you the page number also where it is given. If you are having NCERT, let me show you the page number also, kids, where it's been given. In my NCERT, it's given on page number. In my NCERT, it's given on page number. Where it's given. Page number 114. Wow, 114. 114. Very good. You got it? Everyone, you got it? Now see, the hydrogen atoms are far away. Two hydrogen atoms, they are being far away. These two hydrogen atoms, they are being far away. Can you see the hydrogen atoms, kids? These hydrogen atoms are far away, this hydrogen and this hydrogen. Now, they are coming close. Now, they are talking to each other. Now see, the energy is getting decreased. This line, yellow line is coming downward side. That means energy. See, upside energy is increasing, downside energy is decreasing. Energy decreasing, stability increasing. Energy decreasing, stability increasing. Now, at this point, see, this is the closest approach. They form the bond, any type of bond. I can say they got best friend or they got married. I don't know. This is the maximum stability, least energy. Energy is being least. Stability is maximum. Now, after this, they have fight and see the energy is positive energy. Positive energy means not that positive energy. That means energy increase, stability decrease. Energy increase, stability decrease. And it happens if you see clouds. Clouds can fly. They are maximum energetic but least stable. Any aeroplane can cross them. If you see iceberg, ice least energetic, but if any Titanic is going to collide, then Titanic can get destroyed. Means the ice is having least energy, maximum stability. Clouds, they are having maximum energy and least stability. This happens. Everyone is able to understand. In old NCERT 118, gets is this point clear to all of you? This is given in NCERT that hydrogen and hydrogen are over here. Now, this is the best friendship. They have formed the closest. And after this, what is happening? Either this side or this side, not better understanding than this. There will be the fight. I hope that everyone is able to understand this diagram. Now, after this, let me come to orbital. As I have told you what is orbital. Orbital is the space around the nucleus where probability of finding electron is being maximum. Now let's see, this is orbital. This I have shown you in the starting. This is boundary surface diagram and this is orbital. This is the difference, that it is having sharp boundary, but orbital cannot have sharp boundary. As you go away from the nucleus, the probability of finding electron decreases. It never stops. Now see kids, after this, if I come to P block, you see x-axis, y-axis, z-axis. Let me clear you very easily how to make it clear. Have you seen your room? Have you seen your room? Room is like this. Let me show you. Your room is like this. So this is plane. Suppose this is x-axis, this is x-axis, this is y-axis, and the height must be increasing like this. This is z-axis, upper side. Let me make it here. Let me say this is x-axis. This floor is x and y-axis. Just see x and y-axis, and upper axis is going. This is your z-axis. You can take any axis to be x, y, or z, but generally we take like this. This is z-axis, this is x-axis, this is y-axis. They are perpendicular to each other. Just see, if this is now, this is z-axis, this is x, y. Now it can be like this. Anything can be taken. I hope that all three axes is clear to all of you. Now see, if this point is clear to all of you, okay, Raki is writing, sir, try with other pen, please. Which color you are not able to see? Raki, which color you are not able to see? Now see, if I say this is x-axis, that is y-axis, this is z-axis. So orbital is on this axis, y-axis, 2py. Now going up, z-axis. Is it clear? This diagram I have taken from J.D. Lee book, the best book. Yeah, Varshike, welcome. This is for you only. Now see, kids. These are d orbitals, double dumbbelled, dxy, dyz, and dzx. Now see, all 5 orbitals means d subshells, 5 orbitals, 4 lobes, 4 lobes, 4 lobes, 4 lobes, 2 lobes like this, and this is degenerated. Can you see? And if I show you it in real, let me show you, kids. Just try to understand, then only I can show you the overlapping. This is d orbital. Can you see? This is boundary surface diagram. This is making its wavical nature. So this is d orbital. Just see to it. Everyone do let me know. Can you see to it? The pipe 1 is showing this pipe. This pipe is showing the boundary surface diagram, and these fibers, peacock feather, is indicating its wavical nature. Can you see, kids? Can you see, kids? This is d orbital, d orbital. Now, if I keep like this is dxy, dxy. Now, if I keep it like this is the xz. Now, if I keep it like this is dyz. Right now, this is dxy. Just see, this is dxy in the plane of this surface, dxy, dxz. I can keep it like this, dxz. If I keep it like this, dyz. Can you see, kids? Generally, Latharika, generally stability and energy, they are inversely proportional. Now see, kids, let me show you p orbital also. Before this is d. Now this was p. See, if I say 2px, it was 2px. If I say this is 2px, this is 2py, and if I keep it like this, 2pz, it's everyone is able to understand. 2px, the boundary surface diagram, and along with this wavical nature, these are the waves. Wavical nature, you know, orbital is having psi, Schrodinger wave equation, psi. Are you getting my dx square, dy square like that? Del square psi upon del x square, del square psi upon del y square, del square psi upon del z square plus pi square like that, e minus v psi is equal to 0. So this is wavical function. So waves. Clear to all of you? Okay. Now see, if these points are clear, now kids, just one mosquito is there. See, it is doing resonance. I will teach you resonance. If mosquito is flying, it is moving, it is delocalized, can't be killed easily. Now, my dear students, if there are 2 orbitals, what can happen? Either they can come together to do friendship, or they can fight, they will become enemy, or third thing is that they will move silently, neither friendship nor fight. Are you getting my point? If there are 2 orbitals, what can happen? In between 2 orbital number 1, orbital 1, orbital number 2, what can happen, kids? In between 2 orbitals, what are the possibilities? Always 3 possibilities are there, my dear friends. Always there are three possibilities. What are they? They can combine together, that is known as bonding. Positive, that is friendship. They can do friendship. This positive means they can do friendship. Some people call it bonding molecular orbital. Some people call it bonding molecular orbital. That is BMO. Some people call it in phase. In phase. Some people call it, if you study physics, physics people will call it constructive overlapping. Constructive overlapping. Physics people will call it constructive overlapping. Am I right, kids? Constructive overlapping. Now, if they are fighting, what do you call it? If there is a fight, you will say anti-bonding molecular orbital, anti-bonding molecular orbital, and fight anti-bonding molecular orbital, or you will say out of phase, or you can say, physics people will say destructive mind, destructive overlapping. Now, my dear students, if there is friendship, stability is going to increase. Stability will increase. Stability will increase and energy will decrease. Energy will decrease. In fight, energy will increase and stability will decrease. Am I right, kids? Now, this valence bond theory, orbital overlap, it's very clear. Are you getting it? Any scientist is required, or we can understand it clearly? First of all, do let me know. I will give break at 9. I've already told you. Sir, positive means fight. No fight. Friendship. This is positive means overlapping, good overlapping. Good overlapping. Positive means be positive. Be positive. It's not the charge. It means bonding. Positive means bonding. This means bonding. Okay, positive is not the charge. Positive means having positive approach, likeness, liking. This means liking. Same frequency, same mind. Both are having same mind, same frequency, same likeness. Are you getting my point? They are having opposite likeness. Are you getting my point? First of all, do let me know. Are you getting my point, kids? Do let me know. Hey, everyone, do let me know. This thing is clear, then I can move ahead. Hey, kids. Got it. Okay. Now see. Kids, now I want to tell you one thing. An orbital of p orbital is having two lobes. First, coming toward this, let me tell you, otherwise you won't be able to understand. One p orbital is made up of two lobes. Let me show you. This is p orbital. It is having two lobes. One lobe, second lobe. Are you getting my point? Let me show you in theory. Let me show you this thing in theory. Otherwise, you won't be able to understand, kids. S is spherical. If I talk about S is being spherical. It is being spherical. Symmetric distribution of electrons. spherical symmetric distribution of electron. If I talk about P, if I talk about P is like this, dumbbell shaped. At this point, there is no probability of finding electron. This is note. This is note. No probability of finding electron. These are the two lobes of one orbital. Suppose if I say this is x-axis, if I say this is internuclear axis, this is being internuclear axis. You can take either x-axis or y-axis or z-axis. So these are the two lobes of one orbital. One lobe, second lobe. These are the two lobes of an orbital. Which orbital? That is p orbital. Clear to all of you? Two lobes are making one p orbital. That means one p orbital is made up of two lobes. Is it clear to all of you? First of all, now everyone, is it clear? Now clear. Then these are orbital. Who made these orbitals? Just like if I say there is mosquito, there is being mosquito, and mosquito is moving like this. Sometimes mosquito is over here, sometimes only one mosquito, sometimes over here, sometimes over here, sometimes over here. It's moving like this. This is the path of mosquito. That mosquito is making this path, and this is only one or two mosquitoes. They are moving like this. And this path is made by mosquito. That mosquito is over here, electron. So electron is moving and making path, and this path is known as orbital. Here the mosquito is moving like this, and this is the path of the mosquito. It is moving like this. We call it spherical, we call it S. Here we call it P. If this much is clear, then we can understand that you can treat one orbital like a person, like one person. Now, suppose I am HSP. I'm HSP. Sometimes I'm thinking positive, that is going to be the constructive. Sometimes I'm thinking negative, that can be destructive. Everyone is having two types of minds, constructive, destructive. Now see, if I tell you like there is a river, if I say there is ocean, if I say there is ocean, have you seen ocean? Sea. Have you seen sea? If I say there is sea, those who have seen the sea water is moving like this. Sometimes the waves are, suppose if the river is moving like this, if the river is moving like this, plane, river is like this, plane. River follows this path. River follows this path, like this planar path. This is the path of river. River flow. River moves like this. River water. River water moves like this. But if I say sea water moves like this. Going up, going down, then going up, then going down. And we call it waves. Sea water is having wavical nature. Am I right, kids? Do let me know. Sea water is having wavical nature. Wavical nature. Now, this wave we call it positive, and this wave we call it negative. What do you think? It is having negative energy? No. One side we have taken positive, another side we have taken negative. We could also have said like this. This is going up, up. This is going down, This is going towards sky. We can also say towards sky. This will say going down, anything we can call it. It's the two things, just like we are saying plus and minus, the electron, if it is forming wave like this, electron is vehicle, electron is particle, electron is being particle, electron is being wave. So electron is vehicle. So electron also moves like this. And if I talk about electron shell, so if I talk about this shell, one side we are going to take it positive, another side we are going to take it negative. Are you getting my point, kids? There is nothing positive, nothing negative. What we can say, one side positive, one side negative, we can call like this, or we can do the different colors. See, we can draw it like this, one side like this, can change the color. That doesn't mean that positive, negative, that lobes are going to be positive, negative. This is just the indication. We can call it positive. If we said this is positive, we can call this to be negative. We can say this to be the positive. This will be negative. Nothing, no positive, negative. It's not like energy. Now, this is just the indication. We can change the color. We can write anything else. Everyone, are you getting my point? This thing is clear to all of you, first of all. If this thing is clear, then we can understand this thing. Now see, this is given an NCERT. This diagram I have taken from NCERT. Exactly the same diagram given in NCERT. So if everyone is ready for it, everyone is able to understand it, that's meaning of plus minus or change of color, at least show me the thumbs up and smash the like button, kids. Everyone, you can show your love towards your Baba HSP, kids. I want to see this much hard work Baba is doing, this much hard work even you are doing, kids. Even you kids are really doing hard work. My dear students, now let me tell you. See, this is one lobe. Plus and plus, the bonding has taken place. Bonding. This is bonding. This is known as bonding. Bonding has taken place. See, kids. Because plus and plus, they have combined. This is constructive overlapping, and negative are far away. Now, on the other hand, if I take this blue one on this side and green one on this side, either I can indicate plus minus or I can indicate blue and green. It's not necessary that I should show green and blue, plus and minus. That means opposite lobes, they are interacting. So this is not bonding or anti-bonding, negative, this means not bonding. First one, if you are able to understand, then see, this is S and this is P. In between P and S, this is being P, this is being S. Positive, positive. But if the negative, positive, not bonding, this is being bonding, that is being not bonding or negative bonding. Everyone is able to understand. Now see, plus plus. Now they are forming bond like this. What do you call it? What do you call it, kids? This is internuclear axis. If I say this is Z axis, and they are moving up and down, pi bond. Plus plus, bonding is possible. Plus minus, no bonding or negative bonding. Everyone, kids, Now, if I show you like this, now plus plus by p by p by plus plus bonding plus minus not bonding. Everyone is able to understand, my dear students. See how much hard work Baba has done. Can you see, kids? If I'm going to draw these structures, if I would have drawn this structure in the class, how much time they have taken? How much time they have taken, kids? Now, orbital overlap concept. Zero overlap. See, this S is saying, hey, I want to make bond in the middle. In the middle, there is no electron. P is saying, here no electron is present. P is saying, P says, here, this is my node. This is my node. What are you doing over here? No electron. No electron present. You have come with your electron. I don't have electron at this place. I have electron over here. I have electron over here. What are you doing here? No bonding. Zero overlap. Now see, this is px. This is px. So pi bond. See, pi bond can get formed like this. If two p orbitals are like this, the bonding is possible. If two orbitals are like this, p orbitals, bonding is possible. If two orbitals are like this, then also bonding possible. But one orbital is like this and one orbital is like this or like this, bonding is not possible. Are you getting my point? This is px, this is py. Even though negative negative are close to each other, plus plus, but this is like this and that is going like this, bonding is not possible. Are you getting my point, kids? Everyone, if this much you have understood, then see sigma bond and pi bond. I am going to show you sigma and pi bond, kids. If this much you are able to understand, kids, now we have reached to sigma and pi bond and just 4 minutes are left for the break. Kids, hey kids, 4 minutes are left, and in this 4 minutes, I will try to tell you sigma and pi bond with some questions also. Now see, S, they are combining together. S, see 2S, anyways they are combining, they are symmetrical. Two balls, they are always symmetrical. They will always form sigma bond. They will always form sigma bond. S overlapping end to end, head on, X0 overlapping along internuclear axis. This is sigma bond. S orbital, SS orbital, always sigma bond, sigma bond, sigma bond. Now see, this is sigma bond already, I've told you. Now see, S and P head on overlap. S orbital, P orbital, head on overlap. Then S and P will combine. Now see, this is SP overlapping, one S, one P overlapping, sigma bond, sigma bond, sigma bond, sigma bond, sigma bond, sigma bond. Now, 1P, they are coming head on, axial overlapping, head on, end to end. This is PP overlapping, sigma bond, sigma bond, sigma bond, PP, sigma bond. Now see, if they are coming like this, perpendicular to each other, P orbital, like this, they will form the bond over the plane, above the and below the plane. At both the places, bonding is taking place, and this is known as pi bond. Pi bonding overlapping takes place above the plane and below the plane. Axis remains parallel to each other and perpendicular to the internuclear axis. If this is Z, internuclear axis, then P bond is coming like this and P bond is coming like this. Two P orbitals are coming like this and they will form overlapping here and here. At two places they will combine to form pi bond. But this pi bond is weak bond. Let me show you how. If I say this is one p orbital, this is another p orbital, if they are coming head on, see head-on. Head-on overlapping is good overlapping. Just see, this is px, this is also px. Just see to it. These are 2p. They're coming like this, head-on overlapping. This is going to form sigma bond. Just see the overlapping extent, pp. Very good overlapping extent. Better than ps and ss, the best. If they belong to the same period, this overlapping is best. See kids, best. Let me write down. Out of 3, this is the best. If they belong to the same orbit, if n is same, means period is same, quantum number is same, then SS, SP, then PP. Who is the best? PP is having maximum extent of overlapping. Maximum extent. This is best. All these are being sigma bonds. They are going to form sigma bond. I am comparing sigma bonds. Maximum extent of overlapping. Maximum extent of overlapping. Better. Now see, PP is having maximum extent of overlapping because S cannot have that much of extent of overlapping, my dear student. Now see, now actually the pi bonding is not usually going to take place in these bonding surface diagram. What actually happens, the pi bonding takes place in the fibers. These fibers, just see, and this is weak bonding. See, these fibers are colliding above the plane and below the plane. In the center, they are not colliding. Just see, this is internuclear axis. They are perpendicular to the plane. See, the feathers are combining upper and lower side. Just see. That's why pi bond is weak bond, and this pi bonding take place above the plane over here and below the plane. Everyone, can you see kids? Can you see kids? This overlapping is taking place above the plane as well as below the plane. Everyone, can you see? Now kids, if this much you are able to understand, let's do some question. No, time is 9. Now kids, should we do these questions right now or after the break? Would you like to do these questions right now or after the break? Those who want to do it right now, it will require just 10 minutes. It will require just 10 minutes, kids. Show me the hearts if you're ready. After 10 minutes, I will definitely give you the break. After 10 minutes, definitely I'm going to give the break, kids. Show me the hearts, those who are ready right now. Yeah. One kid is continuously writing SP4 to SP5 hybridization in cyclopropane is right or wrong. Absolutely correct. And today I will teach you that cyclopropanes SP4 to SP5 hybridization, that is having too much in-depth curiosity of these students is there. Concept is also fantastic. Now see kids. Now if px and px, these are the names of orbitals, and this is internuclear axis. Let me tell you, here it is internuclear axis. And this is about orbitals. This is all about orbitals. First of all, let's understand and you have to answer this question. If px and px coming from axis, what do you think? Sigma bond or pi bond or no bond? Sigma bond, it is going to form sigma bond, pi bond or no bond. Question is find type of bond. Sigma bond, pi bond or no bond. Delta bond I will teach. Raki, delta bond I will teach. Sigma bond. Absolutely correct answer. Sigma bond. That's really fantastic. That's really fantastic. Now, Py on Y internuclear axis. Py on Y internuclear axis. Once again, sigma bond. Very good. No, some are saying pi bond. Oh my God. Everyone is saying pi bond. Let me show you. Let me show you. Let me show you. Just see what I have told you. First of all, let me know what I have told you. This I have told you the x-axis, right? This. And this I have told you the y-axis, right? X-axis, y-axis, and this I have shown you z-axis, right? X-axis, y-axis, and z-axis. If I am having two p orbitals, this is px, this is x-axis, px, this is also px, and if I am keeping it on the same axis, it is head-on overlapping, sigma bond. Now, if I am having p by and I am keeping it on the y-axis, then they will be like this, both on the y-axis only, both the orbitals on the y-axis I have to keep. Once again, sigma bond. Now, if I am having two orbitals 2pz and I am keeping on the same axis 2pz, I am keeping on z internuclear axis, that is going like this. Both are on the z axis. Once again, they will come head on. Head on. Kids, do let me know. Do let me know. In all the three cases, sigma bond is going to get formed. First of all, do let me know, kids, in all the three cases, only sigma bond will get formed. See, whatever is the orbital's orientation, same is the axis. Orbital orientation, same is the axis. Orbital orientation, same is the axis. In all three cases, you will get sigma bond. How many of you are able to understand? These are the questions examiner will definitely ask kids. These are the questions examiner will definitely ask. Now see kids, if I'm having py on x-axis, now see, orbital's name is py. Orbital's name is py. This orbital's name is also py. Now where I am going to keep it? On the x-axis. How I will keep? This is py. How I will keep? I will keep them like this. And now this type of bonding is known as what? This is y, 2py, and I have to keep it on the x-axis. What type of bond? Pi bond. Very good. Pi bond. Very good. 100% correct. Absolutely right. This is going to form pi bond. Absolutely correct. Now, px on y-axis. Px, this was px. This was also px. But I have to keep it on y-axis. Px and px, I have to keep it on y-axis. Now they are going to form pi bond. Once again, pi bond. And PZ, PZ on x-axis, PZ and PZ. These were the PZ, PZ, and I'm going to keep it on x-axis. Once again, they are going to form pi bond. All are pi bond. All three are being pi bond. And see the answer, pi bond. Till now, how many of you are able to understand? First of all, do let me know, kids. It's these questions they are going to ask in the examination. No one is going to tell you all these things. Now, after this, see Px, Py. Px, Py. See, this is Px and on x-axis, Px and Py. What type of bond do you think they are going to form? This is Px, this is Py. On x-axis, they are saying keep it on x-axis. So this, I have kept x on the x-axis and y on the x-axis. What type of bond? No bond. Very good. Wow. That's great. That's like a good student. Very good. You got it. You got it. No bond, no bond, no bond. No one is going to form bond. Not possible. No bond. No bonding. You got it. No bonding. Kids, are you feeling happy? Then I will tell you about D. Then delta bond. Then the break. Then I'm going to give the break. Kids, are you able to understand it? Do let me know. Is everyone able to understand it? Now see, kids. D. This is D. This is also D. dxy, dxy. The name is dxy because in between x and y. In between x and y. This is dxy. This is also dxy. Four lobes. Four lobes are there in our d orbital. Now see, kids, this is combining with this. Just see what our representation. This is pi bond because overlapping is taking place above the plane and below the plane. So pi bond is possible. Pi bonding. Pi bonding. Okay. Now see. First of all, see what it's written over there. dxy, dxy and dpy, dpy bond, and we have combined them like this. But you see over here, dxy, dxy, but the internuclear axis is Z. Just see. Here, dxy, dxy, any internuclear axis you can take either x or y. These are on x-axis. If you bring it on y-axis, y internuclear axis, then also they will form pi bond. Are you able to understand? But if I dxy, dxy, if I bring it from up, internuclear axis is Z, then they are going to form delta bond. I think you are not able to understand. I think you are not able to understand. Let me show you. See, kids, if I keep it dxy, this is dxy, in between x and y, because x-axis was like this, in between x, y, can you see, everyone? Now, another dxy, if I bring it like this, see, this is the pi bond, see, the peacock feathers, they are combining over here and there. It is going to form pi bond. dxy on x-axis or dxy on y-axis, if I bring like this, they are going to form pi bond once again, see, pi bond. But if dxy, if I bring this from the Z internuclear axis, just see, Z internuclear axis, what is going to form? How many lobes they are going to interact? 4 lobes. Just see 4 lobes interaction. Delta bond. Can you see? One dxy is just above another dxy. Kids, can you see, kids? At least claps for me. Huge round of claps. No one, nowhere. See, kids, delta bond. Truly, I am going to visualize delta bond. 4 orbitals overlap. See, kids. Just like one drone is getting coincided with another drone. See, kids, this is delta bond. Just see your delta bond. See your delta bond. You can see to it. Delta bond, delta bond. This is being delta bond. See, like this is being your delta bond. One above another, delta bond. See, this is being delta bond, delta bond, delta bond. Kids, you can't imagine from where I've got these peacock feathers. I made it. First, the iron wire is there inside it. Then the plastic is above it. Then the round circle is there. Then the webical nature. It took 6 to 7 hours to draw it, to make it. Now see, kids, it's your time to answer the questions. Now, the xy dxy on z internuclear axis, I'm sorry, x internuclear axis. X is the internuclear axis. Dxy dxy is combining. What type of bond you will get? Thank you, sweetie. Thank you, thank you, thank you. Pi bond, very good. We will get pi bond. The xy dxy on y axis, what type of bond we will get? Once again we will get pi bond, very good. Now the xy dxy z internuclear axis, what type of bond you are going to get? The xy dxy z internuclear axis, what type of bond you are going to get? Yes, what type of bond you will get? Delta bond, very good kids, very good, delta bond. Now see the answer. Pi bond, delta bond. Definitely, it's absolutely correct. It's absolutely correct. Now, if you are able to understand this much, then answer this question. Dxy plus dyz on x internuclear axis. Dxy plus dyz on x internuclear axis. Dxy dyz on x internuclear axis. Very important question. Very important question, kids. Wow, Sri Hari, Raki, no bond. Very good. Awesome, kids. You kids are rocking. Let me show you. Let me show you. Let me show you. This is dxy. This is dxy. Another one is dyz. Dyz. Dyz is like this. Dyz is like this. Now see, internuclear axis, this is the node. What type of bond? This is no bond. See, this is dxy. Can you see? This is being dxy in between x-axis and y-axis. And this is dyz. This is dyz. Just see. Do you know any type of bond like this? Have you seen any type of bond like this? No bond, no bond, no bond. Very good, kids. Your visualization is Vera level. Your visualization is Vera level. No bonding. No bonding, kids. No bonding. Okay. Now the break. And kids, really thank you. It's being 3:30. 4.5 hours. And I told you to give a break at 9, but it's already 20 past 9. Thank you, kids. Now it's a break. 20 minutes break. Okay? 20 minutes break, kids. But kids, you have to make a promise. You have to make a promise that you will come with more energy. You will come with more energy. We will meet at, right now it's 21:19, 21:40. That is 9:40 with more energy. Come with more energy. Promise, kids? And call everyone to attend this lecture. Kids, thank you. Thank you. Oh my God, Srinath, sweetie. Kids, tomorrow we are having special class, yeah, at your Unacademy platform. Special, that is free class, and I will take all the questions MCQ which are important for your NEET as well as ZEE in that class. It's 90 minutes duration class. Class duration is of 90 minutes. I will take it over there, my dear students, right? But right now, let's meet after 20 minutes break. Okay, so we will meet sharp at 9:40 with more energy. Remember that, with more energy, not the less energy, right? Okay, Raki, I will use other pens. Okay, 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 Kal. Okay, okay, kids. Okay. Welcome back. Namaskaram. Kids, wow, Rishi, Pallavi, back. Have you had something, some water, snacks? Keep hydrated and energetic yourself because food gives us energy, and energy is the ability to do work. It's long way to go. Right now, I'm going to tell you about hybridization. And once we know the hybridization, we can easily find out the structures. And once we are able to understand the structures, we can find out the dipole moment, we can do the resonance, the bond order, number of things are there, my dear students. That's why I'm telling you long way to go. Even I will tell you the oxy acids, banana bond, sp4 to sp5 hybridization. And all these things really holds a hell lot of weightage. Categorically, those particular things the examiner is going to ask in your examination. And his friends, now how is everyone? Are you ready, kids? Let me see in the chat section that how's the Josh. Show me some fire in the chat section. I want to see, kids. Some fire I want to see in the chat section. Yes, if you're ready, show me some fire hearts in the chat section, my dear friends. Wow, thank you, Vijay Kumar. This is the thing which really I feel accomplished. This is thing required, kids. You have to be with me. I want to tell you each and everything. So let's start. Let's start, kids. Hybridization. We can say the intermixing of orbitals. How the intermixing of orbitals is going to take place, I will let you know that. And then only we can find out the hybridization. Suppose you just let me know, kids, I'm having, so what I'm going to tell you right now, intermixing of orbitals. Intermixing of orbitals of nearly same energy level. Nearly same energy level. Now, my dear friends, if I say I'm having one fruit that is S, the name of this fruit is being S, this is S orbital, so S fruit. And if I say I'm having one fruit named as P, named as P, this P fruit, pineapple. Let's say this is being pineapple. This is being pineapple. Pineapple fruit. So it's yellow. Let's take yellow colored pineapple. Yellow color, right? It's being yellow colored pineapple. So this is being pineapple and it's looking like also pineapple. And tell me any fruit starting with S. It's just do let me know any fruit's name starting with S. I want to see any fruit's name starting with S so that I can tell you each and everything. Orange. Orange is not starting with S. Okay, it's spherical. It's being spherical. So let's take orange. This is being an orange. Now, it's if I mix one S orange, one pineapple, what type of taste you will get? One glass orange juice, one glass pineapple juice I have added. One glass pure orange, one glass pure pineapple, one glass of pure pineapple I have added. Now I will get 2 glasses of juice. Definitely I am going to get 2 glasses, 1 glass, 1 more glass. Now, what do you think? What should be the color of the juice? It will be neither white, it will be nor yellow. It would look like something like this. See kids, the juice will look like something like this. Yellow color will become whitish and white color will turn out to be little bit yellow. That means it is in between yellow and white. Am I right? That juice will be, color of juice will be in between yellow and white. Am I right, kids? And this will be having 50% taste of orange and 50% taste of pineapple. So I will say the name of this juice is SP and the name of this juice is SP. Am I right? Am I making any sense, kids? Neither this is pineapple nor this is orange. It is hybrid of pineapple as well as orange. 50% S character. I can say there's 50% S character and 50% P character. Is everyone able to understand? Show me the thumbs up if you are able to understand. Keep on showing thumbs up. No need to ask so that I can increase the speed, my dear students. Keep on showing the thumbs up. Everyone, keep on showing the thumbs up, kids. No need to ask again and again. So just to increase the speed, you have to write, you have to put their thumbs up, kids, so that I can move speedily. Now, once again, because we are going to deal with hybridization, so we have to understand the intermixing of orbitals. We don't know the intermixing of orbitals, we can't understand anything. Now if I say there is S, one S, and there are 2 pineapples, there are being 2 pineapple, one pineapple 2px, another pineapple 2py. I have mixed 1 orange, 2 pineapple. Now how many glasses of juice I will get? 1 glass, 1 glass, 1 glass. I was having 3 glasses. 1 glass of orange, 1 glass of this juice, 1 glass of this juice. Right? Keep on writing, kids, in the chat. 3 glasses. Now 3 glasses I will get. Now this time the yellow part will be more or the white part will be more? The yellow part will be more or the white part will be more? Just to let me know which part do you think will be more. Definitely this time the juice is having yellow part more. That means more P character and less S character. How much? Out of these three glasses, I can say only 1/3 is S character. Can I say like this? Only 1/3. 1/3 is how much? Percentage of S character. Percentage of S taste. Character is taste. If I say, if I drink this glass, one glass, how much taste of orange I will get? I will get 1/3 taste, I can say, or percentage of S character I will say, and 2/3 is percentage of P character. 1/3 is how much? Because 1s 2p, so this is going to form sp2 hybridized orbitals. sp2 hybridized orbitals. Now how much? If you divide 100/3, I will get how much percentage? Not 25, it's 33. It's out of 3. Just divide 3 parts. 3 part, and if you're going to take 1 part of it, 1/3. 1/3 is how much? Kids, can't you do this much? 1/3 is how much? 33%. 33 passing marks, 33.33%. Is it clear? Now, if I am having one glass orange, now 3 glasses of pineapple, 2px, 2py, 2pz, 2px, 2py, 2pz, and I mixed it. Now I will have 4 glasses, 1, 2, 3, and 4. 4 glasses, more or less, they will look like more yellowish, very less white. So right now I will say the percentage of S character will be how much? That is 1/4, because 1s 3p, so it is going to form sp3. 4 hybridized orbitals, 4 hybridized orbitals. So the percentage of S character is 25%. Am I right? S character, and rest of 75% P character. The taste of pineapple will be 75%. The taste of this orange will be 25% only. Everyone, is it clear, kids? Everyone is able to understand? Is it clear? Now kids, once we are able to understand the concept, once the concept is clear to our brain, now we have to understand how the sp hybridization takes place orbital wise. I will show you orbital wise also. See kids, if I take carbon, if I take the case of carbon, my dear students, if I take the case of carbon, just see to it. If I say I am having CH3, I am having CH2, I am having CH, triple bond CH. I will show you the electronic geometry and trick to find out hybridization. But first of all, let me tell you what is the meaning of sp, sp2 and sp3. You know that each carbon of this is being sp3 hybridized, sp3, because it is bonded with 4 sigma bonds. I will tell you the formula also. Now this is 1 sigma, 1 sigma, 1 sigma, sp2. Now one sigma, one more sigma, SP. Right now our target is just to find out the meaning, actual meaning of what? Actual meaning of SP, SP2 and SP3. Just see. If I talk about this, the carbon's atomic number is how much? Carbon's atomic number is 6. I will write 1s2, 2s2, 2p2, ground state configuration. Now, in the outermost shell, we are having 2s2 and 2p2. If I take ground state 2s2 and 2p2, 1, 2. Now, this is the ground state. Now, if I supply some energy, if I say first excited state, in the first excited state, the one electron from 2s2 to move towards 2p this, so it will go like this. Now I will have the arrangement like this: 1 1 1 1. All they are having one electron. Now if I say excited and hybridized state, hybridized state. Now kids, why they are hybridizing? You must have seen the Indian soldiers. They will come from different states. They must be having different shirts, but Indian army says or military says you will have one uniform, just to make it uniformity over there. Now when they are going to fight at the border, even their vehicles, they are having some trees, branches like that, and they are having on the face black color, and they are not calling by their names, just to maintain uniformity, same energy level, same group, and to get better stability. By the mixing is taking place, once the mixing is taking place, then they are getting more stability and less energy. Now see, they will combine together, and once they are going to combine, my dear friends, so excited and hybrid state, this I am going to draw over here, excited and hybridized. This is pure S, these are pure P, Px, Py, Pz. Once they have combined, they will look like this, see kids. They will look like this. Now you cannot find which one is S, which one is P. All there are 4 sp3 hybridized orbitals. This is sp3, this is sp3, this is sp3, and this is also being sp3. All they are being sp3. Are you able to understand, my dear friends? Still now, is it clear to all of you? Now when they all are being sp3, now what I said, I was telling you, this is being S and these are being P. P is being double dumbbell shaped or single dumbbell? Single dumbbell shaped. This is like this, like this. Now once they are going to combine together, my dear friends, you have combined it, you have combined it, you have combined it. This was spherical in shape. When this was alone, this was round, circle, spherical, and they were dumbbell shaped. Now once, my dear friends, there is one movie Krantiveer, in Hindi Krantiveer. There is one hero known as Nana Patekar. Once there was a fight in between Hindu and Muslims. What Nana Patekar did, he has hit it. Now he has taken blood from Hindu and he has taken blood from Muslim and combined together. Now he asked to the public, find out which blood part is of Hindu and which is of Muslim. We cannot distinguish. So once spherical and dumbbell, they have combined together, kids, no one can distinguish which one is S, which one is P, because once the juice of orange and pineapple that got mixed. Now it's not possible to separate, not possible to identify. You can drink like, can't drink like. This is the part of pineapple and this is the part of what? Orange. So kids, during hybridization, one lobe will become smaller. Let me make it very clear. During hybridization, one lobe will become smaller. So some books shows that lobe, some other books they are not going to show that lobe. So first of all, I will show you that lobe. Now kids, this was slim. See, thin and slim. This was more to spherical. So after once they have combined, it will look like this. It will become somewhat fatty, little bit fatty, because it has got spherical nature also. Little bit fatty, little bit fatty. See, in this, you cannot say which one is S, which one is P. All their names, all four orbitals name are sp3, 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 sp3. These are the four equivalent in energy, equal shape by same shape, same energy, each and everything is same. These are the four hybridized orbitals. We will say four hybridized orbitals of a carbon, Now, when we are having these four sp3 hybridized orbitals of a carbon, so let's say we are taking two carbons. We are having two carbons. Just see, one carbon is having four lobes. 1, 2, 3, 4 lobes. All are having one electron. Now I'm taking another carbon. It is also having four lobes. Just see, 1, 2, 3, 4, opposite spin, opposite spin, opposite spin, opposite spin. So if I give the designation, I will say this is sp3, this is sp3, 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 head-on sigma bond, carbon to carbon, carbon to carbon, sp3 to sp3 sigma bond. This is the designation. Now if I say kids, I'm having hydrogen, this is hydrogen, this is being hydrogen, this is being hydrogen, this is being hydrogen, and this is being hydrogen, this is being hydrogen, this is being hydrogen. I'm having 6 hydrogen atoms. Let's see, 6 hydrogen atoms means 6 electrons, and the electrons are like this. 1 electron of hydrogen, second electron of hydrogen. So opposite spins will be there, 1 hydrogen electron, 1 hydrogen electron, 1 hydrogen electron, and these are having opposite spins, hydrogen electrons, hydrogen electrons. Now see, designation of this one, I will say definitely this is known as hydrogens S, carbons sp3, sp3 to S, head-on sigma bond. Now in this ethane molecule, I'm having 1, 2, 3, 4, 5, 6, 7, means 6 plus 1, 7 sigma bonds, but their designation is different. One designation is being carbon to carbon, sp3 to sp3 sigma bond. This is not 6, sorry, it is just 1. sp3 to sp3 is, this is 1 only, and 6 are carbon to hydrogen, sp3 to s sigma bond. So in total I'm having 7 sigma bonds. Just see to it. I hope that everyone is able to understand. If this one is clear, then I will show you how sp2 hybridization is forming. But show me the thumbs up. No need to say. If you are able to understand, everyone, just show me the thumbs up, kids. Now I'm going to tell you the bonding in ethene. Ethene's bonding, just see. Ethene. In ethene, how and why the sp2 hybridization is taking place. This is sp2, this is sp2. Now I have told you, my dear friend, this is carbon atomic number 6, 1s2, 2s2, 2p2. Outermost orbit, if I say the ground state, outermost valence shell, if I say, then the valence shell, this is 2s2, this is being 2p2, like this. In excited state, first excited state, I will say one electron will transfer from here to there. Now it will look like this, 1 and 3. Now my dear students, number of times you must have seen that whenever there is the festival, that is the eve of Holi, then everyone is saying, let's play, let's put some color on your face. But some people, they are very arrogant or rich, or their level is different. We used to say Bira level, Thalaiba level, this level. They will say, no, I don't want to play. My level is different. I'm of different level. Now this gets, if I say this is 2s, this is 2px, this is 2py, this is 2pz. During hybridization, one orbital said, I'm not going to combine with you. I'm not going to combine with you. So only these three are combining, kids. Only these three are combining. Now what will you say? One orbital is not combining. One orbital which is not combining, kids, that will have its two lobes. That will have its two lobes. One combined, this combined, this combined, this combined. This has not combined. See, its energy will be more than rest of others. This is the energy level. Its energy is more, and this is having two lobes like this. Its lobes will be like this. It is acting as pure p orbital, pure p orbital, or I can say unhybridized orbital. Unhybridized orbital. Its energy will be more, its lobe will be 2, because it has not taken in the group formation, and their designation will be sp2, sp2, sp2. Are you getting my point, kids? Now this is not combining with this. If till now it is clear, then I can show you its bonding, my dear friends. Let me know once it is clear. Show me the thumbs up, kids, everyone. Now when it is not combining with this, there is more s character. More s character means its lobes will be heavier. Its lobes will be heavier, like, see, if I say this is one carbon, this is one carbon, this is sp2, this is sp2, this is being sp2. One electron, one electron, one electron, and their designation is being sp2, sp2. Now more s character, so it is more spherical. Now let me take another carbon. If I take this carbon, it's sp2, sp2, sp2. This is also having one electron, one electron, one electron, and their designation is being sp2, sp2, and sp2. Now the orbital which has not taken part, it will look like this. slim trim, lengthy, pure p orbital. This is also pure p orbital. Just see to it. And the bonding in between these two, the bonding in between these two will be above the plane as well as below the plane. There is one pi bond. Just see to it. This is known as pi bond. This is known as carbon to carbon sigma bond. This is your carbon to carbon sp2 to sp2 sigma bond. Now they will combine with hydrogen. 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 Their designation will be sp2 to s, carbon to hydrogen sigma bond. So how many covalent bond? 1, 2, 3, 4, 5. 5 total covalent bond, 5 sigma bonds. If you want to break them 5, then how will you break these 5 bonds? 1 plus 4. 1 is carbon to carbon, sp2 to sp2. This is the designation. Now 4 are carbon to hydrogen, sp2 to s sigma bond, and 1 pi bond. Now if anyone is asking how many covalent bonds, 1, 2, 3, 4, 5, 6 covalent bonds are there. 6 covalent bonds. My dear friends, I hope that everyone is able to understand. Show me the thumbs up if you are able to understand. Kids, if everyone is able to understand, just show me the thumbs up so that I can move ahead. Hey, my dear friends, what are you waiting for? No need to repeat. Once if you got it, always put. Yeah, now let me show you acetylene. Let me show you acetylene. This is your acetylene. CH triple bond CH SP linear. I will tell you how to find out linear and what. Once again, you see the carbon at the last. Let me tell you, carbon was 1s2, 2s2, 2p2. Now you could understand I'm finally reaching towards the hybridized state. You can understand my statement of the hybridized state, that only one S and one from the P is going to combine. Rest of the other two, they will not combine this time. Let me show you kids. These two will combine, only these two. Just see, only these two are going to combine this. 2px, this is 2s and this is 2px. Y and z, they are not combining. So if only these two are combining, kids, sorry, if only these two are combining, then we will call it sp. We'll call it sp, and this is having more energy and this is having more energy. They are unhybridized pure p orbitals. There are two pure p orbitals. They will be having more energy level. Their lobes will not get reduced. Now see how the bonding is going to take place. Let me say this is one carbon, and if I draw more s character, sp, and this is also being sp, this being sp, this is also being sp, I am being hsp and they are being sp. Now let me take another one. This is carbon, this is being sp, and this is also being sp. 2 electrons like this. Now they are having 2 pi bonds. One pi bond is going perpendicular to the plane above and below the plane like this. The bonding will take place like this. Now another pi bond. One pi bond is going like this. Another pi bond will go like this, perpendicular. See, this is sigma bond. This is one pi bond. Can you see? This is sigma bond. This is one pi bond. Another pi bond will go like this. Are you able to understand? Now, see kids, another pi bond will go like this, which is perpendicular to both. And this is another pi bond. And rest of the orbital, it will combine with hydrogen, hydrogen atom and hydrogen atom. I hope that everyone can understand it. Kids, got it? Everyone got it? This is acetylene structure. Now, my dear students, everyone just show me the thumbs up if you are able to get it. Why we are telling pure p orbital? Suppose you are having one glass of pineapple where the just pineapple juice is there. No mixing has been done. No mixing has been done because they are not combined. No mixing. No mixing means without mixing. So what do you say? Is this pineapple juice pure or impure? When no mixing has been done. Suppose in this pineapple, this was the pineapple p orbital and this was s. NSP mixed. Here the mixing of sp is taking place. Mixing of sp. So they are impure. And there are no mixing. They are pure p orbitals and no means no hybridization. Not undergone hybridization. Not undergone hybridization. Has not undergone hybridization. Now kids, man gaming. Okay, I will tell you how to find out whether the SP mixing is taking place or not. I will let you know. This thing I am going to tell you now. See kids, see to it. I am going to give you the trick to find that whether the mixing is taking place or the mixing is not taking place. Just see to it, kids. See kids. I'm going to give you the trick, the best trick. Just see to it. Trick is find out steric number. Just find out steric number. How to find out steric number? Number of sigma bonds plus number of lone pairs, pair of pairs. But remember that these lone pairs must be localized one, means not taking part in resonance. This is the trick, kids. Now, if the steric number is coming out 2, then the hybridization will be sp. Steric number is coming out 3, then the hybridization will be sp2. Now the steric number is coming out 4, it will be sp3. It is coming out 5, simple, I'm just telling you right now, simple one, it will be sp3d. It is coming out 6, it will be sp3d2. And it is coming out 7, it will be sp3 d3. Right now I'm not considering dsp2 like that, d2 sp3. I'm not going to, right now I'm not dealing with all those things. So kids, very easily we can find out the steric number. I will show you how to find out the steric number. Once the steric number is on hand, we can find out the electronic geometry, and then I will tell you how to find out shape of the molecule. Is everyone ready? Is everyone ready? Now see how to find out steric number. See kids. Suppose I'm having CH4, I'm having ammonia, I'm having water, I'm having HF. Let's find out steric number. See kids, carbon. Carbon belongs to which group? Just see, carbon, boron, carbon, nitrogen, oxygen, fluorine. Just see to boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine. This is third, fourth, fifth, sixth, seventh, because they are having these many electrons in the valence shell. How they are having? If I say boron is having how many electrons in the valence shell? Electrons in valence shell. So definitely they are having 3 electrons. This is having 4 electron, 5 electron, 6 electrons, 7 electrons. Now if we are able to keep this thing in our brain, then carbon is having 4 electrons in the valence shell. That means 1, 2, 3, 4. Now it will combine with hydrogen, The shape I will let you know. Now steric number. Steric number will be how much? Steric number will be number of sigma bonds plus lone pairs, 4 plus 0, so 4. So it is sp3 hybridized. Now nitrogen. Nitrogen is having 5 electrons in the valence shell. If I say there is nitrogen, now 1, 2, 3, 4, 5. Now it is forming bond with 3 hydrogens. 3 hydrogens, that means 1 hydrogen, 2 hydrogens, 3 hydrogens. Now how many sigma bonds? 1, 2, 3 and 1 lone pair. So steric number is 3 plus 1, that is equal to 4. This is also sp3. Shape I will let you know. Now if I talk about water, the middle central atom is oxygen. Oxygen is having 6 electrons. So if I write 1, 2, 3, 4, 5, 6 to complete its octet, it will form bond with 2 hydrogens. See, 2 hydrogens are there. So how many sigma? 1, 2, 2 sigma and 2 lone pair. 2 plus 2, 4. This is also sp3 hybridized. Fluorine belongs to 7th group, 7 electrons. Just see, you can find out. Now this much is clear. I hope this much is clear. Now see some more examples. Let's discuss some more examples, my dear friends. If I say I'm having PCl5, I'm having XeF2, I'm having XeF4, I'm having XeF6. Just see to it. My dear friends, phosphorus is having 5 electrons in the outermost shell. 1, 2, 3, 4, 5. With 5 chlorines, it has formed the bond. 1 chlorine, 2 chlorine, 3 chlorines, 4 chlorines, 5 chlorines. So 5 sigma bonds. Steric number will be 5, 0 lone pair. 5 means sp3d hybridization. Xe, xenon belongs to 0 group. That means xenon is having 8 electrons in the outermost shell. So xenon is having 8, 1, 2, 3, 4, 5, 6, 7, 8. Fluorine 2, 1 fluorine, another fluorine. So 2, steric number is 2 sigma bonds. How many lone pairs? 1 lone pair, 2 lone pair, 3 lone pairs. 2 plus 3, 5. sp3 dehybridization. Now XeF4. If I talk about XeF4, once again 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 4 fluorine, 1 fluorine, 2 fluorine, 3 fluorine, 4 fluorine. That means steric number is equal to 4 sigma bonds and 2 lone pairs. 4 plus 2, how much? 6. 6 is sp3d2. How to find out? 1s, 1 plus 3, 4, 4 plus 2, 6. XEF6, 1, 2, 3, 4, 5, 6, 7, 8. 6 fluorine. 1, 2, 3, 4, 5, 6 fluorine, 6 sigma bond. That means steric number is 6 plus 1 lone pair. 6 plus 1 is 7. 7 is sp3d3. I hope this is clear to all of you kids. Is this clear? Now, suppose if somebody is going to give you something like this, ClF3, or somebody is going to give you I3 negative, like this. Now, how to find out? See kids, 1, this is 1, this is 3. So this is central atom. Fluorine is 1, 2, 3, 4, 5, 6, 7. And fluorine, how many fluorine? 3 fluorine, 1 fluorine, second fluorine, third fluorine. So 3 sigma bonds. You can say steric number is 3 plus 1, 1 lone pair, 2 lone pair, 3 plus 2, 5. That is sp3d, sp3d. I3 means 1 is central atom and it is having negative charge. 1 negative charge means 7 electrons of its own. 1, 2, 3, 4, 5, 6, 7. And 1 negative charge means 1 electron it has gained. 1 electron is that it has gained from somewhere. Iodine is having negative charge, 1 extra electron. Now 2 more iodine are bonded. Iodine with iodine is bonded like this. Iodine with iodine is bonded like this. Now, how many sigma bond it is having? 2 sigma bonds. So steric number will be 2 plus lone pair 1, 2, 3 lone pairs, 3 lone pairs, 3. So it is sp3 dehybridization. My dear students, once if you are able to find out hybridization, then I will let you know how to find out the shape and the electronic geometry. If this much is clear, do let me know. If this much is clear, kids, do let me know. Show me thumbs up till now if you are able to understand. Then I will tell you how to find out geometry. Now see kids. Electronic geometry and shape. Electronic geometry and shape. Electronic geometry and shape. Electronic geometry is also known as arrangement of electrons. Electronic geometry is also known as arrangement of electrons. My dear friends, wow, everyone is able to understand. Kids, sometimes different teachers or their management, I can see them in the chat section. Sometimes they will say something, sometimes they will say something. They are there always. So be aware of such type of people. Now, my dear friends, electronic geometry is also known as arrangement of electrons or arrangement of electrons. Let me tell you one more thing. If lone pair is not present, then electronic geometry and shape is generally remains same. If no lone pair is present, or I can say without lone pair or lone pairs, electronic geometry and shape are same. Shape are same. If lone pair or lone pairs are present, they will get changed. otherwise they remain same. Now let me tell you kids, let me show you. Suppose if I say any atom is like this, AB2, center of attraction is A and it is surrounded by two atoms. One is king and other two are queen, and this is the world. Just see, if I say this is the world, one king, two queens, and this is the world. And in the center, there is king. No lone pair is there. Without lone pair, I am considering the case without lone pair. All the cases right now without lone pair. Without lone pair. Now there is king in the center. Now queen will be at the maximum nearest to the king, queens, but in between queen and queen, they will lie close to each other or they will lie far away. Do let me know. These B are being queen, they will be close to each other like this. If I say B and B are like this. Is this is the right structure? Is this is the right structure? Or they would like to remain far away? Definitely the answer is they will lie far away from each other. So far away distance is which one? Far away means one queen will be over here, another queen will be over here. Is it making any sense, kids, whatever I am writing? Am I making sense? B and B, the bond angle will be 180 degree, and the shape and electronic geometry and shape will be linear. Is it clear to all of you kids? Is it clear? Just to let me know. My dear friends, if it is clear to all of you, do let me know. Yes sir, this is clear. No need of any teacher, no need of any book, no need of revision. You will get it immediately. Now, my dear students, let me take another case. This I have taken AB2. AB2 means one sigma bond, another sigma bond. So this is the case of SP hybridization. SP hybridization. I hope that everyone can get it. Everyone, this is clear to each and everyone. Now let me take sp2 hybridization case. Let me take sp2 hybridization case. Means three are there. AB3, one king, three queen, one king, three queens without lone pair. Once again, let me write down without lone pair. Without lone pair. Now this is the world, this is being the world, this is the world. One king, three queens are there. Just to let me know, what will you say? One king, the maximum distance in between queens will be, this is the king, this is being the king, kids. Now divide 360 into 3. 360 divided by 3, how much will you get, kids? There 360 was divided by 2. 360 world was divided by 2, so we got 180 degree angle. Now here 360 divided by 3, how much we will get? 120. So 120 means one queen will lie over here, another queen will lie over here, another queen will lie over here. This is the position of all three queens. B, B, B. Now the bond angle, you told me what should be the bond angle. 120 degree, 120 degree. They all are lying in same plane. 120, 120, 120. AB3, this is sigma bond, this sigma bond. Sigma bond, trigonal planar. Trigonal planar is the shape as well as electronic geometry. Electronic geometry gets. I haven't told you anything. I haven't taught you anything. This is you are getting it. You are getting it. Once any point is clear, kids, don't forget to show me the thumbs up, kids. If you are getting it, it's your duty to show me the thumbs up. Now see, kids. Now SP3 case. Case is SP3. SP3. SP3 case means what? SP3 case means there are four, AB4. Once again, I am telling you right now, I am considering without lone pair. Without lone pair case, I am taking, I am considering. Now, if I draw it like this, the 360-degree, there is one king, there is one king. Let me duplicate it because it will be required. Now there is one king A, there is one king A, now four queens. Now four queens, if I draw like this, four queens, at what angle they will lie? This angle will be how much? 90-degree, one queen, another queen, another queen, another queen. So they are thinking it's not good. It's not good because maximum repulsion will be there. So it is wrong. Maximum repulsion in between queen and queen will be there. So they thought something else because in between these queens, force of repulsion will be there increased all the queens. So they are saying, no, no, we will not lie. We want to increase the bond angle. This distance we want to increase. So how they will live? See, they said, we will live like this. You are the king. You are being the king. Now, how we will live? Let me tell you. So they said, more than 90-degree, 109-degree, we would lie and we would be present at 109 degrees. So it is not planar. Now it is not planar. They have gone out of the plane. So this is being B, this is being B, this is being B, and this is being B. And they have formed a structure that is known as tetrahedral structures. So this is the structure secrets. They are now present like this. Secrets. Can you see this structure? Is everyone able to understand this structure? This is being tetrahedral structure, and you can see to it like this, like this. Can you see its tetrahedral structure? So 109-degree bond angle. This is being not planar. The bond angle is now 109-degree. If it was planar, that was coming 90-degree. If it was planar, it was coming 90-degree. This is 109 degrees. See the difference of how much they have managed. Now the difference of, can see 19-degree bond angle they increased. This is known as tetrahedral. Tetrahedral, and this is not planar. Not planar. Not planar. Now my dear friends, let me take the case of SP3D. Now see the case of SP3D kids. Case of SP3D. Let me take the case of SP3D. Without lone pair. Right now I am taking without lone pair. C kids. Without lone pair. Without lone pair. Now see, let me tell you sp3d. sp3d. Now the example is being ab5. Let me take ab5. ab5. Now how they will manage kids ab5? So they can't live in one plane. If they are going to be in one plane, maximum repulsion will be there. So they thought, let's divide ourselves. Let's see how to divide. They have done one programming. They said, let's be like this, sp2 plus pd. sp2 plus pd, it is coming sp3d. Now see kids, sp2 means they will lie trigonal planar. Trigonal planar, and they will go above and below the plane. See kids, and that's why nowadays you must have seen the houses in village. The houses were of one row. Now in cities there are double story, triple story, 15 story, 25 story, 50 story Burj Khalifa. You see, it's going up, it's going down. So they are above, one is being above, another one is being below. Let's see how to draw the structure. See, this is the world. Let me show you the world. This is the world. Can you see, this was our world? This was the world. Now this was the king. This was your king, a king. Now 5 queens. The 5 queens, they have decided to live like this. One queen over here, another queen over here, one queen over here. Can you see the bond angle? Can you see? Can you see kids the bond angle? These 3 queens, the bond angle is how much? 120 degree. It's 120 degree. 120 degree. So this is queen number 1, number 2, number 3. Now see, rest of the queens, they are like this, very bad conditions. See kids, one queen is like over here, another queen is below the plane. They are like this. These are the rest of the 2 queens, B and B. They are forming 90 degree. Now kids, their bond, if I compare, that is 90 degree. 90 degree. Which queens are more comfortable? See, their bond length is less and bond dia is more. That means they are forming a strong bond. This bond is being a stronger bond. You can see kids, stronger bonds. Why this is stronger bond? Because they are living more comfortable. This bond angle is more, so more comfortable. They are more comfortable, and this is big bond. You can see this is being big bond kids, and they are having difference, or you can compare here also. See, here the percentage of S character is 33.33, and in this 0% S character, 0% S character. And kids, S character means how closely the electrons are attached. I will tell you over here the band theory also, but right now not. Right now I am teaching very simple. So this is known as equatorial bond. This is known as equatorial bond. Equatorial bond. This is known as axial bond. Axial bond. axial bond is having 0% S character. This is the weak bond. And that's why if I say PCl5, whenever you are reacting PCl5 with ethyl alcohol, it is going to give you POCl3 plus Cl2. Two Cl bonds, they are lying like this. Let me draw one more structure, better structure than this. Just see to it. If I say I'm having this AB5 only, let me draw AB5 only, or let me take example of PCl5. If I take an example of PCl5, so I'm having phosphorus over here, and the three bonds, they are being axial, 1, 2, 3. You can see these are the three bonds, and the one bond is going above the plane and below the plane. Can you see, kids? Now, let me write down, this is one Cl, this is another Cl, this is another Cl. Let me write down, this is one Cl, this is another Cl. And if I draw like this is trigonal planar. You can see, just try to understand, this is being trigonal planar. And if I attach that bond with all these, just see one pyramid from upper side, you will see this is one pyramid. Can you see? Visualize from upper side one pyramid, and another pyramid you will see from lower side. I hope that everyone can feel it. One pyramid from upper side, one from the lower side. This is trigonal bipyramidal. This shape is known as trigonal bipyramidal. Trigonal bipyramidal. If you are able to understand, then you can understand anything, kids. These are the equatorial bonds. Let me tell you, equatorial bond, equatorial bond, equatorial bond, stronger bond, and this the axial bond, the axial bond. See, structure is clear, kids. I was busy in writing only, kids. Are you able to understand? First of all, do let me know. And first of all, let me say thanks from the internal core of my heart that you're liking my teaching this much. You are staying with me. Really, you are hardworking. I'm also hardworking, but success is waiting, and you are going to get success. I'm going to get success, because no one is going to ask who is being HSP Baba. Once you are becoming doctor engineer with the best rank, you're going to the best college, your society will ask that who is being HSP Baba, where you have studied. Then you will say, this team has given you the selection kits. Really, my dear students. Thank you, Vijay Kumar. Thank you. Really thanks, kids. Just, I was thinking of whether you will remain over there. Will the energy will remain over there, because this chapter, chemical bonding, is the backbone of whole chemistry, and it holds a whole lot of weightage. You have to remain. Sir, you missed Ambika ma'am few minutes back. Oh, she was here. Oh my God, kids, whenever and whenever ma'am is there or sir is there, start putting hearts. Start putting hearts, kids. Whenever ma'am is there, sir is there, always start putting hearts, fire in the chat. Then I will, kids, I was busy. I was busy. Now see, kids, PCl5. Now see, kids. One has gone up, one has gone down, three are in the plane of paper. Now see, it's now if I say the case is AB6, AB6, now what they will do? They will remain like this. See, kids, there is A and B will come like this. See, kids, 1B, 2B, third B, fourth B. If I see or you see, then they will look like this. Let's try to understand. This is looking like a square, isn't it? This is looking like a square. 1B is over here. 1B is over here. 1B is over here. 1B is over here. 90-degree bond angle. Now, if I say rest of 2Bs, they will be like this. So all B are at equal position only, kids. Just you see, all B's are at equal position only. Can you see, kids? Now, if I draw something called as the pyramid, now see, this will combine with this. Just see one pyramid upper side, and another pyramid lower side. You can see this. This pyramid from lower side, from the base side, you can see this is left. Where? Why this is not getting combined? Okay, this has combined with that. This is forming 1, 2. This is left. So 4. Is everything okay? B is forming with 4. Okay, this is not going over here. This will come over here with this, this, and that. Can you see two pyramids? I don't think that you are able to visualize it. Let me give you another diagram so that you can easily get it, kids. Let me show you. Just a sec. Just a sec. SF6. Let me take the case of SF6. One fluorine, another fluorine, another fluorine, another fluorine, another fluorine, and another fluorine. 6 fluorines. I've got one fluorine, another fluorine, another, another fluorine, another fluorine. Now see SF6. This is SF6. Now I'm going to form a pyramid. Let's see this time we can visualize it or not. One has gone over here, another has gone over here. Now this has gone over here, has gone over here, and this, let me combine over here. Can you see, kids? The one pyramid, can you see? Another pyramid from lower side, it will go over here, will go over here, will go over here, go over here. Can you see, kids? Everyone, can you see? So it is square bipyramidal. It is square bipyramidal. All bonds are equal. You can say it to be octahedral also. Octahedral. You can call it octahedral or square pyramidal. The bond angle is 90 degree. 4 up, 4 down, 8, 90 degree means 8 bonds. See, with this sulfur, one fluorine, see, one fluorine, 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 4 fluorines up, 4 fluorines down. Can you see how many? 8 bond angles of 90 degree. This is sulfur, fluorine, one fluorine, 190 degree. With this fluorine is forming with 1, 2, 3, 4. Lower one is also forming 4. There are 8 90-degree bond angles. Now, kids, the last one in this, without lone pair, IF7 means AB7. Just see to it, kids. So if I draw like this, So see, if I write one iodine at the center and I combine it with one fluorine, one more fluorine, one more fluorine, one more fluorine, one more fluorine. See, if you divide 360 by 1, 2, 3, 4, 5, just divide 360 by 5 and do let me know how much you are going to get. 360 by 5, how much you are going to get. Let me put fluorine till that time. You calculate, you just calculate, kids. So 7 ja 35 and 2 are 72 degree. It's I have written first 72 degree. We are getting bond angle and this is pentagonal. One fluorine will be up, one fluorine will be up and another fluorine will be down, kids. One fluorine will be up, another fluorine will be down. Now kids, one fluorine up, another fluorine down. So this fluorine, it is going to combine, kids. Just see, combine with this, combine with this, combine with this, will combine with this one. It is going to combine with all of these, going to combine. It is forming one pyramid upside. It is going to form one pyramid upside, another pyramid it is going to form downside. Can you see, kids? One pyramid over here, another pyramid it is going to form downside. Can you see, kids? Everyone just see to it. Can you see? So it is pentagonal bipyramidal, known as pentagonal bipyramidal. So 72 degree is there and this is forming 90 degree, 90 degree. This is forming 90 degree. My dear students, is it clear to all of you? These structures, the electronic geometry. Once you got the hybridization, the electronic geometry will never change. If the lone pairs are there or not there, electronic geometry remains constant. Only the shape changes. Thank you, Laharika. Thank you. 3D diagrams you liked? You liked, Laharika? You liked it? Just have a glass of water. And kids, you also have a glass of water. Keep yourself hydrated. Keep yourself hydrated, kids. Oh, it's looking good. Even I'm liking it. When I was drawing the diagrams, I'm not liking. But right now I'm liking diagrams. Wow, really nice. Oh my God, Srinath, Andrew, your presence is the best present, kids. Your presence with full on energy is the best present for me. Thank you, Vijay Kumar. Thank you. Oh my God, that's really awesome. That's really awesome. That's really awesome. And remain energetic so that I can teach you with full energy. Remember that my energy will not go down. You have to keep yourself hydrated. Eat something to get energy. I will teach the full concept. Okay. Wow. Thank you, kids. Really, really loving your comments. Really, kids. Really loving your comments. Really, kids. Wow. Thank you. Now, see, let me write down one statement. Let me write down one statement. With the lone pair or without lone pair or with the lone pair. we have got steric number. From steric number, you can find out the hybridization, and from hybridization, you can find out the electronic geometry. This will never change. It is always constant. These things are always constant. Electronic geometry will not change, will not change, will not change. Once you are able to reach up to here with this steric number, oh, Pankri ma'am is also there. Kids, keep on showing hearts whenever any ma'am, respected ma'am, respected sir is there. I will come to your chat. Okay. What is the difference between electronic geometry and shape? I will tell you. Whenever the lone pair is coming, that will, let me write down. Lone pair will generally change the shape, but not the electronic geometry. Lone pair or pairs, lone pair will change shape. Lone pair or pairs will change shape, but not the electronic geometry. But can't change electronic geometry. I will show you, kids. I will show you. But let me give you the analogy. Suppose if HSP sir is eating too much pizza, if I am going to have too much pizza, then my body will go like this. I will get D-shaped. But then also I will remain human being. My shape will get changed. But everyone will call me human being only. No one is going to say, hey, elephant is coming. And if elephant is eating very less, then elephant will be called as an elephant. No one is going to say, hey, you are man. Thank you, JDSS. Thank you. Are you getting my point? Let me show you. Let me show you. Let me show you with the help of example. Let me show you with the help of example. Let's take the case of SP3. SP3. Now, how many possibilities are there in SP3, kids? SP3 possibilities are, see to it, I can write CH4, one, two, three, four. Just see, if I say this is the column of sigma bond or bonds, and this is the case of lone pair or pairs. Now here 4 sigma bond, 0 lone pair, result is coming out 4. That's why sp3 steric number is 4. Now if I write ammonia, 3 sigma bonds, 1 lone pair, the sum is coming 4, the steric number is 4, sp3. If I write H2O, 2 sigma bonds, 2 lone pair, the sum is coming 4, sp3. If I write HF, 1 sigma bond plus 3 lone pairs, sum is coming 4, sp3. Now, everyone's electronic geometry in all 4 cases, 1, 2, 3, 4, all 4 cases, electronic geometry will remain same. Kids, everyone is able to understand? Pallavi, don't say bye. Many concepts, many tricks Baba is going to tell you. Once the molecular orbital theory is going to come, dipole moment is going to come, Baba will tell you a number of things. Everyone is able to understand. Now see, everyone's electronic geometry will remain same, but the shape will get changed. Electronic geometry will remain same. Electronic geometry will be tetrahedral only. Tetrahedral only. Now let me tell you the shape of all the 4 secants. Methane we know very well. Methane we know very well that C, H, 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 H. You can see it's being tetrahedral. Can you see, kids? It's being tetrahedral. Just see to it. This one, this one, this one, this one, and this one. Clearly visible that this is being tetrahedral 109 degree. Can you see clearly 109 degree 28 minutes, 109 degree tetrahedral. The geometry as well as shape is same because there is no lone pair. No lone pair. So electronic geometry is equal to shape. They are same. Now, my dear friends, before telling you the other shapes, we should know one thing: valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. Then I can tell you other structures too. Vassipper theory. Valence shell electron pair repulsion theory. This theory, the full form is valence shell electron pair repulsion theory, kids. This theory says that lone pair is bounded by only one nuclei, so it is more free. If you have seen your town, city, mohalla, the ox, no one is the owner of ox, and wherever the ox is moving, everyone gives the side. Everyone is going to give side. So lone pair repulsion is maximum. This repulsion is maximum. If I say the maximum repulsion is over here, this is the degree of repulsion, so it is having maximum repulsion. In between one lone pair and second lone pair, repulsion will be maximum. After that, lone pair and bond pair repulsion. After that, bond pair and bond pair repulsion will be there. This is the least repulsion. This is the maximum repulsion. This is maximum repulsion being the least repulsion. Now I can tell you the rest of 3 structures. So if this thing is clear, let me explain it, kids. Let me show you. There is ammonia. Just see how to find out. This is ammonia, one lone pair, 3 hydrogens are there. Now let me draw its shape. I will say this is ammonia and maximum space will be occupied this lone pair boss. See, is looking like boss. He is occupying maximum space. Maximum space is occupied by this lone pair, and this lone pair will say that, hey, rest of others, you just go away and do your job. So the hydrogens will come like this, and the shape you can see, it will look like pyramidal. Shape is looking like pyramidal because lone pair has nothing to do with the shape. Lone pair is just going to destroy the shape. lone pair and pi bond does not give the shape. Remember that. Remember one thing, lone pair and pi bond doesn't do not give shape. Lone pair and pi bond do not give shape. Lone pair is responsible for destroying the shape but not giving the shape. Let me tell you kids, lone pair or pairs, lone pair or pairs are known for destroying or deshaping. Now my dear students, it is pyramidal in shape. This is being pyramid, looking like pyramid. Now its shape is pyramid, but still the electronic geometry is tetrahedral only. Electronic geometry will never change. Its electronic geometry is tetrahedral only. That is the base from where it has originated. That is tetrahedral. I hope that everyone. Now you have to remember this value 107 degrees the bond angle. You have to keep it in your brain. And other family members like phosphine, bismuth hydride, they follow Drago's rule. They have no hybridization. I will explain Drago's rule also, kids. I will explain Drago's rule also. So it is being pyramidal in shape. I hope that everyone is able to understand now. Kids, let me tell you the shape of water. Let me explain the shape of water, kids. Just see to it. Water case. Just see. If I write water, H2O, then you can see two lone pairs are there. Two lone pairs are there. So maximum space will be occupied by whom? Two lone pairs. And the lone pair repulsion will be maximum. So the lone pair will occupy too much space. Lone pair is occupying this, lone pair is occupying. Now these two lone pairs are occupying maximum space. Let me once again tell you, two bond pairs are there and two lone pairs are there. Lone pairs are occupying maximum space, kids. Space is occupied by lone pairs being maximum. If I say these are the bond pairs, they are being lone pairs. So the bond pairs are not having too much. See the repulsion. Let me show you the repulsion. This is the repulsion between lone pair. This is the repulsion between lone pair, bond pair. This is the repulsion in between bond pair. Just see, this is being, let me mark. If I say this is A, B, C, lone pair repulsion, LP repulsion, valence shell electron pair. Theory says this repulsion is maximum than lone pair, bond pair, then bond pair. So A is more than B, more than C. This repulsion's order will be like this. I hope that everyone is able to understand, and experimentally its bond angle has been found to be 104.5 degree. It is known as V-shaped, or some people also call it vent V-shaped. I hope that everyone is able to understand. This is the repulsion. This is the case of sp3. Now I'm going to tell you about sp3d. There I will let you know band theory also. But first of all, do let me know, kids. Oh, Wow, Laharika, wow, very clear, sir. You removed my all the doubts. That's really looking very fantastic. It's really feeling comfortable, accomplished when you are saying like this. Your all the doubts are getting cleared. Really, I'm what to say, kids. Let's have a glass of water. Wow, thanks, thanks. Chief, Chief Fan Gaming, thank you. Now, let me take the case of PCL5. Already I have told you. So, let me take PCL5, SF4, CLF3, XCF2. First of all, my dear students, it's your time to calculate the steric number and hybridization, and do let me know A, B, C, D. All four steric number calculate and hybridization. Once you are able to calculate steric number, hybridization will always be, you are going to find out. Now kids, I am waiting for your answer. Then I will tell you their shapes. Then shapes I am going to tell you, kids. Let's see who is going to find it out fast. Phosphorus is having 5 electrons in the outermost shell. 1, 2, 3, 4, 5. Sulfur is having 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. Chlorine is having 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. Xenon is having 8 electrons in the valence shell. 1, 2, 3, 4, 5, 6, 7, 8. So kids, all are okay. PCl5 is sp3d. Okay, let's see, kids, what's your answer is being coming. Let me check it out. 1, 2, 3, 4, 5. SF4, 1, 2, 3, 4. CLF3, 1, 2, 3. CF2, 1, 2. Let's see who is going to calculate first, me or you. Cl, 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 Cl. 5 plus 0, 5. sp3d. Fluorine, 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 fluorine. 4 plus 1, 5. sp3d. All are sp3d. Oh, you are faster than me. You are faster than me. So 3 plus 2, 5. sp3d. 2 plus 3, 5. sp3d. All their hybridization is being sp3d. So their electronic geometry will be trigonal bipyramidal. All their electronic geometry will remain same because the hybridization is same. So the electronic geometry will remain same. Only the shape will get changed. So is everyone ready to see the shape? PCl5 we already know. SF4. Let's see SF4. If I am going to draw SF4, kids, my base will be according to the electronic geometry. Its steric number is 5. So electronic geometry will be definitely trigonal bipyramidal. This will never get changed. So the base trigonal bipyramidal. Always remember that sp3d hybridization. P3D hybridization, right? So how it is going to help, kids? How it is going to help? See, kids, if I draw its electronic geometry, that is S, and electronic geometry like this, 1, 2, 3, and one above the plane and one below the plane, like this. Okay, this is the electronic geometry. Now, kids, who occupies more space? Do let me know, the lone pair or the bond pair? Who occupies more space? Just give me the answer. Then the answer is lone pair occupies more space. Lone pair need more space, more repulsion. Now, kids, you see this is the equatorial position, and the equatorial position is having bond angle of 120 degree. So which place lone pair would like to remain? Lone pair would, because of maximum space they want to occupy, maximum repulsive forces they will give, they would like to occupy equatorial position. Remember that lone pair will occupy equatorial position. Equatorial position, remember that, equatorial position. So this is going to help you. Put one lone pair here and rest of the fluorine over there, you will get the shape. Just see, I have added one lone pair at this place, one fluorine 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 at this place. Now I can find out, I will try to see the shape. Just see this one, just try to see this one, this one, this one, and this one. Just see, it's looking like somewhat. Let me show you, let me show you how it is looking like. Just see, if I say this is sulfur, if I say this is being sulfur, and this is being fluorine, this is being fluorine, and it's somewhat like this. See, kids, because this space is occupied by the lone pair. Here the lone pair is present. It's looking like something like seesaw. Seesaw. Have you seen the seesaw? A distorted tetrahedral seesaw game, that it was like this. See, kids, it was like this. Seesaw, you must have played in your childhood. This was the game like seesaw. Seesaw. Not remembering, then you can see like this. It was something like this seesaw. This was the place there. One Ramu was seated, one Shamu was seated. Are you getting my point? Ramu and Shamu were sitting seesaw. Have you heard this name, seesaw structure? Seesaw. That was the game of balancing, or we can say distorted tetrahedral. Distorted tetrahedral. I hope that everyone is able to understand SF4 is like this. If it is clear, then do let me know. Otherwise, I will tell you something else. If everyone is able to understand, kids, if it is clear, oh, from Bangladesh, Shimul, that's really fantastic. Now, CLF3. I'm going to tell you about CLF3. Just see to it, kids. CLF3. CLF3. Now CLF3, chlorine is the central atom, And first, let me draw the electronic geometry. Once again, I would like to say the electronic geometry will not get changed. The electronic geometry will remain like that only, my dear students. This, 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 one going above the plane, one coming downward side. This will remain trigonal planar. Now it is having how many lone pairs? Chlorine is having two lone pairs. So equatorial position I will give to the lone pair. That is my point. The lone pair will get equatorial position. So these three positions are being left. So on these three positions I will put fluorine, 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 and I will try to make the bond. Just see to it. I'm going to draw the bond. This is one bond. This is another bond. This is another bond. See how it is looking like. You just take it out like this and you will get the shape. This is the chlorine. One bond is this side. This is fluorine. This is fluorine. And this is the fluorine. Just see, it is looking like which shape. Just try to understand which shape. T-shaped. Little bit fluorine due to the lone pair. Due to the lone pair, fluorine are coming little bit downside. So it will be slightly tilted toward this side. So when T-shaped, either you can say T-shape or you can say pit bend T-shape. If T-shape is given, then it's fine. Otherwise, bent T-shaped. Bent T-shaped. Because once bent T-shaped was written for the IIT. So I hope this much is clear to all of you. Everyone is able to understand this much. Now XEF2. I'm going to tell you XEF2. XEF2. First of all, do let me know that everyone is able to understand, my dear students. Some kids, I think, they got tired. They have gone. Kids. Now see kids. It's not everyone's cup of tea to remain awake for this much time. I don't think that everyone is able to remain. Now kids, okay, my God, thank you. Now see kids, strength is getting decreased and I am feeling bit not good. See kids, molecular orbital theory, its concepts, number of things. I know that the students, those who have gone, they will see the recording, but as the strength, if it is getting decreased, what Baba will do? Kids, show me the hearts. You will remain till the end. After this, I'm going to give you the formal charge. I will make easy the formal charge. The dipole moment, I will make that also easy. And the molecular orbital theory, it's brilliant tricks I will give you, and the difference in between those electronic configurations I will tell you, kids. Thank you, kids. Thank you. I can see your love, your respect, and this is really going to give you selection. Thank you. I don't know, kids. Last time it was 2:30, 2:30 in the morning. Oh, thank you. Thank you. Nawab's World. Oh, great, great, great. Wow, thank you. Now see kids, CLF3. Now I'm going to tell you XCF2. XCF2. Now XCF2, it is steric number is 5. Hybridization is sp3d. So let's see the electronic geometry that will not get changed. Now the electronic geometry not going to change XE. Now let me try to make the electronic geometry, and the electronic geometry is like this: trigonal bipyramidal, trigonal bipyramidal. But it is having how many lone pairs? As I have told you, xenon is having total 8 electrons: 1, 2, 3, 4, 5, 6, 7, 8. two fluorines, it has formed the bond. So 3 lone pairs are there. Who is going to occupy the lone pair? Means where the lone pair will occupy the space, equatorial spaces, it will occupy equatorial. This is equatorial, this is being equatorial, this is being equatorial. Now where the fluorine will lie? The fluorine will lie over here and here. Now you can see the shape. You can easily find out the shape. Shape is being linear. Can you see? Linear shape. Everyone, can you see? This is axial, and the shape is linear shape. Everyone, linear shape. I hope that easily you are able to understand. Very easily you are able to understand. Now I am going to tell you the bent theory. Are you ready? Till now, is it okay? Till now, everyone is able to understand. Now I am going to tell you the bent theory. Bent theory. Just see the bent theory. Bent Bent theory says, this theory says, according to this theory, more electronegative atom or atoms will occupy that position where percentage of S character, where percentage of S character is minimum. Now, my dear students, you know very well at which position percentage of S character is being minimum. Do let me know. That means clearly we can say they are telling us about what? That more electronegative atom will occupy which position according to this statement. That means they want to tell us that more electronegative atom will occupy axial position. Am I right? Am I right, kids? Because I have divided sp3d like this. sp3d has been divided like this. sp2 plus pd. And this was not having percentage of S character, 0% of S character, and this were axial, forming axial, and they were forming equatorial, right? Now this is going to help us to find out where which element will take place. For example, if somebody has given you compound like this, PF2Cl3. Now how will you draw the structure? Which will occupy axial, which will occupy equatorial? Which will occupy axial, which will occupy equatorial? Now gets very easy. First of all, we will find out the steric number. That will come out 5. Then we will find out hybridization. That will come out sp3d. Then we will find out electronic geometry. That is trigonal, bipyramidal. Now it's very easy that fluorine will occupy axial position and chlorine will occupy equatorial position. So the structure will be like this. Very much clear to us that chlorine, 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 3 chlorines will be located at equatorial position. Am I right, kids? If not, then do let me know in the chat section. And if I'm right, then show me thumbs up that they will be present over here in this way. Trigonal, bipyramidal, they will occupy all three equatorial positions and their bond lengths will be shorter, and the fluorine will occupy equatorial position or axial, definitely axial position. This will be fluorine and this will be fluorine. So they are occupying axial position, axial position. Their bond length is more than the equatorial. Are you getting my point? Got it? This is the theory, and this is known as Bend's theory. Bend's theory. This is known as Bend's theory. Is it clear to all of you kids? Yeah, more electronegative element, because this, the more electronegative element will try. So if I am not saying about Bend's theory, you can think yourself. The one who is more electronegative will try to withdraw electron and will go far away. Its distance will be more, and the more electronegative element will withdraw electrons, so the bond length will be more. You see in your NCERT class 12th, just see ECl5, the element which is present at axial position, its bond length is more than the one which is present at equatorial position. You can see. Got it? Everyone got it? I hope that everyone got it. Now we can find out any structure, any element. Just see. If I say, if somebody has given you XeF4, XeF4, and he is asking, find out the shape. If examiner is asking to find out the shape, the hybridization, the electronic geometry, these many things have been asked by the examiner. Now what will you do? Always remember that one thing, how to start. Find out the group of xenon. Once the group of xenon you got, you will get its number of electrons in the valence shell. The group is 0. That means xenon is having 8 electrons in the valence shell when it is not in the combined state. Now 4 fluorines, combine 4 fluorines, 1 fluorine, second fluorine, third fluorine, fourth fluorine. Now after this, what you are supposed to do, just find out steric number. After this, you are supposed to find out steric number, and steric number is equal to number of sigma bonds plus lone pair localized, not taking part in resonance. So 4 sigma bonds plus 2 lone pairs, 6. So it is sp3d2 octahedral shape or geometry. Shape we cannot say, because lone pair shape will not come equal to electronic geometry, but electronic geometry is definitely octahedral. Now we got octahedral. This will help you in finding out the shape. Let's see how to find out the shape. We have drawn Xe. Now octahedral geometry says that it should be like this. It's supposed to be 1, 2, 3, 4, 1 up, 1 down, but there are 2 lone pairs. Anywhere you can keep the lone pairs, all the positions are same. So sorry, I kept 1 lone pair over here, 1 lone pair over here. Now I got fluorine, 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 fluorine. Now you can see what is the shape. What is the shape coming out, kids? It is coming out square planar, because 1 lone pair has cancelled out another lone pair, and its shape is coming out square planar. Its shape is coming out square planar. Everyone able to understand, my dear students? You got it? Is it clear? If yes, show me. Wow. Wow. Why not here? Axial, equatorial. All they are equal. It is just the thinking way. If you see octahedral, all the bond lengths, all the bond angles are 90 degrees. See, it is going like this. Let me show you. Let me show you. Let me show you, kids. All the bond angles are the same. So the bond lengths are also being same. Let me show you. Kids must be thinking, why not axial equatorial over here? Just see, kids. See, kids. If I say SF6, SF6, this is sulfur. Now, if I draw one bond, just take this as the plane. This is the plane. One bond, sulfur, it's going like this. Fluorine like this, and the fluorine like this, 90 degree. The same bond is 90 degree. All the bond angles are 90 degrees. So all the bond lengths are equal. There is no change in the bond lengths. All of them, they are equal. So there is no axial, there is no equatorial, my dear student. Just see this one. Just see this one. 90 degree. You see the bond angle is 90 degree. Can you see? This is being 90 degree. 90 degree. Can you see? This one, this is also 90 degree. This one, just see, all these bond angles are being 90 degree. Just see this with this is 90 degree. With this is 90 degree. With this is 90 degree. All they are being 90 degree. Now this is going, it's looking like it's going up and down, but all they are being same. Just see octahedral, all they are same. This is also forming 90 degree. Only it is also forming with this 90 degree. It's going like this. It's up, going like 90 degree. It's going 90 degree. Got it, kids? So all bond angles are 90 degree. All bond angles are 90 degree. So all the bonds are also equal. There is no axial, there is no equatorial. Now see, kids, if I say I'm having, this is the question for you right now, you have to do XEF2. I'm having XEOF2. I'm having XEO2F2. And I'm having XEO3F2. How many I have given? 1, 2, 3, 4. Just find out each and everything. The biodata of these A, B, C, D, D, A, B, C, D. The steric number, then the hybridization, and the electronic geometry, and then the shape. Let's see how many of you are able to understand it. So let's solve it all together. XE8, 1, 2, 3, 4, 5, 6, 7, 8. Xenon once again 8. Xenon once again 8. Xenon once again 8. Now, fluorine, 2 fluorines. 2 fluorines, I made 2 fluorines. Now, oxygen forms double bond, fluorine, fluorine, XeO2, double bond, one double bond, another double bond, fluorine, fluorine. Now 3 double bonds, 1 oxygen, 2 oxygen, 3 oxygen, fluorine, fluorine. Now just see to it. Pi bond has nothing to do with the steric number. Remember that. Pi bond has nothing to do with the steric number. Always remember this point, my dear students. pi bond has no role. Pi bond has no role with steric number. With steric number. No role with steric number. This is the point to be noted, my lord. Now let's find out. Let's find out. 2 steric number is equal to 2 sigma bond plus 3 lone pair. 5 steric number is equal to 2, and this is sigma. One is pi. One is sigma, another one is pi. 1 sigma, 2 pi, 3 sigma. 3 plus 2 coming out 5. Now sigma, 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 then pi. One is sigma, another is being pi. So 1 sigma, 2 sigma, 3 sigma, 3. No, how many sigma? 1, 2, 3, 4 sigma. Sorry, 4 sigma. So steric number will come out 4 plus 1 lone pair, 5 sp3 d. 5 only. Let me write down 5. And here 1 sigma, 1 pi, 1 sigma, 1 pi, 1 sigma, 1 pi, 1 sigma, 1 sigma. How many sigma? 1, 2, 3, 4, 5. 5 plus 0 is being 5. So all their steric number is coming 5. So all they are being sp3d hybridized. Am I right, kids? All of them, they are being sp3 hybridized. sp3 hybridized is saying the electronic geometry will be trigonal bipyramidal. Trigonal bipyramidal, and this will help you a lot in finding out the shape. But till now, if it is clear, then I can tell you the shape, kids. Then I can tell you the shape. Till now, if it is clear. Now, if this is clear, then I can show you, kids, XE and trigonal pyramidal, how it will look like. See to it. Will look like trigonal bipyramidal. 1, 2, 3, lengthier and lengthier. It will look like this. It's okay? No, it's looking bad. Let me make it clear. Yes. Yes. Okay, Baba. Okay. Now one going up. Now one going down. It's looking better. It's looking better. Now let me copy it. Let me make files of it so that it can be used. Now see. First one was XCF2. That means 3 lone pair. Lone pair will occupy equatorial positions. Hey, I'm looking good. I have occupied equatorial positions. Okay, lone pair repulsion is maximum. This repulsion is of 120 degree. Now, 2 fluorine swing left. 1 fluorine will go up. Another fluorine will go down. And this is the bond. You can see clearly, my dear student, one bond, another bond. This is linear shape. Can you see, kids? Can you enjoy linear shape? PeCl2 was having linear shape. That's hybridization was sp, no lone pair. Its shape is also linear, but its hybridization is sp3d. Because of the lone pair, it is being linear. Now see, if I say XCOF2, now my dear students, definitely fluorine will occupy this position, this position. Now double bond O will occupy this position only, and the lone pairs will remain over here. Now which shape? I must have told you this shape. Just focus on this shape. It's which shape is this? Let me draw it properly so that you can get some hint. You know this shape. Which shape is this, kids? Only consider sigma bonds for the shape. No role of pi bond. Pi bond does not give any idea about the shape. Which shape, kids? Everyone, seesaw. For seesaw shape, how many sigma bonds are required? 4 sigma bonds. It is being T-shaped. Can you see this is being T-shaped? Can you get it? This is being T-shaped, distorted, bent T-shaped. Can you get it, kids? Just see to it and try to find it out. Now, if I could have drawn it like this, see, then you could easily determine, see kids, if I have drawn it like this, see, two lone pairs, one lone pair if I keep it over here, one lone pair if I have kept it over here, and then the sigma bond with oxygen and pi bond if I have drawn over here. Now you can easily, you would have recognized it easily. Just see, now it's easy, it's looking easy, it's all the thing of visualization. Now everyone can see this is T-shaped, T-shaped. Now another one, XeO2F2, XeO2F2. Once again, have to draw Xe. Now, the electronic geometry will be same as I have told you. This, this, this. One going up, one going down. You can see. Now, O2. Where I have to place O2? Definitely O, one sigma, one pi, sigma pi, sigma pi, and O2 I have kept F2. Now I have to keep F and F over here. Now try to understand the shape of this and you can easily get it. Xe F2O2. Which shape it is looking like, kids? Do let me know. Now you can easily recognize which shape it is. Seesaw. Very good. Seesaw or distorted tetrahedral. Now my dear friends, XeO3F2, XeO3F2, no lone pair, no lone pair, so easily you can find out XeO3F2. It's very clearly visible, kids, very clearly visible. It is how many sigma bonds it is having? 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma. This pi, 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 you can see pi, pi. So trigonal bipyramidal is the shape. Kids, hey kids, how are you? How are you, kids? Do let me know. Those who are new, please hit the like button. Let's make it 700. Only 25 more likes for 700. It's, call your friends. It's 12. Thank you, Laharika. It's 12. It's 12 now. Now I'm going to tell you the formal charge. How many of you feel uncomfortable with the formal charge? Then I will tell you how to find out the formal charge. Nawab's World. Who is there with Nawab's World? Welcome, welcome, welcome. Wow, thank you, thank you. Now I'm going to tell you about the formal charge and then I will tell you molecular orbital theory. Definitely, definitely. Okay, okay. Now see the formal charge. Gets the formal charge. We are going to deal with formal charge. Formal charge. Most of the people must be thinking that formal charge We are not able to visualize, sir. We are never liking this. No one is liking the formal charge. Now, my dear students, first of all, I will write down the formula which is given in your NCERT. How many of you are always forgetting this formula? You are not able to remember this formula. Do let me know how many of you are not able to remember this formula, the formal charge formula. How many of you are facing this thing, that formal charge is equal to what? The formula getting slipped. Formula of formal charge. First of all, good morning. Oh my God, it's morning. Welcome, welcome, my dear students. Let me have a glass of water and welcome to all of you. Wish you a very happy morning, my dear students. Good morning to each and every one of you, my dear students. Good morning, good morning. Very, very good morning, kids. Very, very good morning. Now, see, kids, break after 12:30. Yeah. Thank you. Yes, I will give. Definitely at 12:30, I will give you one break. Good morning, kids. Means after formal charge and before molecular orbital theory, means after formal charge, I will give you the break. After formal charge, molecular orbital theory. After molecular orbital theory, dipole moment. Okay, at least this much, right? And then if you are having energy, I will tell you the banana bond. And one thing very, very important, oxy acid. The trick for oxy acid, I will tell you, know where you are going to get, that is a P block. If you are having energy up to that time. Now, kids, formal charge. If I talk about your NCERT, just see your NCERT. Okay, thank you. Just see your NCERT. Let me tell you the page number. Let me tell you the page number 100. What's written over there? Formal charge of an atom in a Lewis structure. I'm writing that. Formal charge of an atom in a Lewis structure. Now see, kids, what the NCERT is writing. Number of electrons in the valence shell when electron was in free state or alone. Number of electrons, let me write down it properly, otherwise you won't be able to understand. Number of electrons in valence shell. This valence shell is not talking about, that formula is not talking about the combined state. This formula is talking about number of electrons in the valence shell when atom was free. When atom was free means not in combined state. That is not in bonded state. Not in bonded state at that time. So at that time, how many electrons? So definitely you can find out with the group number minus what is minus 1 minus and half of another 1 minus. Now what is that? And it's becoming lengthy. First minus this slot minus half of this slot. What is that? No, it's not bonding minus anti-bonding. That you have gone to the molecular orbital theory. You have gone to the molecular orbital theory. You have gone to the molecular orbital theory. Now see what NCERT is writing, minus half, minus half. What should be that? Now most of the time people are getting not in their mind what is that. Valence minus lone pair minus half of the bond. Lone pair, just see lone pair is there or something else is written over there. Most of the students just see your NCERT page number 100, just see to it. Total number of valence electron in the free atom minus total number of non-bonding electrons. Here it's written total number of non-bonding electrons. Total number of non-bonding electrons. Now kids, it's very tough to remember. I will give you super amazing tricks, 2 tricks, not the tricks, they are logics. Baba HSP's logics I will give you. For that, you need not to remember any formula. Now, okay, now here half of, what should I write? Half of, everyone do let me know, half of what should I write? See your NCERT everyone, what should I write? Half of, everyone I am waiting for your answer. Break I will give you just after formal charge, I will give you. Everyone, half of, it's written half of total number of shared electrons, half of total number of shared electrons, half of total number of shared electrons or bonded electrons. Now see kids, this formula is very huge, very tough to remember. Now how many of you want simple formula and then visualization? How many of you want kids? Do let me know. How many of you want? Okay. See, I'm going to tell you in my way that formal charge is equal to number of valence electrons when it was free, in free state, minus vandita, bonded electrons. Vandita means bonded plus dots, this much only. Better to say bonds, not the bonded. Otherwise, we have to subtract bond or bonds plus dot or dots. Dot or dots. That's it. Is this formula easy or tough? Is this formula easy or tough? The meaning is same. Answer will come out same. The meaning is same. Let me show you. Dots. And if you are writing lone pair, you have to make it half. See, there we have written lone pair. Total number of shared electrons we have divided by 2. So one bond is formed by 2 electrons. So this means same. Either you do half of total number of shared electrons, or you can write bond. Either you can write bond, one bond means 2 electrons, or you can divide it by 2, then also it will come 1. Are you getting my point, everyone? So let me rub it and let's find out the answer. So which one is easy? This is the HSP formula, and that is NCERT formula. What do you think, which one is easier, kids? This one is NCERT formula. Which one is easier, NCERT or HSP formula? Number of valence electron in free state minus bonds plus dots, bond dots. This one is easy. Okay, HSP formula is easy. Let me show you the questions how to do it. See, kids. CO2. And after these two things, I will tell you one thing where no formula is required. The visualization I will show you. The visualization. See, let's find out formal charge on carbon. Let's find out formal charge on carbon. Now, formal charge on carbon. Apply the formula valence electron minus bonds plus dots. Now just apply number of electrons when it was not in combined state, 4 minus how many bonds? 1, 2, 3, 4. 4 plus dots means lone pairs electron. Dots means lone pair electron, 0. So it is coming out 4 minus 4, 0. Definitely 0. There is no charge on carbon. Let's find out formal charge on oxygen. Formal charge on oxygen. Formal charge on oxygen. Let's see. Oxygen 6 minus bonds. Bonds 2. Lone pair 1, 2, 3, 4 dots. 1 dot, 2 dot, 3 dot, 4 dots. 4 dots. 4 plus 2, 6. 6 minus 6, 0. Everyone is able to understand this also. We are able to understand this also. Then now I am going to give you one tough example so that you can understand. Now see, kids, I am going to give you one tough example. Just see, if I say I am having carbonate. I'm having carbonate CO3 2 negative. Now one oxygen is having no charge, another oxygens they are having 1 negative charge. Now let's see. I'm good Vishesh. Come on. Now see, kids. Now let's see, kids. Carbonate CO3 2 negative. Now which oxygen would you like to see? This is yellow oxygen without charge, and this is red oxygen or pink oxygen with charge. Just do let me know where should I find out, so that the concept will become easy, more clear. The oxygen which is having negative charge, or the oxygen which is not having any charge. Which oxygen? Let me number them. This is A, this is B, this is C. Which one? A, B, C. Pink one. Okay, pink one. C. The for everyone is saying pink one. So the formal charge on Pink oxygen. Pink oxygen, right? See kids, the number of valence electron will remain same only. In the oxygen outermost, there are 6 electrons minus bonds plus dots. Now see kids, 6 minus, how many bonds are there? How many bond? Only one bond is there. One bond plus dots. Now see kids, oxygen is having its 6 electrons. One negative charge means one more electron. So 1, 2, 3, 4, 5, 6 and 1 electron for the negative charge. So how many doubts? Doubts, no doubts. I'm saying doubts. How many dots are there, kids? How many dots? See, that is bonded. 1, 2, 3, 4, 5, 6. 6 dots are there. So 6. So 6 minus 7. The formal charge is minus 1. Minus 1, kids. You see, it is having minus 1 charge. It is coming minus 1. You got it? Everyone is able to understand, kids. Everyone is able to understand. You got it? Done and dusted. It is done and dusted. So the formal charge, you can easily visualize what's the, and minimum is the formal charge, more is the stability. Remember that minimum being the formal charge, more will be the stability. Minimum is the formal charge, better will be stability. Now kids, the second break, it's 12:17. Now kids, after 20 minutes, we will meet. You can say it's 20 and 40. So we will meet at 12:40 a.m., right? It's a break time, kids. Now, kids, will you come back with the same energy? Will you come back with the same energy? Come with more energy, more energy at 12:40 a.m. It's short break. Okay, kids, let's have something. Okay, kids. Thank you, Nawab's World. Thank you, thank you, thank you. Kids, sir, it is 5 for oxygen, right number of dots. See, Sharbesh, oxygen is having 6 electrons of its own. One is bonding, one is taking part in bonding, so we cannot count dot. This is being bonded, can't be counted. This is taking part in bond. So how many? 1, 2, 3, 4, 5 and 1 for negative charge, 6. See, oxygen is having 1, 2, 3, 4, 5, 6 of its own. One negative charge means one more extra electron it is having. One more extra electron it is having. One has taken part in bonding. This has taken part in bonding. This is bonding one. So now how many dots are left? How many surveys? Just see 1 dot, 2 dot, 3 dot, 4, 5, 6 dots. Clear? Surveys? Is it clear? Is it clear? Okay, let's meet after some time. Namaskaram, all my dear students. Welcome back to see the punctuality. Punctuality means a lot. I can see my kids are awake. All my dear students, I can see your punctuality, your energy level. Those who are really doing hard work, success is waiting for them. The beginning is always tough, but always say to yourself, once I'm in it, I become unstoppable. So, once again, good morning. Welcome back to your Unacademy NEET English channel. Those who are new, please smash the like button. And now, my dear students, Baba is going to tell you the MOT theory, molecular orbital theory. That is really the best part. I'm here with MOT theory. That means a lot. Molecular orbital theory. You must have heard the name of molecular orbital theory. Number of questions must be having regarding that. I will clear each and everything, kids. Baba is here to clear each and everything, kids. Let's see. Molecular orbital theory. Are you ready? Say everyone. This is the morning time. Wake up, wake up, wake up. Kids, yeah, from yesterday to today we have come. So let's start. Let's start, kids. Let's start. Molecular orbital theory. Molecular just wait for a sec. I think it's not responding, but let me tell you, my dear friends, what is the meaning of molecular orbital theory? That we are going to form molecules. You must be thinking number of times that up to 14 electrons in a molecule, the configuration is different. And after 14 electrons, the configuration gets changed. Why? Number of times you must have thought like that. Yeah, board is, let me wait because board was not responding. Till now it's not responding, kids. Yeah, here it's working. Let me see. Yeah, started working, kids. It started working. Okay, fine. So molecular orbital theory, MOT, molecular orbital theory. That is MOT. MOT. Now, kids, should I tell you the short trick first or should I tell you in detail first? Because you are still awake for your Baba HSP best concepts. So, this is the privilege Baba HSP is going to give you, kids. Yeah, I will forget. I will wait for the board to work properly and definitely I will share each and every PDF this time. Short trick first or detail? Those who want the short trick first, show me the hearts. Those who want to know in detail first, show the fire in the chat section. Let's see whether the hearts are more or the fire is being more. Just see what is more. Hearts for the short trick first fire in detail first. Let's see who is going to win. I will give you both the two things. In detail, I will teach. Short trick also I will give. But I can see the fire is going to win. More fire in the chat sections. That's really salute. Okay, so decided. It's decided finally. So I'm going to give you in detail first. See, kids. The molecular orbital theory, what it's going to say and how to write down the electronic configuration. Just see, if this is, if the sum of electrons if the sum of electrons is greater than 14, then how to write down the configuration. Just see first how to write down sigma 1s, maximum electrons you can fill, then sigma anti-bonding 1s, you can fill the electrons. Then in place of these two, you can also write kk. Kk means nearest to the nucleus, nearest to the nucleus. So kk, it's been kk. After this, you can write sigma 2s, sigma anti-bonding 2s. Now, till now, its symmetry is there. You can see sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s. Now, kids, have you ever eaten pizza? What is filled inside the pizza? One pizza, one pizza. In between the pizza, you can fill some SP, SP, XY, XY, something like XY, XYZ, anything XYZ, whatever is filled, we don't know XYZ. So see, I will write sigma 2pz and I will end with sigma 2pz. So let me write down this thing over here. After this, I'm writing sigma 2pz and I'm writing sigma anti-bonding 2pz. This is your pizza, like pizza. One pizza, another pizza, and in between this pizza, I'm going to fill something. Sigma 1s, anti-bonding 1s, 2s, anti-bonding 2s. I will give you the reason also. Why I'm writing like that, I will give you the reason also. Right now, I'm telling you about the NCERT. What's written in the NCERT, that I'm telling you. 2pz. This is like pizza, that is like pizza. Let me write down. These are like pizza. 2 pizza, 2 pizza. Round, round pizza. See, circular 2 pizzas. Are you keeping it in your brain? Circular 2 pizzas, anti-bonding pizzas. Now, in between this, I will fill pi 2px is equal to pi 2py, and then I will fill pi anti-bonding 2px, pi anti-bonding 2px is equal to pi anti-bonding 2py. This energy is more. Can you see, kids? The energy is increasing like that. Here, little bit congested, but you can manage. Can you see, kids? Can you keep it in your brain? Are you able to keep it in your brain? Now, this is for electrons greater than 14. And I will tell you this electronic configuration is because there is no SP mixing. What is this SP mixing? I will let you know. No, it is due to no SP mixing. What is this SP mixing? I will tell you in detail. There is no SP mixing. That's why this is the diagram. It's like this. But first of all, you should know how and how to write. Then only you can understand that is hi-fi thing, and I will let you know. Now, once you are able to write it down, just help me and tell me what I have written. Just help me, my dear friends. Let me see whether you are able to help me or not. So if I say that for electrons more than 14, if I want to write down the electronic configuration, molecular orbital electronic configuration, how should I write? Sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s. Now, what should I write? What should I write, kids? Sigma 2pz, 2 pizzas, and end with sigma anti-bonding 2 pizzas. And in between, what will be there? This pi 2px is equal to pi 2py. Everyone, you have to repeat along with me. Then pi anti-bonding 2px is equal to pi anti-bonding to py. Something is filled inside the two pizzas. Pizza, and xy. Something xy is there. Bonding and anti-bonding xy is there. This is being bonding xy, equal energy, bonding molecular orbital, and this is being anti-bonding xy, ABMO, anti-bonding molecular orbital xy. Now you can remember this or not, kids. First of all, do let me know. Everyone, do let me know. Now, if you are able to fill it, then I will let you know that more than 14 electrons you have filled. If the electrons are less than 14 or electrons are 14, then how will you write down? Just you have to do one thing. If the electrons are 14 or less, this sigma 2pz will come over here. That's it. No need to learn this. From here, it will go there. It will go over there. Its position will be there. So no need to learn it. And why that is going to happen, let me tell you, kids. Let me tell you. See, why that is going to happen. See, first of all, let me tell you, if electrons are equal to or less than 14, then the configuration will be like this: sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s. Now 2pz will go. So what is there? Pi 2px is equal to pi 2py, and sigma 2pz is over here. Sigma 2pz at this position, and after that sigma 2pz pi anti-bonding 2px is equal to pi anti-bonding 2py, and then the sigma 2pz. Now kids, why it has gone over there? Its position was supposed to be over here, but it has gone over there. This is due to SP mixing. This is due to SP mixing. Now, this happened due to SP mixing. Now, how many of you are interested in understanding what is SP mixing? And this SP mixing takes place in B2, C2, and N2. These are the three main molecules where SP mixing is majority is going to take place. SP mixing takes place in these three mainly. Now kids, how many of you are interested? Show me the thumbs up. Let's see. Let's see how many of you are interested to understand that to understand that, see, its sum of electron is how much? Its sum of electron is 10, its sum of electron is 12, its sum of electron is 14. Now, why the sp mixing is going to take place? Now, suppose boron, carbon, nitrogen, I take boron only. If I take boron only, boron, its atomic number is 5, right? I will write 1s2, 2s2 and 2p1. From here, the filling of p orbital takes place. From this element, filling of p orbital takes place. My dear students, you have to focus over here, because if tough question is going to be asked, because number of times last to last year IIT has asked 2 questions, but before that once again 1 or 2 questions. So everyone, you have to listen. From here the p orbital started filling. Now my dear students, as we go from left to right, what do you think? If I say, if I move from left to right, like boron, carbon, nitrogen, oxygen, chlorine, neon, what will you say about the Z effective? Z effective will increase or decrease? Do let me know. Its Z effective will increase. This we have studied in chemical bonding. Z effective will keep on increasing by 0.65. Means it will go like this, Z effective. If the Z effective is going like that, the force of attraction of the nucleus will be on S as well as on P, but the penetration power of S is more than P. So the force of attraction by nucleus proton will be more on S rather than P. So due to Z effective, the force of attraction will be more on S than P. Will be more on S than P. So keeping this thing in mind, I'm going to draw one diagram. Just see to it, everyone. The diagram I'm going to draw. Now, if I say this is energy on the y-axis, if I say this is being energy level, and here the atomic number is increasing, then see how the line will go. If I say this is the force of attraction on p orbital, this is the force of attraction on p orbital, white line I'm drawing. This is the force of attraction on p orbital. So atomic number is increasing, the energy is decreasing. You can see energy is getting decreased. Suppose if I say here is boron, here is boron, here is carbon, here is nitrogen. Okay, P2C2 like that, I will draw like that, nitrogen. And if I say here is being oxygen, chlorine and neon, this is the energy of p orbital. This is for p orbital, indicating for p orbital. Definitely, if the Z effective is increasing, the hold of nucleus on p orbital will be more. So the energy of p orbital will keep on decreasing. Now, if I draw for S, now kids, if I draw for S, it will look like this. See, it will look like this. More force of attraction it will feel, and it will go like this. The graph will go something like this, kids. Now see, bond of equality is good and bonding of equality is good. This thing I'm telling you from the very starting, that bonding of equality is good. This thing I'm telling you, bonding of equality is good. That means bonding of equality is good. Means if you want to mix something, there should not be too much difference in the energy. What does it mean? If you want to mix something, there should be not too much difference. Now see, this is for S. This I have drawn for S. This is for S orbital. Now see difference in S and P. This is S, this is P. The difference is, here the difference is very less. Difference is okay, difference is okay. And after this, you see too much difference is there in between S and P. Too much difference in between S and P orbital. So here no mixing will take place. Kids, understand, here the mixing of SP is allowed. Just try to understand what I am telling you. Here the SP mixing is allowed. S and P orbital mixing. SP mixing is allowed. SP mixing is possible. SP mixing means in between S and P, 2S and 2P. That is 2S and 2P orbital mixing is possible. But here in these, because of too much energy gap, SP mixing is not possible. That means 2S and 2P can't mix up to that extent. That means SP mixing, that is 2S 2P mixing, is not possible. One thing is clear, then I will let you know why is that, because I'm telling you something new. So it's not that easy, kids. It's not that easy. Are you till now, are you able to understand that in this SP mixing, less energy gap, more energy gap? This energy gap is being less energy gap, there is being more energy gap, this is being more energy gap. So not possible. If this much is clear, then only I can explain you. How many of you are getting this much point is clear? Show me the thumbs up, then I can tell you the second point, why the configuration got changed. Why the configuration got changed. See, in between this S, this is line going of P orbital. This white line is indicating for P orbital. This white line is for P orbital, 2P orbital. And this blue line is for 2S orbital, 2S orbital. See, the energy gap is less because as you move from left to right, as we go from left to right, what is increasing? Left to right, Z effective, as the atomic number is increasing in the same period, for the same period, for the same period, Z is increasing. Z effective nuclear charge will also increase. So the nucleus will pull S as well as P towards itself side. S is more nearer because 2S comes first, 2P comes later on. So the effect will be more on 2S rather than 2P. So here in between S and P, energy gap is less and there is more, and this is being experimentally determined. Kids, clear till now? Now kids, what is the consequence of SP mixing? Just see. consequence of sp mixing, so sp mixing, first of all let me tell you, sp mixing is possible. Sp, that is 2s and 2p, mixing is possible only for electrons is equal to or less than 14. One point. I think this point is clear to each and everyone. This is the first point. Now, what is going to happen with this? How it is going to affect? See, 1s and 1s, linear combination of 1s and 1s will produce two new molecular orbitals, orbital, one BMO, another one ABMO. Can you see? BMO, ABMO, as we call it, sigma 1s, sigma anti-bonding 1s. Whenever two orbitals they are going to combine, linear combination of atomic orbitals will produce two new molecular orbital kits. One will be less in energy, one will be more in energy. One energy will get increased, another one's energy will get decreased. Now, when I am going to combine second orbital, that is 2s and 2p, they are lying in the same shell. They will lie in the same shell. Just see, 2s and 2p. Whenever I'm going to combine one elements 2s, 2p, here 2s and 2p, here 2s and 2p. Now, due to sp mixing, the new molecular orbital is getting formed. So, sigma 2pz and 2s2, there will be what? There will be more energy gap. Why more energy gap gets? When the sp mixing is allowed, that when this is going to combine, its energy will decrease, and its energy is getting decreased, then 2p energy will get increased. See what I'm saying. If I'm combining, this is one orbital and these are three orbitals. Just see, this is one orbital of 2s, these are three orbitals of 2p. How many orbitals will combine? 6 orbitals. 1, 2, 3, 4, 8. 3 of this, 6. 1 of this, total 8. When 8 orbitals are going to combine, 8 new molecular orbitals will get formed. And whenever the mixing is there, the energy of sigma 2s2 will get decreased. Due to sp mixing, mixing is, that means sigma 2s2 energy will get decreased. And if you know that if someone's energy is getting decreased, another one's energy has to get increased, and that's why its energy is getting decreased, then definitely sigma, this is also sigma, because after this only this is sigma 2pz, energy will get increased, and that's why due to sp mixing, in between sigma 2s2 and sigma 2p z, there is gap in energy, and due to this, in between these two, due to sp mixing, we can say due to sp mixing, and that's why due to sp mixing there is too much gap, there is too much gap in between energy of sigma 2s2, sigma 2s, and not 2, you can write any electron, 1 or 2, this is the electron, so sigma 2s and sigma 2pz, 2pz, sigma 2pz, too much. Now see, if you talk about p2, 10 electrons, p2, 12 electrons, n2, 14 electrons, in their electronic configuration sigma 2s2 and 2pz, energy gap is more. Let me show you, kids, let me show you. See, this is for greater than 14, no sp mixing, no sp mixing, right kids, no sp mixing, no sp mixing, no sp mixing. That means energy gap in between sigma 2s and 2pz, very slight difference, just see, very less difference, very less difference, because its energy has not gone decrease, very less difference. There is no sp mixing, no sp mixing, so very less difference. But see, here the sp mixing has taken place. See, here sp mixing, due to sp mixing, due to sp mixing, the gap between sigma 2s and sigma 2pz, too much gap. Can you see kids? Too much gap in between these two, this one and this one, too much, huge gap in energy, huge gap in energy, huge gap. Kids, how many of you are able to understand this concept? I think you must be studying for the first time. How many you got it? How many of you got it? I think this is, you are studying for the first time, or I think this is new to you. How many you liked it? How many you are able to understand? Yes, this is the in-depth knowledge. First of all, do let me know how many of you are able to understand, kids. Got it? Oh my God. These many students got it. Really fantastic. Really fantastic. Oh, that's really fantastic. Now, kids, if I say how to find out the bond order, how to find out the bond order, just see, let me tell you some points. Bond order. How to find out bond order? Bond order. Half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. This is one thing. First, I will tell you in detail, then I will tell you the short trick as we have promised, right? Okay. Now see, suppose if somebody is going to find out for O2, O2. Now, O2 means how many electrons, kids? How many electrons? 8 plus 8, that is total 16 electrons. Now, we know that its electronic configuration, how to write down? Sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s. Now no sp mixing, so 2pz is over here, sigma 2pz pizza, that is pi 2 px is equal to pi 2 py, pi 2 py. Now pi anti-bonding 2 px, pi anti-bonding 2 py. This we have got due to linear combination of atomic orbitals. We have got molecular orbitals. Whatever the number of atomic orbitals they are combined, they will give you the same number of molecular orbital, and they will follow Abbo, Pauli and Hund's rule. The filling of the electrons will take place in the increasing order of energy level, starting from the lowest energy level, and no two electrons in an atom can have same set of all the four quantum numbers, and Hund's rule says the pairing of the electrons will not take place unless and until all the orbitals are filled with single parallel spins. All the three rules. Now see, 16 electrons I'm going to fill. How to fill 16 electrons? 2, 2, 2, 2, 2 to 4, to 6, to 8, to 10, to 12, to 14, 15 and 16. 16 filled, kids? Do let me know. All well? All well? 16 electrons I have filled. Am I right, kids? Are they 16? Now how to find out its bond order? See to it. Bond order will be number of bonding electrons 2. See kids, here is star I have added sigma, anti-bonding sigma. This star should not be there. This star should not be there. 2 to 4 to 6, 8, 10. 10, right? Now 10. So 16 minus 10, 6 are left, divided by 2. 10 minus 6, 10 minus 6, 4, divided by 2, that is 2. 2 is the bond order. It's clear? Is it clear, kids? Hey everyone. Everyone, do let me know. Got it? Now, the bond order we have calculated. One thing we have calculated, that is the bond order. The second thing is being, if unpaired electrons are there, this all the things I will tell you in the short trick, paramagnetic, diamagnetic, bond order, each and everything. But see, the unpaired electrons are there, so this is being paramagnetic. This is going to be paramagnetic as the unpaired electron. Due to unpaired electron, due to unpaired electrons, it is being paramagnetic in nature. I will tell you the short trick also. Now in this way you can find out the bond order. And remember that, wow, that's really awesome. Now, oh, that's really fantastic. Now my dear students, if number of electrons in the anti-bonding are more, then the compound will be unstable. Now kids, I'm going to tell you the short trick. Just see and watch it. Everyone just see to it. Short trick. I'm going to give you the short trick. Short trick by Baba HSP. Short trick by Baba HSP. Okay, ready everyone? Are you ready, kids? Just see to it. If I say I'm having lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The sum of electrons are coming how much? Sum of electrons are coming how much? Just see. 6, 8, 10, 12, 14, 16, 18, 20. Remember that you have to write down over here 3 bond order. Bond order here 3. 3, 2, 1, 0, 3, 2, 1, 0, 1. Can you see, kids? Now, if somebody's sum of electron is coming 15, let's suppose 15, then how much should be the bond order? 2.5. If some entity is getting 17, then how much should be the bond order? 1.5. If somebody is getting 19, 0.5, kid. 0.5. If somebody is getting 13, some entity is getting 13, 2.5. Some entity is getting 11, 1.5. If some entity is getting 9, 0.5. How is it, kids? How is it? And for isoelectronic entities, the bond order will remain same. I'm coming to this point. But first of all, do let me know, my dear student. If you're liking this trick, Baba HSP's trick, show me some hearts and fire in the chat section, kids. If you are able to understand. Once, if you are able to understand. 0 means no bond formation can take place. 0 means bond will not get formed. No bond. No bond formation will take place. No bond formation. No bond formation will take place. Whenever the bond order is coming 0, no bond formation can take place. No bond formation. Gets. First of all, do let me know. I know that you must got tired, but kids, I'm going to tell you such type of things that you can't imagine, you can't believe. Now, I will tell you in the short trick, I will tell you how to find out paramagnetic character. That I will let you know. When I come, Mr. He. Now see, kids. Let me tell you one thing. For isoelectronic entities, or you call it a species, bond order will remain same. Bond order will remain same. For example, just see, if I write down CO, NO, now just find out the bond order. C is how many electrons? 6 plus 8. Sum is coming 14, and for 14, the bond order is 3. For 14, the bond order is 3. So its bond order will also be 3. Bond order will be 3. Got it, kids? NO, 7 plus 8, 15. Now see, for 15, what was the bond order? 15, the bond order was 2.5. Its bond order will also be 2.5. Kids, are you able to understand? Is everyone able to understand? Do let me know, my dear students. Now, see, if I say I'm having O2, 2 plus, O2 single plus, O2, O2 single negative, O2 2 negative. Now what do you think? A, B, C, D, E. What should be the bond order? Find out bond order. Find out sum of electrons. Sum of electrons O2, 16 minus 2, 14, 16 minus 1, 15, 16, 16 plus 1, 17, 16 plus 2, 18. You know that the bond order, kids, bond order for 14 is 3, for 15 is 2.5, for 16 is 2, for 17 is, yes, 1.5, and for 18 is 1. Am I right, kids? Am I making any sense? Just do let me know, kids. Suppose if anyone is asking, find out the bond order for KO2. This is question asked in IIT as well as AIIMS. AIIMS has asked this question, IIT has asked this question. Now people will think how to find it out. Let me tell you, kids. There is ionic and covalent bond. Break it. K positive, O2 negative. O2 negative is having how many electrons? Definitely 17 electrons. And for 17, the bond order is 1.5. So the answer is 1.5. If somebody is asking for Na2O2, now Na2O2, how to calculate? Twice of Na positive and O2, 2 negative, 18, and the bond order for 18 is 1. Can you get it, kids? Everyone, do let me know, my dear students. Are you getting it? First of all, now after this, I will tell you the bond strength, the bond length, and the paramagnetic character. You must be thinking, sir, without writing electronic configuration, how to find out the paramagnetic or dimagnetic? Baba will let you know. Baba will let you know. No need to write down the electronic configuration. Baba will let you know. Yes, previous slide. Okay, see the previous slide. This one, I think this one, you are asking for this slide. You are asking for this slide. Kids, smash the like button. Those who have joined right now in the morning, kids. If you have joined in the morning, just hit the like button, kids. I want to see more likes. Baba is waiting for your likes, kids. See, the great teacher Baba is waiting for your likes. Smash the like button, kids. Smash. Smash the like button. Now, see, kids. Remember that if I talk about atmosphere, our atmosphere, our atmosphere is inert because of our atmosphere is inert because of atmosphere is inert, and who is responsible? Inert because of N2, nitrogen gas. Nitrogen is saying in between two nitrogens, the bond order is 3. Now, kids, the bond order is 3. What does it mean? It is indicating more is the bond order. Bond order is directly proportional to bond strength. Bond strength. And more is the bond strength, less will be the bond length. Bond length. I hope this point is clear to all of you. If the bond order is 3, the bond strength is more and the bond length is less. So I can say if the bond order is getting increased, the bond strength will also get increased and the bond length will keep on decreasing. Point clear to all of you. I hope that this point is very much clear. Now, the trick to find out paramagnetic and dimagnetic character, just see. It's just see. Everyone, see to it. Trick for paramagnetic and dimagnetic. Just see. Everyone, you have to cooperate. Trick for para and di. One thing you should know, diamagnetic means not attracted towards magnetic field, and paramagnetic means slightly attracted towards magnetic field. This thing you should know very well, right? Now, my dear students, if I'm having, just see, this is my shoe box. Let's say this is my shoe box, or you can say sandal box, shoe box. In one shoe box, maximum of how many shoes are possible? You can keep two shoes, one in this direction, one in this direction. Okay. Now kids, if I'm having three shoes, not pairs, three shoes, I'm not talking about pairs, three shoes. Can you keep three shoes? One box can contain maximum of two shoes. One box, a box can have maximum of two shoes, not more than that. Now, three shoes. Can you keep, is it possible to keep three shoes in a pair? Is it possible to keep three shoes in a pair? No. One will definitely remain unpaired. One will definitely remain unpaired. Am I right, kids? Am I right, kids? One will definitely remain unpaired. Kids, what happened to you? Write down yes. Now, this means whenever I'm having odd number of electrons, in case of odd number of electrons, always paramagnetic. It will always be paramagnetic. Agreed or not? Everyone agreed or not? If you're liking it, kids, if you're liking it, only after this, I have to tell you dipole moment. Let me complete molecular orbital theory, dipole moment. Then I will see to it. So don't worry, kids. Just 30 minutes more. 30 minutes more, kids. Now see, everyone, you got it. Now, kids, if I'm having even number of, if in case of even number of shoes, shoes are equal to electrons, shoes equivalent to electrons. I have taken in place of electrons, shoes in place of electrons. So what the analogy I have taken, kids, the box, shoe box is actually, shoe box is actually what? Orbital. Shoe box is actually orbital. Pauli has given rule that one box cannot contain more than two shoes, and they should have opposite head and tail. Everyone knows what's the need of scientist Pauli. So shoe box is actually orbital, and electrons actually what? Actually, no, sorry. Shoes are actually electron. Shoes are actually electrons. Shoes are actually electrons. Okay. Now, in case of even, if I am having even shoes, then what do you think? Paramagnetic, paired or unpaired? If I am having even number of shoes, they will be paired or unpaired? Now kids, even number of shoes, if I talk about even number of shoes, then mostly paired, mostly paired, except, 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 except 10 and 16, except 10 and 16. They are even numbered, but they are paramagnetic. Just remember 10 and 16. Except 10 and 16. 10 and 16 even, but then also paramagnetic. Paramagnetic. They are being paramagnetic. 10 and 16. Remember that 10 and 16 are the exceptional. Got it? Everyone got it, kids? Have you got it? Do let me know. Now every question can you solve immediately, kids? Now can you do any question immediately? Now this is the bond order. I've told you about diatomic molecules. Now how to find out bond order in case of molecules? Now kids, how to find out bond order in case of molecules? Everyone ready? Finding bond order in molecules. Bond order in molecule. Bond order in molecules means molecules. If I mean molecules means triatomic. Right now we have considered just diatomic molecules. Tri-tetratomic molecules are there. How to find out bond order? Now see, bond order will be equal to number of bonds, number of bonds taking part in delocalization, taking part in delocalization divided by number of resonating structures, number of resonating structures but these resonating structures only the most stable form, most stable. Now how to apply this formula? Is everyone ready, kids, to understand it? Bond order is equal to number of bonds taking part in delocalization or involved in resonance, number of bonds taking part in delocalization or number of bonds. I can write involved in resonance. This is easy to understand. If I write like this, number of bonds taking part in resonance, this you can understand easily. Taking part in resonance. Now see kids, if I take case of benzene, the most interesting case, benzene. This is canonical structure of benzene. This is another canonical structure of benzene. Now, if anyone is going to ask the bond order, now just see, if I consider this carbon, there are hydrogens, but hydrogens bond is not involved in resonance. So leave it. But you can see clearly that this pi bond is moving. Sometimes this pi bond is along with this sigma bond, and sometimes this pi bond is along with this sigma bond. So totally how many bonds of it are involved in resonance. This bond, because pi bond is doing resonance on this only, this is involved and this is involved. How many bonds of single carbon is involved in resonance? 1, 2, 3. So 3 bonds of each carbon are involved. So the bond order will be, kids, bond order will be 3, and 2 canonical structures are there, most accepted 2 canonical. So 3 divided by 2, the answer will come out 1.5. How many of you are able to understand, kids? How many you got it? How many of you got it, kids? Do let me know. Hey everyone, what type of talks are going on, kids? My dear students, where are you? Just do let me know, kids. The kids, those who were giving answer. Okay, let me take another example so that you can get more clarity. To get more clarity, let me take another example. See, kids, if I take carbonate, CO3, 2 negative, let me draw the structure. C double bond O, O negative, O negative. Now see, my dear students, this is the pi bond. Can you see pi bond? Right now it is on number 1 oxygen, number 2 oxygen, number 3 oxygen. Let me draw all the resonating structures, then you can easily understand. C, O negative, double bond O, O negative, C, O negative, O negative. Now see, kids, try to understand. 1, 2, 3. 1, 2, 3. 1, 2, 3. The pi bond, here it was on first oxygen, here it is on second oxygen, here it is on third oxygen. All these 3 are equivalent resonating structures. Is it clear, kids? First of all, do let me know how many resonating structures are there. There are total 3 resonating structures or canonical structures. These are being 3 resonating structures, or you can call canonical structure. Till now, is it clear? Now, how many bonds are involved? See, this is the pi bond which is moving, but this is moving on which sigma bonds? It is touching which sigma bond? It is touching this sigma bond. It is touching this sigma bond. It is touching this sigma bond. So the 3 sigma bonds, because they are allowing this pi bond to move and to touch them. The pi bond is doing resonance on the basis of sigma bonds only. The one pi bond which is touching all the 3 pi bonds. So total how many bonds are involved in resonance? Do let me know. Total how many bonds are involved in resonance? Do let me know, my dear students. Kids, I want to see your answer. Total how many bonds are involved in resonance? Total how many bonds? 4. So 4 divided by 3 is your answer. How much it will come out, kids? 4 divided by 3. 1 point something. 1 point. That something is 3, 3. Now, if you are able to understand, then tell me the bond order of this compound. Let's see how many of you are able to understand. ClO4 negative. Let me write down the structure also. ClO4 negative is like this. Cl double bond O, double bond O, double bond O, O negative. 7 valency. 1, 2, 3, 4, 5, 6, 7. Yes. Now I am not going to draw the resonating structures. Do let me know what should be the answer. Bond order. Laharika 4C, 4, 3 sigma bonds and this pi bond. Once this pi bond is attached to this sigma bond, suppose I am pi bond. I am one pi bond. I'm a teacher. I go and teach A, or 1. I teach 2. I teach 3. So I'm a teacher and 3 students. So how many kids? 3 kids and a teacher. They are becoming super educated. I'm becoming super educated by teaching, and they are becoming super educated because they are getting knowledge. Whenever the resonance is there, single bond acquires double bond character and double bond acquires single bond character. Both bond lengths getting changed. Laharika, it is clear, I think. Laharika, is that clear? Now kids, let's see. JDSS is writing 2.33. So you can see how many resonating structure. Now this is one oxygen number 1. You can clearly get an idea. 1, 2, 3, 4. Right now it is over here. It will come over there. It will come over there. It will come over here. So resonating structures will be how many? There will be 4 equivalent resonating structures. Am I right? If you don't know equivalent, no need to worry. Equivalent resonating structures, because they will be same. All of them will be same. Now kids, how many bonds are involved? You can see clearly that sometimes this is becoming sigma, single, sometimes that will become single, sometimes this will become single, sometimes this will become single, sometimes this double bond will become single, sometimes this double bond will become single, sometimes this double bond. So how many? 1, 2, 3, 4, 5, 6, 7. Total, how many are involved? 7. That means 7 divided by 4 will come out how much? 7 divided by 4 will come out 1.75. Okay. So kids, more is the bond order. More is the bond order. More will be stability. Either you can do the question like this, or even you can do the question, more the number of resonating structures, more will be stability. You can do this question in this way also from organic chemistry. More the number of resonating structures, more will be stability. Got it, kids? Everyone got it, my dear students? Now, these things I've told you. Now, kids, first, should I tell you the oxyacid trick, or should I tell you the dipole moment? Do let me know, my dear students. First, what you want to understand, the oxyacid trick, the banana bond, or the sp4 sp5 hybridization? What do you want? Dipole moment, oxyacids. Okay, once again there is tie. Those who wants dipole moment, show hearts. First, if you want dipole moment, show me the hearts. And if you want to go with oxyacids, show me the fire. Let's see, the fire is more or the hearts are more. For dipole moment, hearts. For oxyacids first, fire. Let's see, hearts are more or the fire is more. What is more, kids? Hearts are more. So the dipole moment. First I will teach dipole moment, kids. Let me have a glass of water. Kids, those who are new, smash the like button. At least make it 750. Hey, my dear students, it's a humble request. At least make it 750. Kids, let me see the likes are getting increased or not. So can we just add pi and sigma bond and no, don't do anything. By seeing 2 or 3 examples, never change the rules, because whatever the rule you are going to make will not be valid in all the cases. Now see, kids, dipole moment. See to it. See, when I was in class 6th, there was a girl in my class. Name was Dia Mirza. Dia Mirza. What was the name? Dia Mirza. DM. Whenever we were having lunch, in the lunch, she was always bringing kaddu. You know kaddu? Kaddu. Have you heard the name kaddu? Kids, have you heard the name kaddu? Kaddu. Kaddu is a vegetable. Vegetable. So, kaddu. She was always having kaddu in the lunch. For the lunch, she was always having kaddu for the lunch. What is this, kids? What do you understand by this? DM is equal to QD. DM is for dipole moment. Dipole moment. Q is the charge. And D is the distance of separation. Distance of separation. This Dia Mirza has come to my state from Dubai. She was in Dubai. Oh, Hema, your phone gone. Oh my God. Take someone else's phone, parents' phone. So, she has come from Dubai. Dubai means what? Dubai. Dubai is the unit. Dubai, Dubai, Dubai. Can you remember Dubai? Dubai is the unit for this. Kids, can you remember Dubai? Can you remember Dubai? And if I talk about its unit in MKS, 1 divided is equal to, yes, how much it could be? Kids, do let me know how much it could be. Let's see. Let's see how much it could be. 1 divided will be how much it should be. Let's see, kids. Everyone, let's see. 3.33564 into 10 raised power minus 30 coulometer. It's not centimeter, coulometer. Coulometer. Now, kids, one more formula you know very well. If I draw vector and if I apply formula, what is that? You must have seen this formula. See, kids, this is one vector, this is another one vector, and if I say this is the angle that is being theta, so this is vector 1, this is vector 2. So how to apply the formula, kids? You must have studied in physics also how to find out mu resultant. There is one formula to find out mu resultant, kids. What is that? Mu resultant formula, what is that, kids? Do let me know. That is square root of what? Square root of, just to let me know. Help me make it, kids. Square root of what? Mu1 square, mu2 square, twice of mu1 into mu2 cos theta. Right, kids? Is it right? Is the formula correct? Just do let me know. In the physics also you must have applied, kids. Help me. Help me. Do let me know. Kids, if you are able to get it, do let me know. Have you seen this formula? Do you know this formula? Mu resultant is equal to square root of mu1 square, mu2 square, twice of mu1 into mu2 cos theta. Just to let me know. No one is, only few students are able to understand. Kids, what are you doing? Hey everyone, are you listening? Mu1 square, mu2 square plus 2 twice of mu1 into mu2 cos theta. Can you see, kids? Okay, now how to apply this formula and how to solve this question? Any question? See, kids. First of all, if I say mu resultant and if I apply this formula, mu1 square plus mu2 square, mu1 square, mu2 square, twice of mu1 into mu2 cos theta. So see, mu resultant is directly proportional to cos theta, and we know that this is inversely proportional to angle theta. As you know that as the angle increases, the value of cos decreases. If I say the value of cos 30, the value of cos 30, how much? The value of cos 30 is 0.884250, like this. If I say cos 60, that is 0.5. If I say cos 90, it is 0. If I say cos 120, it is minus half. If I say cos 180, it is minus 1. Am I right? See, kids? See, the values written by me are right or wrong? Kids, do let me know first of all. Now I want to see, use the calculator and let me know the values I have written for cos. As the angle is increasing, the value of cos theta is decreasing. Just see whether the value I have written cos 30.8840 of 4. This is not 4, 8, 8, no, 8, it's 8.8660. Now it's fine. See, check it out. Check it out, kids. Hey kids, get some energy from me. Just to let me know 0.88602540. Just check it out. Cos 30.86602540, right or wrong? Do let me know. Kids, just do let me know. All the values are right. You can see Baba's maths. You can see Baba's maths, kids. Now, kids, so how to apply this formula? Let me tell you how to apply this formula. Just see to it. If the question is given like this is benzene, this is benzene, this is benzene. In the starting only, I am taking tough examples. Suppose if I place NO2 over here, here also NO2, 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 sorry, this was at ortho, meta, NO2, NO2, NO2. So remember that NO2 is minus M minus I. NO2 is minus M minus I means what? Minus M, or you can say minus R, mesomeric effect or resonance. M for mesomeric effect, R for resonance. And minus I, inductive effect, means electron withdrawing group. That means its vector should be upward side, that is, withdrawing, electron withdrawing group. So both, they are same. Now how to do this question? How many of you want that I should solve this question with formula, and how many of you want without formula, and how many of you want both? If you want to solve this question both ways, without formula and with formula, show me hearts. With and without formula, if you want to solve this question, show me hearts. Then I will let you know, kids. Okay, first what you want, without formula or with formula? First what you want, with formula or without formula? First what you want, with formula or without formula? See, without formula. Just consider this benzene as a car. Just consider this benzene as a car. Just consider this benzene as a car. Now, two people are pulling this car without petrol, so they are applying force like this. This man is pulling towards itself side and this man is pulling towards itself side. This man is pulling towards itself side, this man is pulling towards this side. This man is pulling towards itself side and this man is pulling towards itself side. This car can't move. See, both are having same power, but this man is pulling car towards that side and this is pulling car toward this side. So its resultant vector will be 0. Am I right? Because both are applying equal force but in opposite direction. Equal force but in opposite direction. Am I right? Am I right, kids? Now, here, which car will move fast? If they are pulling the car without petrol, what do you think? Which car will have maximum speed? First, second, third is 0. Already we got it, third one. Do let me know which car will move fast. They are pulling car first. So the dipole moment of first will be more than the dipole moment of second, and their dipole moment will not be equal to 0. Simple. So the dipole moment of first, then dipole moment of second, and then dipole moment of third. Decided without formula. I haven't applied any formula. See, kids, without any formula we have got it. Kids, have I applied any formula? Have I applied any formula, kids? Do let me know. Have I applied any formula? I haven't applied formula. This is known as the logic. Now, if I would have applied the formula, thank you, Laharika, thank you. Now see, if I would have applied the formula, then see what would have happened. See, if I apply the vector over here, this vector is going in this direction and this vector is going in direction. If I touch tail with tail, this is tail and this is another tail. Tail with tail, tail with tail, tail with tail, tail with tail, tail with tail. Just see the physics. Tail with tail, tail with tail, and tail with tail. This is and this is. Just see tail with tail, tail with tail, tail and this tail. Just see. Here the bond angle is how much? Here the bond angle is 60 degree. Here the bond angle is 120 degree. Here the bond angle is how much? Bond angle is how much? Tail. This is the tail. And with the tail, how to touch tail with the tail, kids? Kids, how to touch tail with the tail? Here in this case, it's 180 degree. Yes, tail with the tail. So I have to put this tail with this tail like this. See, this tail with this tail. Is it okay? Is it okay, my dear students? Now see, here the bond angle is 180 degree. As the bond angle is increasing, that its theta value is increasing, cos theta will keep on decreasing, so the mu resultant will decrease. The formula I have told you. Agreed? Agreed or not? Is everyone agreed, kids? The same thing we got. We got the same thing. Tail with tail. Always remember this, tail with tail. Don't forget tail with tail. Now kids, here the groups were same. If the groups were different, then what you would have done, see kids, once again, let's wait for a second. It's not working, kids. Just a sec, just a second. Just a second, let's see. Let's wait for a sec, kids. Okay, see kids. If the compound would have been given like this, then what we have to do, kids? What we are supposed to do, kids? See to it. Now, even the board got tired. The board is thinking, sir, how much time more you are going to take? See kids, if it would have been given like this, NO2 methyl, any electron withdrawing and electron donating group. Now this time the nature got changed. NO2 methyl, NO2 methyl. Now kids, remember that NO2 is minus M minus I minus R. That is electron withdrawing group. This is electron withdrawing group, but this is electron donating group, kids. Just try to understand. One is electron withdrawing, one is electron donating group. This is minus M minus R. NO2 is minus M minus R minus I. That is electron withdrawing group. But this is plus H and plus I, hyperconjugation and inductive effect. This is electron donating group. So earlier they were having same tendency. Both were either electron withdrawing or electron donating. They were doing the same effect. That will not cancel out. But here it's getting cancelling out, but not up to the extent is not exactly equal. Now this is NO2. This is methyl. One is donating, one is withdrawing. NO2 is withdrawing, methyl is donating. Yeah, without formula you can get this is the having the best resultant of dipole moment, because the same direction, that is just pulling and this is pushing. Pull, push, same direction vector is applied. This is going to have maximum dipole moment. But how to apply formula to calculate it? See kids, this is the tail, this is the head, this is the tail, this is the head. How to meet it, kids? If I bring near to this tail to tail, see how it would look like. It's like this, and let me bring near to this. So it will be like this. How? It will be like this. See, it will be like this. In this case, if I draw like this, and this is the tail, it will look like this. And in this case, tail with tail, what should I do? What should I do? Tail with tail. In this tail with tail, what should I do, kids? Do let me know. Tail with tail. How to combine tail with tail? Just see to it, kids. Everyone, do let me know how to combine tail with tail in this. Tail with tail. Kids, do let me know. I have to draw parallel. So definitely here the angle will come out 0. Here the theta angle will come out 0. So theta is 0, cos theta is 1. Isn't it? But theta is 0, so not defined. Not defined, right? But we can say mu resultant will be maximum. Maximum. Now here the bond angle is 120 degree and here the bond angle is 60 degree. So this is less bond angle, this is more bond angle. So you can see which is going to have maximum dipole moment, kids. That will have maximum. So third one will have maximum, after that this one, and after that this one. Clear to all of you, kids? Is it clear? So everyone got it? This is going to be having maximum. So A, B, C. I hope that everyone, is it clear, kids? You got it? 60 and 120. Just see, this is more than 90 degree. See, more than 90 degrees. So this is 120 degree. You can see, you can do one thing. You draw 360 degree bond angle and one balance is this side. So 120, 120, 120. Now you draw one circle and just see, this is the 1/6 part, 1/6 part, just the 1/6 part. This is just the 1/3 part. Clear? Is it clear to all of you, kids? Do let me know. And these are like this only, this only. So the angle is 0. So that is having maximum, than this, than this. CBA, CBA. Right, kids? Now I'm going to tell you some exceptional cases. I'm going to tell you some exceptional cases. See, kids. See. If we are provided with compound like this, now what do you think? Its dipole moment will be 0. Its dipole moment will be 0. The first option, second option, greater than 0. Do let me know. This is question number A. Everyone. 1,4-dichlorocyclohexane. Everyone, first or second option, first option or second option, kids, everyone, find out first option or second option. Maximum students are going for the first one, but the correct answer is second one. Now ask me why. This is not the clear picture. This is actually in chair form. Its correct picture is in chair form. It should be like this. Cyclohexane is chair form and it's not planar. It's not planar. And once it is not planar, then the vector will not cancel out. Either chlorine will be here or the chlorine will be there. axial or equatorial, we don't know, but dipole moment will be greater than 0. I think this is clear to each and everyone. Agreed? And this is known as the chair form of cyclohexane. This is chair form of cyclohexane. I hope this is clear to all of you. Chair form. Now, let me give you one more, and just do let me know what you say, kids. If I say this is B1, B, and if I draw like this, OH, OH, what will you say? Its dipole moment 0 or not 0? OCH3, OCH3, OR, OR, OR. What will you say? Kids, remember that they are having two lone pairs, and due to two lone pairs, the structure will be like this. Actual structure, dangling one won't be able to manage so all three, let me tell you, their dipole moment is not 0. Dipole moment is not equal to 0. They will have some dipole moment because of two lone pairs. Now if I write compound like this, kids, chlorobenzene, chlorobenzene. Now definitely it is having three lone pairs. So, and it is being planar because it is being benzene, it's not being cyclohexane. So its dipole moment will be exactly 0. Its dipole moment will be exactly 0. It is not polar compound. Are you getting my point, kid? Everyone, are you able to understand? Kids, do let me know. Everyone is able to understand. Now, if I say that I'm having one compound cis and one trans, who will have more dipole moment? This is cis and trans. Let's say A, and this is being B. Question is, which will have more dipole moment? More dipole moment. First option is A, second option is B, third option is can't say. Three options are there. See, it's actually third. Oh, third, can't say. A, B, can't say. A, B, C, kids. Some are writing 1, some are writing 2. So, most students are going for A, but the correct answer is, kids, third. How many of you want that I should prove it? Kids, you are getting failed again and again. How many of you want that I should explain it, kids? How many of you want? Do let me know how many of you want that I should explain it, kids. See, kids. C double bond C, CH3, H, CH3, H. Now, this is electron donating. This is also electron donating. donating. Definitely. One is the cis form. Cis form, definitely. Cis form's dipole moment is greater than 0. Fantastic. Now, if I draw the transform C double bond C, this is being CH3, this is being CH3, H and H. So, the same magnitude but in opposite direction, its trans dipole moment is 0. Trans dipole moment is 0. So, definitely cis is having more dipole moment than trans. On the basis of this, you would have given the answer, I think. You would have given the answer. But my dear students, this is not only one example. See, if I draw it like this, another compound, just see to it, this compound, C double bond C, H, H, NO2, CH3, C double bond C, NO2, CH3, H and H. Now see, NO2 is electron withdrawing, methyl is electron donating, they are in opposite direction. Methyl NO2 is electron withdrawing and this is pushing electron, same direction, magnitude. The hydrogens are on same side, these two hydrogens are same side, that's why it is being cis. These two hydrogen atoms are on opposite side, that's why this is on trans. Now what do you think? The vector will add, these vector will cancel out. Both are having dipole moment greater than 0, not equal to 0. It is having greater than 0. Its dipole moment is also greater than 0. But who is having better dipole moment, more dipole moment? Definitely the trans form is having more dipole moment. Here trans is the winner. Trans is having more dipole moment. Get C, more dipole moment. Am I right, kids? Am I making sense? Just to let me know. Most of the students, majority of the students, they have given answer that cis is having more, but either cis or trans, anyone can have more, kids. Got it? Everyone got it, kids? Do let me know. Do let me know. Everyone got it, kids? Is it clear to all of you? My dear students, do let me know. Everyone is getting, kids? Now, so this thing is very much clear to each and everyone. You are able to understand the dipole moment. Now I'm going to tell you Drago's rule. Now I'm going to tell you Drago's rule. That is very, very important. And how many of you are able to understand? Show me the thumbs up. And kids, at least hit the like button. Those are new. Kids, those who are new, hit the like button. I want to see it's 728 only, kids. At least show me the thumbs up and hit the like button. Now I'm going to tell you Drago's rule, kids. Drago's rule. Drago's rule. See, Drago's rule. What is the need of Drago's rule? Why it is being required? Let me show you. Let me tell you, my dear students. What is the need? If I say there is nitrogen and there is being oxygen, if I say that ammonia is there, H2O is there, fine. But the other family members, if I write nitrogen, phosphorus, arsenic, antimony, bismuth, And if I write like this, there are hydrogens PH3, ASH3, SPH3, BiH3, oxygen, sulfur, selenium, tellurium, only polonium. Now, if I write down H2S, H2Se, H2Te, my dear students, this class, the elements present in this box, they are not hybridized. Will you believe? These are not hybridized. No hybridization is there, my dear student. No hybridization is there. They are not hybridized. No hybridization. Let me tell you, kids. This is second period, first period, second period, third, fourth, fifth, sixth. And the group, if I say this is fifth, sixth group, they are not hybridized. Without hybridization, bonding has taken place. Will you believe this? All these elements are bonded without any hybridization, and number of questions, either you can say these questions are of P block, or you can say P block, in the reduced syllabus P block, certain limited properties are there which are given in the box, and they will be asked from here only. Now, if you see either P block, or you can call about the chemical bonding, number of questions the examiner is going to ask. Are you ready, kids? And can you believe they are not having any hybridization? Drago's rule says that third, fourth, fifth, sixth, these elements and the electronegativity of surrounding, for this electronegativity of surrounding atom should be electronegativity of surrounding atoms should be 2.5 or less than 2.5, right? And these should be from here only. Now, what is Drago's rule? Why the bonding is not taking place? And what are the consequences? Let me tell you, my dear students. Let me show you. If I talk about ammonia, its bond angle is 107 degree. Okay. But if I talk about phosphorus, arsenic, antimony, bismuth, then my dear students, if you apply the formula, somebody is asking what is the hybridization in pH3, everyone will say pH3. Oh, I know, phosphorus is having 5 electrons in the outermost orbit and it is bonded with hydrogen. You will apply steric number. Steric number is coming out 3 plus 1 lone pair, that is 4, and you will write over there sp3 hybridized. But my dear friends, each and everything is wrong. Examiner will give you 0 marks for this. Examiner will give you big 0 for this. This is absolutely wrong. It's wrong. It's wrong. Because pH3 is not having any hybridization. No hybridization is there. And once no hybridization is there, and due to no hybridization, the consequence is that its bond angle, its mosquitoes coming at this time only. I don't know from where they are coming. So everyone will write sp3. See, in the chat section I can see you're writing sp3. They are not hybridized. No hybridization is there. I'm waiting for the there no hybridization. No hybridization. Not hybridized. How the scientists started thinking for this? They have got the bond angle of ammonia to be approximately equal to 94, 93, 92, 91. See, 107. One lone pair, but 94, 93 is too much less bond angle. Bond angle is too much less. So this bond angle realized scientists to think about what is the problem with this compound. Now let's see how they are combining and how to find out. Just see, let me tell you how the percentage of S character you are going to get and how the questions can be asked. See kids, if I say ammonia, if you consider ammonia, what is the hybridization in ammonia? In the ammonia, the hybridization is sp3. That means all they are sp3. This is sp3. This is being sp3. This is also being sp3. This is also being sp3. Now all they are being sp3. That means this lone pair is having 25% S character. This lone pair is having 25% S character. Am I right? Now if I say ammonia, this is nitrogen, this is the lone pair, and if they are not hybridized, sorry, nitrogen, no, it's phosphorus. So atomic number is 15. 1s2, 2s2, 3s2, so 2p6, 3s2, now 3p, 3 I think 2 to 4, 6, 10 to 12, and 3, 15. Now 3s2 is like this and 3p3 is like this. Now Drago's rule is saying they will remain like this. They will remain like this. No hybrid orbital formation. There is no hybrid orbital formation. That means if I talk about phosphine, kids, if I talk about phosphine, this is 2s nearer to the nucleus. They are 2p. That means this lone pair is in 2s. 2s. There is no p character. It is approximately 90 to 100% S character, because there is no hybrid orbital formation. So this is pure S. Better to say this is being pure S, and S is maximum penetrated, and these hydrogens are forming bond with pure p orbitals. These bonds are being pure p, no hybrid orbital formation, that is pure p. Now kids, is there any formula? You will ask, sir, is there any formula to find out? Yes, there is formula. Just see, if I apply this formula, we can find out. But no need to go with the formula because that is not in a syllabus. But yeah, there is formula. See, what's that? Cos theta is equal to S upon S minus 1. This is the way you can find out the percentage of S character, and by applying this formula, the percentage of S character in this bond will come somewhat 2 degree, 2, 2, 2, 6. That means they are not having any S character. A percentage of S character will come out to be 2% only, 2% for this, 2% for this, 6% only. So they are being pure p orbital. Now, how this is going to affect our studies? Just see to it. Just see to it. If I say, once again, let's wait for a second. Board is tired. Board is also saying, oh my God, I got tired. Kids, how's the Josh? Let me have a glass of water. Let the board come its original form. Now after this, I will take 15 minutes only for oxy acids. Only 15 minutes. Kids, only 15 minutes, not more than that. Just 15 minutes. But show me how's the Josh. Kids, at least make it 750. You are not hitting the like button. Hit the like button, kids. Just 15 minutes more. 15, not more than 15 minutes more. Kids, only 15 minutes. And those who have not smashed the like button, yeah, don't go for reason, but let me tell you the application of this. You can remember, you can just remember. Let me tell you the application of Drago's rule. Application of Drago's rule. See, kids, if I compare basic strength, ammonia, this lone pair is having, this hybridization is sp3, so this lone pair is having 25% S character. But phosphine, if I talk about phosphine, kids, phosphine, if I say this lone pair is having approximately 90 to 100% S character. Now, if I say who is being more basic, on which lone pair it's easy to attack, who is being more basic, kids, do let me know. If examiner is going to ask who is being more basic, let me tell you one thing, that electronegativity of central atom, electronegativity of central atom is directly proportional to the bond angle, is directly proportional to the percentage of S character, percentage of S character. Now, this is having maximum percentage of S character. That means it is nearest to the nucleus. That is indicating it is nearest to the nucleus. It is nearest to the nucleus and it is far away from the nucleus. The one who is nearest to the nucleus can be snatched easily, and the one who is far away from the nucleus, that means proton can easily attack on this. Proton can easily attack on this and can't attack on that. So the basic strength of ammonia is more than that of phosphine, and that's why ammonia is basic and phosphine is less basic, or you can say acidic. This is very important thing which I am going to tell you, kids. This is being basic and phosphine is slightly acidic, slightly acidic. This is the first thing, kids. Now, if anyone is going to ask who can release its hydride easily, loss of hydride means loss of electron. Loss of electron means reducing agent can undergo oxidation. Do let me know, my dear students. So, once again, I am telling you, who is better hydride donor? Who is? Question is, which one is better hydride donor? Which one is better hydride donor? Better hydride donor. They can ask you this question. So, one is being ammonia. All the bonds, they are being sp3 hybridized, sp3 hybridized, sp3 hybridized, sp3 hybridized. This is also sp3 hybridized. Now, on the other hand, there is being phosphine. There is being phosphine, kids. Just wait for a second, kids. The board is saying, kids, hey, kids, just a second, just a second. Let's see whether it's working. Phosphine, whose this is pure S, and these bonds are being pure P, pure P. Pure P means there is no percentage of S character. These sigma bonds are being pure P. What do you think? Which bonds are being unstable? Which are loosely bonded? Who can let the hydride to go? Yes. Everyone do let me know which can let its hydride to go. So definitely this bond is weak. So this is better hydride donor. This is being better hydride donor, and this is better reducing agent. Is it clear to all of you, kids? Is it clear? Now after this, only one thing. Yeah, very good. Now after this, I'm going to tell you oxyacids. Yeah, very good. Only one thing is left, oxyacids. And after that, class will get ended. It's how's the Josh? Do let me know, kids. Let's have a glass of water, and then I will tell you the trick for oxyacids. And after that, I will end this class. The trick for oxyacids. Everyone, kids, you're not increasing the likes. Baba is giving you marvelous things, but 736, only 14 likes, we are away from 750. At least make 3 by 4 of 1000, 3 by 4 of 1000, kids. Already it's been morning. Now see, kids, oxy acid, fantastic, fabulous trick Baba is going to give you. Oxy acid. Baba's trick. Which Baba? Baba HSP. Baba HSP. Now, kids, do let me know one thing. One is us, one is ick. Let's start with the oxy acid of phosphorus. Let's start with the oxy acid of phosphorus. Okay, is everyone ready? Let me start with the oxy acid of phosphorus. Is everyone ready, kids? Let's start with the oxy acid of phosphorus. Phosphorus oxidation state, if I talk about oxidation state of phosphorus, that is, if I say if phosphorus is in +5 or +4, then we will call it ick acid. Remember that, ick acid. This is higher oxidation state. And if phosphorus is in +1, +2, +3, that is lower oxidation state, we will say us acid. Us acid. This is being lower oxidation state. One thing is clear, kids. Is one point clear? If its oxidation state is higher, like ferric, stannic, lower oxidation state us. So just remember, if somebody is giving a pinch, new pinch, if thick part, oof, you will say ush. But if thinner part with more force, ick and us, ick and us. Everyone, you got it. Now see, what else we have to find out, kids? Just see, what is the necessary thing required for oxy acid? P double bond O, OH. This is the necessary part. Rest of the things can be anything. This much is the necessary part for a compound to be oxy acid. This is the necessary part. This is the necessary part. Why this is the necessary part? Let me explain, kids. This is a replaceable proton. This is a replaceable proton. If it is going to lose that proton, that will do resonance. That is resonance in between this oxygen and this oxygen delocalization. So this electron is being delocalized. This is the conjugate base, and this conjugate base is stabilized by resonance. Conjugate base is being stabilized by resonance. SBR means stabilized by resonance. So this is an acid because acidic strength of acid is directly proportional to stability of conjugate base. Acidic strength of an acid, acidic strength of an acid acidic strength of an acid is directly proportional to stability of its conjugate base. More is the stability of conjugate base, more will be the acidic strength of acid. Now, once this thing is clear, now you must be thinking when to apply hypo, when to apply meta, when to apply ortho. This is the major problem. Now see, kids, let me tell you how to overcome with this problem. Remember that P double bond O, OH, OH, OH. This is the most renowned form of phosphorus. We can also say H3PO4. Now the oxidation state of phosphorus is how much? -2, +2, -1, +1 contribute, -1, +1, -1, so +1. The oxidation state of phosphorus right now is 5, and this is known as ortho phosphoric acid because maximum oxidation state. So ic phosphoric acid, orthophosphoric acid. Now, when to apply meta and when to apply pyro, just remember that if you directly heat it, definitely very high temperature it will require, approximately 600 degrees Celsius temperature it will require, but water will get released. If water is getting released from one molecule, we will say it is weak. See, P double bond O. Now water has been removed. So coordinate bond O and OH. Still it is being acid, but you have to say meta. Directly one water has been removed. Whenever from ortho one water is removed, you have to always say meta. Now, ic or us will be defined by its oxidation. See oxidation state -2, so +2. Coordinate bond is formed from electropositive to electronegative, so -2. Once again +2, -1, +1, +5. Higher oxidation state, meta phosphoric acid. It can be written as like this or it can be written like this. This is the monomeric form, so it will polymerize. So it can form HPO3 whole thrice, or you can polymerize to HPO3 whole N, because in this form it is being unstable. This is its unstable form. Now this is ortho, this is meta. How will you use the word pyro? Pyro is related with heat. Pyro is related with heat. That means if you take two molecules of this, the same compounds, if you are going to take two molecules like this, P double bond O, OH, 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 one more, P double bond O, OH, OH, OH. Now, by taking two molecules and removing water, it's easy job. This is easy job. Just remove water by heating. And if you're removing water with two molecules, definitely whatever the compound you are going to get, that will be known as pyro. Let's see. Water has been removed. This water will get removed at 100 degrees Celsius only, at low temperature only, heated. Water will get removed. Now the compound you are going to get, that compound is like this, P double bond O, OH, OH, and this one oxygen is there. Now P double bond O, OH, and OH. Just see the symmetry is there. Now definitely this is pyro. This is being pyro. Now us or ic, do let me know. Now the ball is in your court. Do let me know us or ic. What should I write? Should I write us or should I write ic? Nawab's World, thank you, you are still there. Which class? You are very good. very hardworking. Really, you are showing stupendous performance. Fantastic, awesome. Really hardworking. Ick. Because the oxidation state -2 +2 -1 +1. This is common, but -1 +1 -1 +1. You can see 2, 3, 4, 5. Ick. So pyro phosphoric acid. Now see kids, its basicity is 3, n factor is 3. Its n factor is 1, 1, 2, 3, 4. N factor is 4. Now kids, you must be thinking, so when to apply hypo? You must be thinking when to apply hypo, but first of all, let me write down because there is no space left. Once again, let me tell you these things and you have to help me. There was H3PO4. What I did, kids, to H3PO4, this was orthophosphoric acid. Now it's your turn. Do let me know. Orthophosphoric acid, kids. What I did to this, do let me know. I have gone two directions, one direction, one more direction. In one, simply I have heated and removed water with 1 mole only. I got HPO3 metaphosphoric acid. Now, in another direction, I have taken 2 moles of that and heated. Here also, water got released. This was 600 degrees Celsius. Tough job because this is unstable. So it will polymerize HPO3 whole N or whole thrice trimeric form. This is easy job. So 100 degrees Celsius only water got released and I have got H4 P2O7. This is known as pyrophosphoric acid, right kids? This much we have done. Now if I remove one oxygen from this, if one oxygen is less, what I will get? I will get compound like this, H4 P2O6. Now this is less in oxygen. It is having less oxygen. What is the oxidation state? I will use hypo. But ick or us? Do let me know, us or ick. Now the ball is in your court, kids. Do let me know, us or ick. Kids, do let me know, us or ick, what to use. Ick, very good, because the oxidation state you can easily calculate 4 into 1 plus 2x plus 6 into minus 2 is equal to 0. So 4 plus 2x minus 12 is equal to 0. So 2x, 4 and 12, 8. So x is equal to 4. So hypophosphoric acid. Now, if I remove one oxygen from here, I will get compound like this, H3PO3, known as, yes, orthophosphorus acid. Just see, am I right or not? Orthophosphorus acid, orthophosphorus acid. See the oxidation, 3 2 just 6 and 3. Only 3 is the oxidation state. That's why I have used us. Its another name is phosphonic acid. Its another name is phosphonic acid. Phosphonic acid, kids. phosphonic acid. Now, if I remove one oxygen from here, what I will get? I will get compound like this. H3PO2. Out of all these, this is most acidic. I've told you in the periodic table, but its name is hypophosphorus, or you can say phosphinic acid. Phosphinic acid. Phosphinic acid. It's this I have told you. Now, my dear students, someday I will let you know about dancing resonance, but dancing resonance I taught you in organic chemistry. Resonance also I've taught you in organic chemistry. The rest of the things already I have told you. Now, I've told you each and everything from the chemical bonding along with the tips, tricks, each and everything kids. And thank you. Thanks to each and everyone. We have started at 5 and really kids, Abhivadanam, Dhanyavad Alu, really greetings and thanks to each and everyone. You are really going to be the superb person, whether engineer or doctor, but really a very good person. It's I have no words to appreciate you. I have never seen such a great, hard-working students. Never, never I have seen, never. It's you are really very good, very hardworking. Really, I am saying thanks, and really, I am appreciating your hard work from my team, from my side, from each and everyone's side, kids. Thank you, kids. Thank you. Now I will do my dinner, kids. I haven't done my dinner. I haven't had my dinner because I was really making slides. If you like, you have liked my slides in the morning whenever you are going to wake up, kids, put the comment in the comment section later on in the morning or the afternoon how much you liked, how were the slides, quality of slides, the accuracy, each and everything, kids. Really, I will wait for your comments because these are the comments which are giving me energy to make more slides, to teach more concepts, more tricks without any error. 100% accuracy, kids, 100% accuracy. Thank you, Srinath, for taking care. Of course, Nawab's World, thank you. Thank you. Wherever you are, in at any place you are, my dear students, in any country you are, in any state you are, if you're liking, spread these things. You know, sharing is caring, kids. If you're sharing it to others, Almighty God is there to help you a lot. You are really lovely kids, my dear students. Definitely, God is there to give you the best strength, and I will pray to Almighty God to bless you with all happiness and prosperity, my dear students. Really, you made my day. I have started in the evening. I was thinking whether I'll be able to stand for such a long duration. Will I be able to cover each and every topic? But kids, your energy has given me that support. Your energy continuously kept on giving me that support, kids, that I'm standing continuously in front of you, teaching you, kids. One doubt. Yes, Priya Darshini, you can ask your doubt. Yeah, yeah. Nawab's World, thank you. Priya Darshini, you can ask your doubt. What's your doubt? Yes, what's your doubt? Thank you, Jifan Giving. Thank you, Irene Yeager, GM Eddie, Hema. Yeah, thank you, Nawab's World. Definitely after this lecture, going from here, I'm going to have my dinner, and that dinner is just like breakfast. We have to use some word. That dinner got converted into breakfast. Bye, kids. Bye. Love you, kids. Love you. Love you, kids. God bless you, kids. Really, God is there to give you all the best because you are hardworking, and the one who is hardworking, success is waiting for the such type of students. In the starting, it will look like that you are dying, but after some time, you will feel like reborn. Next chapter, definitely I will keep coordination chemistry or the salt analysis. Two out of these two, I will take one, either salt analysis or I will take coordination chemistry. Okay, in the chat section, not the chat section, sorry, comment section, you can write your opinion. What do you want next chapter, right? If you want salt analysis, then write down over the salt analysis. If you want the coordination chemistry, then you can write coordination chemistry. Wow. Toss, the fan gaming, Saucy from, wow, that's degrees in the degrees. Okay, kids. Bye to all of you, my dear friends. Bye, kids. I will share the PDF, each and everything. Right now, I can see 192 slides are there. I will take care of these slides. Yeah, this is complete. Sharbesh, I taught each and everything I have given. Thank you, Nawab's World. Thank you. Thank you. Respect souls. Thank you. Thank you. I'm not liking just to go, my dear students. You're giving that much of love, respect, but I have to go, kids. Everyone, just go and take a sound sleep. In the morning, we have a class, that is special class. Call your friends, tell everyone that in that class is for 90 minutes. I'm going to give you the best problems, the expected questions for your NEET examination. My dear students, that class is going to be the wonderful class. The timing is at 11. We'll start at 11 a.m. to 12:30, right? That is the timing, kids. So you have to come, right? Promise. In the morning, I will see you at 11, right? Bye, kids. Bye. Love you. God bless you.